Thank you everyone for waiting, and the attendance is looking pretty good right now, so let's get started. First off, we would like to thank you so much for taking the time out of your week and joining us on our 3-day training. There will be an hour-long live Q&A session at, or as we call it, open office at the end of 2-hour training each day. Just a quick intro, my name is Sonia Jones, and I'm an event manager at Capture 3D. If you have any questions regarding the upcoming training courses or webinars or any digital events or any events that we host, I'm your go-to person. So please feel free to contact me regarding our events. So we had our first virtual GOM Inspect training back in May, and it went great. So we actually received tons of requests for more of the same type of virtual course that allows everyone to download the software and get training on it. So we decided to host the GOM Inspect free training every month or two until further notice. But now that our new software version is coming out next month, this is going to be the last of our 2019 software version training. We'll resume free GOM Inspect training in a few months with the software version 2020. All right, so I'd like to welcome everyone again to our third GOM Inspect software training, and we really appreciate you tuning in today and giving us a chance to put something like this together and produce it and network and connect with you all. All right, so before we start, I'd like to go over who we are and what we do for those that are new to our technology. Capture 3D is the U.S. partner for GOM's solutions, and we have been partners with GOM for over 22 years now. And our Capture 3D family has been growing at an incredible rate, and we're just shy of 100 team members now. And we are headquartered in Santa Ana, California, with locations in Connecticut, Michigan, North Carolina, and Washington. And we are solely focused on GOM solutions and GOM's technology and software, which allows us to provide the highest quality of support and expertise to all of our customers. And just to give you an also idea of who GOM is, they are our partner and manufacturer of our systems, and they are based out of Braunschweig, Germany. They were privately owned up until May of 2019. And when it was acquired by Zeiss. So it's been a year since we became part of the Zeiss brand, and we are really, really excited about this collaboration. And a lot of those joining us for the next few days are our current customers, and we are happy to have you all participate. And many of you are already probably familiar with our 3D scanning technology and the lineup of our systems, right? So, but I did want to make a quick note that we just launched the new ATOS Q scanner right there. So basically, this is a brand new portable and compact and high resolution scanner for small to medium sized parts. And we actually hosted a launch event a few weeks ago for this ATOS Q scanner. And the launch event video is available for those that are interested to check it out. So basically what it does is the video shows unboxing of the systems, interviews with our customers, their feedback, and a lot of useful information packed in this video. So if anyone's interested in checking it out, please email at info@capture3d.com and we can send over the link. For those that are interested in seeing our technology, we are offering a complimentary demonstrations and proof of concept, whether online or in person, whichever you feel comfortable. Please feel free to contact us at info@capture3d.com just to learn more about it, or go to the link shown here, which says here, and the reason is you'll receive a copy of our daily presentation at the end of each day. So just one more announcement that I would like to make is that we host application-specific webinars or even industry-specific webinars every month or so. And it's just a 45-minute webinar with 15-minute Q&A session. So the next one up is in August 6th, which is actually next week, and it's on automotive industry. And the topic is about using 3D metrology technology to drive innovation in the automotive industry. And in this webinar, we're going to highlight how to use 3D scanning throughout all stages of automotive engineering, from design to production. And we'll go over the industry trends, latest technologies, real case studies, and such. So it'll be very information-packed webinar, and anyone is welcome to attend. So feel free to follow us on our social media to get updates on our events. Going back to our main topic, which is the GOM Inspect software. And as some of you know, this it's a very, very powerful software offered for free. It can be used as a powerful viewing tool for like sharing reports and projects and inspection within your organization at no cost. And basically anyone can download it and use it to share reports and inspect any 3D data. So you can also upload the data from any other measurement technology, such as like laser scanners, CT scanner, and other structured light systems. So also, as shown here, there are other paid software packages available, but you can see here in this chart that we have GOM Inspect versus GOM Inspect Pro. But for the most part, you can inspect your data and the part with the free inspection version. And there are countless features available in both free and pro software versions. The GOM software engineers normally work every day trying to bring more and more features and functionality to the software. And they are very positive to take feedback and requests into consideration from their partners like us and our users and end users like you guys for each new release of the software. And speaking of the new software, like I said, it's released in July or August timeframe every year, and we are expecting a major new release next month. Please, so feel free to ask your instructors, hosts about any of these features listed here, or simply send an email at info@capture3d.com. All right, so I'd like to remind you all that those who attend all 3 training days will receive a digital certificate of completion, which will be emailed to you guys by next week. And if you didn't fill out the training registration form on our website, we may not have your information to generate the certificate of completion. So please email at training@capture3d.com and provide us with your information so we can make sure you get your certificate. All right, so here is the list of the contents that will be covered during this 3-day training. We sent out an email with the information on day 2 and 3 and what to note, and there's a link to the class material, and also there's an empty folder where we'll be posting the presentations and then recordings each day at the end of the day. So please check your email and make sure you're aware of the link. All right, so if you have any questions, please email at training@capture3d.com again, and we'll further assist you. So there's one last thing that I wanted to note is that you all have this chat functionality on WebEx, so please leave your questions or comments in the chat. And there's a little trick there, so make sure you select either host, who is Sean, I'll introduce him later on, or everyone, or all participants. So there is somehow an option for all attendees. So when you send your questions to all attendees, panelists or hosts or presenters, nobody can see it. Only attendees or the trainees can see your questions. So you don't want that. So you make sure to select everyone or all participants. All right. Alrighty, so without further ado, I'd like to introduce your instructors for the next 3 days. We have Garrett as your main instructor, who is our lead application engineer at Capture 3D. He has a background in mechanical design, and he's been with us for 4 years now. We also have Sean Naniagas as your second instructor who will be monitoring the chat and answer your questions during the training session. So Sean has been with the company for 2 years now, and he has an industrial and systems engineering background. So both our instructors are based out of our California office, and myself is based in our Santa Ana office. So if you have any questions for your instructors during the session, please leave them below in the chat box. Like I said, Sean will address them while training is taking place, or for longer questions that can benefit other trainees, they will address them during the Q&A session. So before I hand it over to Garrett, I'd like to say we're really, really excited to have everyone come together and share the software with you. And thanks for tuning in.
Thanks again, guys, for joining us for our GOM Inspect training. As you saw, my name is Garrett Carpenter. I'm here with Sean Naniagas. I'm so excited, actually, that all my hair fell out. Woke up this morning and it's crazy. It's all buzzed off. So I don't know what happened there. But regardless, we're really excited to be here with you guys. Really excited that you guys were able to join us. We can get you guys through some of this basic GOM Inspect training. And so I'm going to be switching between this presentation. It's going to be sort of guiding us through the process that we're going to be doing in the software here. And then I'm also going to be going back into the software itself. So all of you guys should have the software itself downloaded. I hope at this point there'll be plenty of time to do that in the future. But let's go ahead and dive into some of these slides here, just get some of this background information out of the way. So the basics of the ATOS process, it's essentially a 3-step series here. We've got the step 1 is measurement, and we're going to touch on that very briefly today, but this is more of an inspection training, and so we're going to focus more on the software side of things. But regardless, step 1 is measuring with those ATOS sensors that Sonia introduced you to earlier in the slideshow. Step 2 is inspection, which again, we're going to be focusing on a little bit more heavily today. That's going to be doing all of our measurements, all of our geometry creations, GD&T, reporting, all of that fun stuff. Oh, I take that back. Step 3 is reporting. All the inspection and measurement and geometry creation is going to be involved in the inspection process. And then step 3 is our reporting and our table output data. So that's when you've done all of your creations, you've got all of your measurements done in your project, and you want to export that out as either hard data or as a PDF report. We'll show you guys how to do these steps 2 and 3, and then just again touch briefly on 1. So I want to briefly, real quick, show you guys a video of the measurement process. So again, this is step 1 in the process here, and I have just this basic video of the scanning process here. Hope this is going to play all right for you guys. This is our new ATOS Q, scanning one of our training artifacts here, our GOM block. And we just have this on our rotation table, and it's indexing between shots, so you can kind of see it blinking there, and it's taking pictures of this part, stitching all these shots together based off of reference points, which gives us a point cloud of raw scan data. That red colored data you see here on the screen is our data that we're collecting between each shot. It's the basic interface of the software, which you'll get more familiar with later on in the training. And then once we've got this point cloud here all collected, we're satisfied with the results that we've got here, we are going to polygonize this data, which we'll see here in the next step. So all of our data has been collected, moving up to the polygonize. And this is the post-processing. Again, it takes all of that random point cloud data, and then it does a whole lot of sifting through, sort of smooths out the surface, thins that mesh, gets a lot rid of outliers, and what we're left with is a nice high-quality mesh, which we're going to be playing with later on today. So that is step 1. So what the differentiation is between the ATOS systems versus other sensors on the market is that other systems on the market rely on the system of stereo camera collection, which means that the part has to be seen from both cameras. Both cameras have to see the surface we're going to be collecting on. Now, what's different about the ATOS systems is that we have this triple scan principle. And this is sort of the bread and butter. The magic between these ATOS systems is that we can collect with one camera or both cameras. And so it allows us to pick up data on more surfaces and these deeper bores, in some of these holes, some of these sharp geometries. And so really what you'll see with these systems that have this triple scan technology is that you're able to get a lot more data a lot faster. Coupled with the resolution of these scanners, we're able to collect a very large amount of data a very short amount of time. So before we jump into the software, I just want to remind you guys where all of our data is here in our email sent from Sonia, so I'm going to pull this up real quick. Everybody should have gotten this email from Capture 3D, the GOM Inspect training class material. So in here is going to be some instructions on how to access all the material, the training schedule. This information is here at the top. And then it also has logins for day 1, 2, and 3. Also at the bottom here is access to a link for the cloud where all of the data that we're going to be using is stored. And so if you did your due diligence beforehand, downloaded the data, downloaded the software, and checked out the schedule, you'll be well on your way here. So I'm going to be using all of the data from that link that Sonia sent. So I've got a little continuity. I've got this course content folder here, and this should look exactly like something you're going to get out of that Drive folder. So we've got our exercise projects and files. We've got our results and completed projects. So once we get through the day's worth of projects, you guys will have completed projects here. So if you happen to jump in on day 2 or 3, you're not going to be days behind. You can just grab one of these projects and hop in line with us. And then at the end of each day, the presentations and the recordings are going to be uploaded to these links in this folder. So if you guys want to rewatch these videos or go through some of the information, you'll be able to find it in this link. Also, if I say something embarrassing or wrong, it's going to be immortalized forever. So that's always a plus. Okay. We also have some additional training material on our YouTube channel. We put out a lot of videos on how-to for basic functions in the software. And these are hosted by the engineers in the company. So if you've had a demo, or if you've worked with one of these engineers, or if you've had some online support before, chances are you'll recognize some of these faces in these YouTube videos. There's a lot of good information in here, a lot of good how-tos. It's a good supplement to people who are just learning the software, or alternatively, if you're a user for the software for a long time, there's always some good tips and tricks that you can learn from some of the engineers. Additionally, we have the GOM Training Center. The GOM Training Center is a resource put on by GOM, the manufacturer of all these systems. And this is going to be information straight from the source, straight from the manufacturer. So all this stuff is a lot more technical. It's a little bit more in-depth. It's a little bit longer, but there's a lot of really good information in both of these resources. So if you're just getting into this, or if you're a user from a long time, there's a lot of good information you can glean from both of these resources, along with these online trainings and these webinars that we're going to be hosting. So why don't we go ahead and jump into the software here. This is going to be our introduction to GOM Inspect. So GOM Inspect, just before we get in here, is the free version of the software. There's a couple of different versions of the software. We're going to be using GOM Inspect. You may have seen earlier in that slide the GOM Inspect Pro, which is the paid version. This is the free version of the software. It's pretty powerful. It's going to give us a lot of functionality in here. I'm going to be using the free version as well, so it should look exactly the same as your guys. We're going to be using 2019, and I believe it's hotfix 6 or 7. We'll be able to see that when we open up the software. But regardless, if you've got that software downloaded, it should look exactly like mine. So let's go ahead and open up our software, and let's get to our main screen here. So when you double click that icon, this is our GOM Inspect main screen here. This is just the basic page that allows us to travel to different avenues of the software here. And real quick, I just want to introduce you guys to these 6 different tiles here on our main screen. A couple of these are pretty self-explanatory, but at least want to touch on them briefly. New project is going to open up a blank, fresh project for you. Open project is going to allow you to open a project that you've saved on your computer or network or wherever your computer is mapped. Anywhere you have access to, you can open projects from there. Sample data is a collection of pre-generated projects. We use these a lot of times for our demonstrations, or if we need to show an example of something. We've got a lot of these sample data projects that we can access real quick, and it's a complete project with reports and all the scan data and all this different information. The project templates, unfortunately, is a function that is reserved for the professional version of the software. Now we'll touch on that later in the version, or later in the training rather, on what we can do with that, how to create those, the limitations, when you'd want to use those. But unfortunately, it's not something that we're going to be able to create here in our free version of the software. Regardless, when I talk about templates, if you have the free version of the software, this is where you can open them up from. Directly to the right of that is our recently used projects. So much like Open Project, it's going to show a list of projects that are saved on your computer that you've used recently that you can open back up. And finally, we have the GOM Community. Now, the GOM Community is another great supplemental resource for a lot of great information. We've got the GOM Training. This is going to take you to the GOM Training Center with a lot of different videos, and I believe there's some quizzes and knowledge-based stuff in there. You've got the manuals and tutorials, which takes you to the GOM support site where you can download manuals and tutorials for your different versions of software, the different sensors you have, the different measurement accessories. So So anything GOM related, you'll be able to find your manuals and tutorials in there. The forum is, as it suggests, a forum dedicated to all this different technology. Now there are GOM employees who are tasked with monitoring this and answering questions. So it's a very lively forum. It's a really great place to get questions answered really quickly. And again, it comes straight from the source. So this is really good in-depth knowledge. Knowledge base is a really cool resource that allows you to access a list of frequently asked questions, like, why is the light blue, or what is fringe projection? How do I do alignments? Just very basic, easy functions in there. There's a lot of quick, easy articles in a knowledge base. Sample data we went over before in that previous tile. This is another way to access it. And then the release notes is going to tell you what each of the different versions of the software, how it changes. So each different updates. So we're in software version 19, so it'll tell you how that update, or how that changes from software version 18. And then you've got all of these different hot fixes, and it's going to tell you what it's fixing, what it's adding, all the different little bug fixes that it's doing. And so that's a great resource to check out every now and then just to see how the software is evolving. So let's go back to our start menu here. And if I'm talking or moving too fast, go ahead and shoot Sean a message and I can slow down. We'll have time to re-explain some things near the end. If you guys have questions, go ahead and ask those to Sean as we go. But let's go ahead and open up a new project here in our software. We're just going to open up a blank, fresh project. So we've got our top left tile here. Click on New Project. And we are met with our blank screen here in the software. So we have no data in this project. We have no measurements. We have no alignments. There's nothing. This is just a very blank, basic version here. But I want to go and show you guys around the screen here and just show you guys some of the different functions in this software. And then once we start bringing in data, we'll be able to start exploring some of these functions a little more in depth. So starting in the top left here, we've got our drop-down menus: File, Edit, View, Construct, etc., etc. And each of these are going to remain static no matter where you're at in the software. So you'll always be able to find these drop-down menus. So there will be some functions that we grab out of these drop-down menus, and you'll be able to find those functions no matter what workspace we're in, which is a good segue to introduce you to the workspaces. So workspaces is our list over here. We've got these 3 horizontal bars. Now yours may be collapsed like this, or it may be pinned like this. You can change that again by just clicking this pin, unpin workspace over here. I'm going to pin mine and leave mine open over here just so it's easier for you guys to see which workspace I'm in. Now I want to reiterate really quickly the workspaces term that I'm going to be using, because that's a very, very specific term in our software here. So when I say I'm in the digitize workspace or the reporting workspace, I'm referring to these workspaces over here on the left. Now what's also useful about the workspaces is that as we switch workspaces, it's going to change the color bar on the top here. So we've got this nice purple color for our reporting, go to this nice brown color for the inspection workspace, and then for our start workspace, it changes red. So that's another easy way for you guys to match up if you're not seeing certain functions in your workspace bar on the top here. Just go ahead and take a look at the color bar and then make sure that you're in the same workspace as me. So just like to reiterate that early on. Workspaces refers to these different tabs over here on the left. So we've got our workspace selection. Now in each different workspace, as I mentioned a little bit ago, we have specific functions in them. Now they're specific to what you'll be doing in the workspace, and in these workspaces, I'm going to see how many times I can say workspace for this training. But if you hover over these, each of these have a different core function to them. So mesh editing, reporting, and inspection. And then we have these tools here in the colored toolbar on the top that correspond to what you'll be doing in this workspace. So surface comparisons, inspection sections, and on and on. And we'll be exploring those when we start bringing data in, getting further into the software here. But I just want to introduce you to these drop-down menus in the top, the workspaces bar over here, and then the workspace tools along the top of the screen. Now also on the top of our screen, we have our Try Professional button here. Now if you get into this training and you like the software, it's something you think you'll be using in the future, or if you're looking at purchasing one of these systems, you want to try out the professional version of the software, by all means, try out this Try Professional button here, and it's going to open up a form that you just fill out with some of your basic information, the company you're with, and they will send you a license for a 30-day, I believe it's 30-day trial for the professional version of the software. Pretty sure it's 30-day, don't quote me on that. But again, if you like the software and you want to try out the full professional version of it, that's a really great way to try it, and it gives you all the functions of it. Now, directly to the right of our screen up here, we have our skins, and our skins is essentially a template for the software. We've got a couple of different skins that we can choose from, and these skins are just going to populate certain drop-down menus. It's going to show certain information in our iInspect wheel. We're not going to be changing this, really. We may touch on exporting and creating skins later on, but really, as long as you were in the inspection skin here, we're just going to stay in that. We're not going to change too much of that. Now, directly to the right of our skin selection is our direct help menu. Now, this is a really, really great resource in the software. I want to emphasize that also because I will likely be using this to help answer questions later on in the Q&A, or if I have some quandary about one of the functions in the software, I'm going to use this direct help bar on the very top right here. So definitely a great resource. Now, any function you have, I guess I should probably spell it the right way, right? Let's look up RPS because I know that's an alignment. So RPS alignment, say I had a question about that, we're going to touch on that later on. It gives you this really great article about all the information going into what you need to create it, all the different menu items, how it works, the workflow when you're creating it, all this different information about each of these different functions in the software. Now, you can also access the direct help article by clicking on the question mark in any of the dialog boxes that we have open. I'm pretty sure almost any function in the software has a little question mark next to the X. And so if you click on this, it's going to take you to that direct help menu here in the software. So super great resource if you're early on, you just need to know how these functions work, or if you need some help getting through some of these functions. Again, you can ask Sean. We'll go over these in the Q&A. But I would recommend that your first action be just go up to that direct help and just search out the function and just see if it's got the information in there that you need. And then directly to the right of that search bar is this GOM button here. And this opens the GOM website and again gives you access to all those manuals and knowledge base articles, all this different information. Directly below that, we've got our alignments. We can either create or choose our alignments. We'll go over that once we start bringing some parts in. Down to the right side of our screen, we've got our properties menu that we can open or close. Bumping our mouse over to the right side of the screen, pull out that menu, collapse that menu, and the hotkey that I'm going to be using for that is the tab button. So if you don't see me clicking anything over there and you see my properties menu pop up here, I'm using the tab button. I believe we go over hotkeys later on, and there might be a hotkeys list in that folder that Sonia sent out. Regardless, there'll be a couple of hotkeys that I'll use, and I'll emphasize that whenever I use them. There'll just be 3 or 4 that I use, but tab is going to be one that I'll use to pull up this properties menu. Now, directly at the bottom of the screen here in this grayed out toolbar, these are a bunch of our different selection tools by default. And if you hover over them, you'll get to see what each of these functions are. And they're a little bit nonsensical right now, and we don't have any data in here. But what's nice about this toolbar down here, aside from the fact that we can collapse it, is that we can throw any of our functions down in there. So if there's a function that you find you use a lot more, you can go ahead and click and drag it down there. Alternatively, if there's a function you know you're not going to be using, you can grab that guy, drag it into the trash can, unless it's paper or cardboard, and then recycle it. So that is our interactive toolbar down at the bottom of our screen here. And then to the left is our viewing cube. Again, it doesn't make as much sense to demonstrate this without data in here, but I just want to illustrate the point that you can grab any part of this cube or any of the axes arrows to square up in that axis on your part. And we also have rotational degrees of movement. And once we bring in some parts, I'll show you the different rotation modes and the reset zoom. Finally, it takes us over to the left side of our screen here. There's a couple of different important functions on the left side. The top part where it says no elements is our Explorer. And again, I'll be using that term. The Explorer is where it lists out all of our geometries, all of our alignments, all of the data that we bring into the project. This is going to be a busy part of our software here when we start getting into the actual inspection. I'm going to try and make a point of swinging back and showing you guys how this Explorer changes and expands as we work on this project. Directly below that is our Sub-Explorer. Our Sub-Explorer is an organizational tool for our Explorer. So we've got a couple of different ways to explore this, or to organize this information down here. By default, it is relates to. You can see it just says relates to here. So anything we have selected either on our screen or our Explorer, any elements that relate to that are going to be listed down here in our relates to sub-Explorer. Alternatively, you can grab this plus button down here, and you can grab a bunch of different ways to organize this data. And again, without anything in here, it doesn't make as much sense, but I just like to emphasize again, Explorer on top, sub-Explorer down here. I will be circling back to those and re-emphasizing those again a little bit later. And then last, but certainly not least, we have our status bar on the top here. And the status bar is going to be really cool once we get into the software and we start building things. It's going to help tell us where we have errors in our software, where there's things you can sort of streamline, where there's things that don't make sense. And again, I'll circle back to that as we start bringing data in. So let's real quick jump back to our software here and just catch up on our slides. So again, we've gone to our start screen. We've gone over those 6 different tiles, what they do, what they hold. We've clicked on our new project, brings us into our blank inspection workspace. And we've gone over a couple of different functions on our main screen here. Again, this page is going to be available on that report, which you guys will be getting in that folder. So if you guys need to jump back to this at any point, by all means, go ahead and look at that. But I also believe, real quick, you look up graphical user interface, or GUI here, it's also going to bring up this diagram here in the direct help. Look at that, using the direct help already. What a useful function. Okay, shortcuts. Here's what I mentioned earlier. You'll have to remember all of these, so real quick, go ahead and write that down. Just kidding. It's one of my favorite jokes, though. We're going to be using some of the hotkeys on this list, but this is a very busy way to look at it. So instead of referring back to our PowerPoint here, I am going to just show you in our software. If we go up to Edit, Application Settings down at the very bottom, and Shortcuts down at the very bottom here. This is going to give you a list of all the different hotkeys, and there is a lot. But like I said, I'll only be using about 3 or 4 of them when we go through this training, and I'll make sure to tell you guys which ones I'm using, and they'll make sense at that point. And then if you get in the habit of using just a few hotkeys, it really makes your efficiency in the software a lot better. It helps you develop good habits. So here's our edit shortcuts. Again, if you switch through these functional areas, you've got different ways to, or different hotkeys that do different things. I don't want to get too much into this because there are other more important things to learn as a beginner user than just creating shortcut keys. So real quick, let me jump back to my PowerPoint here. We're going to do a live demonstration of our mouse functions, but that doesn't make terribly much sense unless we start bringing data in. So I'm going to break the rules, and I'm going to skip a step, and we're going to go right to importing mesh in CAD, and then we're going to swing back and we'll go over some basic mouse functions and how to use that viewing cube in the bottom left of our screen. So I'm going to go back to my software here. I'm going to open up this folder that Sonia sent out, and we're going to go to folder number 1, exercise projects and files. We've got 2 folders in here. We've got our actual and we've got our nominal. Now, these are important differentiations in the software here because I'm going to, again, use these 2 different terms. Our actual refers to our scan data that we've collected of the part. It's what the part actually looks like. The nominal is the CAD file. It's the theoretical perfect surface of the part. It's what the part is supposed to look like exactly. And the actual is what it looks like in real time. So let's go ahead and grab either one of these first. So I'm just going to click, drag, drop right here in the software. Anywhere on the screen here, we're going to import the file, and I'm going to import as a new part. And you'll see we now have a part menu over here in our Explorer. So if I expand my part list here, I see I have my mesh. And what a beautiful mesh it is. So now that we've got our mesh file in here, let's go ahead and bring in our CAD file. We're going to do the same method to bring this guy in. I'm going to go to my nominal folder, click, drag, drop. And now we see that I have 3 options. I've got a new part, add to part, or jump to my clipboard. The new part is going to create a new part over here on the left side of my screen, which I do not want to do. I want to add this CAD to my mesh file part. So I'm just going to say add to part. And these are just different parameters to bring in our CAD. I'm going to leave all this as default. If you have a reason or a direction to change these, go ahead, but I'm not going to. I'm just going to say OK, leave this as default. We've got this coordinate system that came in with it. I'm going to hide that with my I key. My I hotkey is just invisible. And so now I've got the basis of any good project. I've got a mesh file and I've got a CAD file. Now that we've got both of these in here, we can start doing some basic inspection. Now again, over here on the left side of our screen, our Explorer, we've got our CAD file, we've got our mesh file. We've also got this toggle view over here, so if I want to turn the visibility of either one of these off, we can do that. Now, you may notice that these are not lined up in space. We start doing some inspection on these guys, we're going to have a heck of a hard time. And so what I want to do really quickly before we show off any of these other functions, I want to start off by making a very basic pre-alignment. Now you can find your alignments up here in the top right of your screen with the plus button. Go to create alignment, and our initial alignment is going to be our pre-alignment. Now the pre-alignment is a global best fit. It takes all of the points of the mesh, all of the points of the CAD, and tries to reduce that deviation down as low as possible. Now this isn't an end-all be-all alignment, and generally this isn't the alignment that a lot of customers or a lot of people or a lot of users will use for their main inspection. They're going to be using some other alignment like an RPS or a geometric element. You're going to be basing off of datums and stuff. But this pre-alignment does a really great job of bringing these two parts together, reduces that deviation, gets them close enough that you can start doing a lot more inspection on them. There's a couple of different functions in this pre-alignment menu that's easy to use. Namely, there's this search time. This is how long you give the computer, the software, to crunch down these numbers. On a more complex part, you may need to go for a longer search time, but on this very basic part, it will work on a normal, short, or long search time. And we've got our additional help point. And so if you've got a part like a gear or something cylindrical that doesn't have a whole lot of information on how to clock it, you can use these nominal and actual points. That allows you to just, control left click somewhere on the CAD and then control left click somewhere on your part. Again, keep in mind where you're looking on this. And it's going to line up those two parts and align everything else around them. As it is, you shouldn't need these help points for this part. Just open up your pre-alignment. It should snap together. Go ahead and hit OK. And so now we have got our two aligned pieces of data. We've got our CAD overlapped with our mesh. Now, these have two distinct colors to them, and that's going to help us differentiate between the CAD and the mesh file. And I'm going to reiterate that later on in the training as well, because I don't want you guys to get confused and start building things on the mesh or building things in the CAD. We're supposed to be building things on mesh, yada, yada. This nice beige color is our CAD. That's our nominal data. And this gray color is our mesh. This is our actual data. Now, what I'd like to do for some of my basic trainings that I'm hosting is I like to change the color of my CAD model to a blue and the color of my mesh to a green, just so it coincides with the left side of my screen up here. Whoops. So you can see on the left side of the screen, we've got our CAD and a blue block next to it, and our mesh and a green block next to it. Once we start building things in our project, anything relating to the mesh is going to be green, and anything relating to the CAD is going to be blue. So to change the colors of these, if you think this is something that would help you, you can click on the part, either the mesh or the CAD, hit your tab button, or bump over to the right side of your screen, open up your properties, and go to your display, and just change that front side color. So again, we're in our split display tab in our properties menu. Front side, if you want to turn that CAD to a nice blue, and then change your mesh to a nice green color, just to help you differentiate. I am going to not do that, even though I just said it's a great idea, just so that what I'm showing you guys here lines up with what's on the PowerPoints. But if you're having trouble differentiating between the CAD and the mesh, changing the color of those is a really great idea, just to help you visualize them a little bit better. So anyways, back on track here, I want to show you guys a couple of the different mouse functions, and I want to show you guys the viewing cube down here. So if you brought in these two files and you aligned them, chances are you've got a little bit of practice looking at your part with your mouse here. But we have these functions in here, and Conveniently enough, every CAD and inspection software uses the mouse just a little bit differently, so you'll probably have to spend the first couple of minutes in the training here just getting used to the different functions of the mouse. So we've got our rotate part with our left mouse button. If you'll notice this little white square, wherever I click my mouse, that's going to be our point of rotation. So if you grab it somewhere in the corner, it's going to rotate a little bit differently than if you were to grab it somewhere on the middle of the part. So that's our rotate with our left mouse button. We've got our scroll wheel. If you press the scroll wheel, that's how we're going to be able to pan. So that scroll wheel is pan. Pressing that scroll wheel is pan. And then zooming in and out is scrolling with that scroll wheel. And then I believe they say something about the right mouse button. Yep, so menu selection. So if you right click something, you've got a couple of different functions in here. And depending on what you're clicking, it'll have different functions. So those are the basic functions of the mouse. Again, it might take you a few minutes to get used to it, but if you're used to using CAD softwares in the past, this shouldn't be anything terribly new to you. So let's try out our viewing cube down here. I believe it has a way more technical name than viewing cube, but that's just the first thing that always comes to my mind. So I'm just going to keep calling it a viewing cube, and if you get used to hearing that, then maybe you'll know what it means when somebody else says, oh, it's the quadrahedron, vector analysis tool. Oh yeah, that one. Anyways, so again, I had mentioned that we can grab any part of this cube to view in that direction. So go ahead and try just grabbing as you highlight on your cube here. You can see little sections of the cube highlight in gray. So it's allowing you to square up on those axes of the part. Again, you can also grab the arrow and it will square up in that direction. If you need to rotate your part, you can use these pie slices up here to rotate your part certain degrees. And then we also have these two functions underneath the rotation. We've got our rotation mode, which locks rotation in a certain axis. And as you rotate this guy here, it's going to rotate along just that axis. So kind of useful if you've got certain parts that are very cylindrical or long and you need to just rotate along a certain axis without having to use this rotate tool. And if you click, it will lock on a different axis. And then if you click that fourth time, it will unlock it. So it just cycles through each of those. So if you're stuck on one of these, just go ahead and keep clicking until you get down to that. Now, one of my favorite tools, because sometimes I have a chronic spaz finger with the mouse, is this reset zoom tool. Now, if you're using a mouse that has a toggle scroll wheel and you zoom out, so you're looking at it from the Earth's or the moon's orbit and you can't see your part at all, you can use this reset zoom tool down here and boom, brings your part right back up to you. So that's very useful. I find that tool to be very handy sometimes. So again, that's our viewing cube down here. That's some of our mouse functions. And that's just the basics of bringing your part in, moving your part around, aligning your part. You can also view the origin of your part by pressing F10. F10 brings up this part's origin. And you can turn that off by hitting F9. So F9, F10. Okay, so let's jump back to our handy PowerPoint and see what we're on to next. I think I'm a little bit behind, so you'll have to forgive me if we run a few minutes over, but I'm going to try and stay on track. Selection tools, awesome. We'll go into selection tools and the mesh editing workspace. Okay, great, so those two segue into each other. So jumping back to our software here, we are currently in our inspection workspace. Again, I'm hovering over here on the left side of my screen, over on our inspection workspace, under our workspaces tab here. Now, the first thing I want to do to demonstrate some of these 3D selection tools is I want to make my mesh exclusive. And I'm going to do that by using one of my aforementioned favorite hotkeys. Now, you can do this by either clicking on the mesh here in your screen, or you can click on the left side of your screen in your Explorer. So I just want to make sure that my mesh is selected, it's highlighted with gray, and we're clicking on it. And hit E, the E key, E for exclusive. So there's a couple of hotkeys that make a lot of sense, and there's a lot that are a little bit harder to remember. So I'm going to use the E hotkey to make my mesh exclusive. Now it works for anything over here in our Explorer, so if I want to make my CAD exclusive, click it and hit E. Alternatively, you can click and drag it out, show element exclusively, but the key word here is that we want to make our mesh exclusive. So click on it, hit E, turn off your visibility of CAD, or just click and drag it out. There's a bunch of different ways to do this. We want to see just our mesh, just the mesh. Click, hit E. So now that we've got our mesh out here, let's go ahead and try some of these different 3D selection tools. We can find our 3D selection tools in our Edit menu, down about halfway through this menu, and Selection in 3D. We've got a bunch of different selection tools in here. Geometry-based selection tools are great for selecting geometry-based selections. So I've grabbed a plane up here in the top of this cylindrical geometry, or I can go, again, Edit, Selection in 3D. If I want to do, let's see what's a good one. Surface, select / deselect on surface. This is going to allow us to grab our part with this lasso tool. This tool is a little bit awkward to use at first, so this will definitely take a little bit of practice if this is one of the tools that you guys think you'll use more frequently. And again, if you find a tool that you think will work well for you, by all means, click that guy, drag and drop it right down here into your toolbar. So from now on, I'm just going to use some of these tools on my toolbar, but again, if you need to find those tools, Edit, Selection in 3D. So I've got a couple of different things selected. If I want to deselect them, I can use this Select, Deselect on Surface, and I can click left mouse button to create a polygon, or I can hold it and make an organic shape. And then once I've got my selection, I still have this hang on green line here. Hold your right mouse button, and you've got three options. You've got plus, minus, or X. Our plus is going to create a selection. Our minus is going to deselect. And then our X is just going to cancel out of this function. So in this case, I want to just let go of my right mouse button over the minus here, and it's going to deselect anything in my polygon. So I've got just this top surface of my geometry still selected here. I can also use this deselect all function. So if you hover over each of these functions, it's going to tell you what each of them are and allow you to sort of explore the different ways to use these 3D selection tools. These take a little bit of time to get really good with just because they do distinctly different things for each. So I'm not going to spend all day telling you guys how each of these work individually, but we'll use a couple of these different ones as we go through the training. So at this point, I'm just going to hit this X, the deselect all, and it just deselects everything I had previously selected. Okay, so that's just an introduction to our 3D selection tools. In our presentation here, we have this list of all the different selection tools, which looks pretty busy. This is just all of them smacked onto the screen here. You'll just go through each of those lists and grab which ones you want to use, the time you're going to use them. But we will use a couple of them when we get to our next function, which is the mesh editing workspace. So far left side of the screen here, I'm going to hover over this bottom icon, which is mesh editing. Our mesh editing workspace is a big reverse engineering tool. If you need to make watertight models, or if you need to fill holes or smooth surfaces, this is going to be a great function for you guys to use. Now, the big caveat to this is that technically you're falsifying data. So if you're going to be doing a lot of in-depth inspection, or if you're using these in production or something, you don't want to be mesh editing this data. The better alternative is to just make sure you have enough scan data and good enough quality scan data on your part that you don't need to use these mesh editing tools. But if you've got parts that you're going to be 3D printing and you want a watertight model, these tools are going to be great. So let's just go over a couple of these guys here. The first one at the top of our screen is we've got our close holes function. Let's go ahead and click on that, go to interactively. And this is just a dialog box that shows, or that allows us to close holes in our part. This will be a great one for reverse engineering if you're making a watertight model. So we've got this missing sliver of data here on the edge of our part. And so I'm going to follow these commands down here in our gray toolbox at the bottom of the screen. We're going to control and left click to fill completely. Make sure to click a boundary. We're not clicking in the hole, and we don't want to click too far away and fill something else. Hold control, left click somewhere near the part on the boundary. Click on that guy there. We have this nice dark gray patch of data. Now it's sampling the area around it to make this a nice accurate patch on the part. So you can increase that selection area around it by the delete neighborhood. That's how far around that part it's deleting it and then reapplying a patch while it's deleting it, sampling that area. Kind of a misleading term, I think, but once you sort of understand what it's doing, it makes a little bit of sense. So we're just going to go with one delete neighborhood just to grab a small sampling of this part. We can change our filling results if you need to between rough, plane-based, normal, smooth, yada, yada. I'm just going to stick with normal. It looks great from there, and I'm going to hit apply. So now we've closed up this hole on our corner here. We've applied a patch there. We can also do this on these holes I believe are supposed to be here on the part, but just as practice, I'm going to control left click this guy here, and it applies a patch on this part. And as you adjust some of these settings, you can check the quality of your hole being filled here. And then again, you've got these filling results. So I'm actually just going to close out of this without applying this, just because I want to show you guys another instance of doing that. So that is our close holes function. If you go back to this and use the automatic, I'm not going to show you this because I don't have any other holes in this part to close up. But this dialog box is a little bit busier, but what it's going to do is it's going to allow you to set parameters for what hole sizes and number of edges to fill, and it's going to select your whole part, and it's going to do a little thinking, and it's going to try and fill all of these bits of missing data or these holes in your part automatically. It's a pretty slick function, but you've got to be careful because it can sometimes fill holes that don't need to be filled, and there are certain limitations to it. So I'm going to close out of this guy. I'm going to go over just a couple of these, and then if you guys have questions about some of these other ones, we can revisit them later on in the Q&A. The next one I want to go over is the smooth mesh. This one's relatively self-explanatory, but if we use our select on surface tool down here, and again, I had mentioned before that for a lot of these mesh editing functions, we're going to be using our 3D selection tools. So this is a good segue from introducing you guys to those tools to the mesh editing because it sort of uses the same functions. So I'm going to go down to my select deselect on surface tool here, and I'm just going to grab an area where I see some deviation. I just zoomed in on an arbitrary part here. As long as you can just find some place that has some deviation on the surface that you want to see how this smooth function works, I'm going to right click, say plus, so I can select this data here, and you can see it turned red and then blinked gray, and it changed that data a bit. You also have these different functions on how to adjust this part, so our filter radius, our detail sharpness. Again, if you change those, it's going to change how this part is smoothed out. I'm going to apply this guy here, close this. So that's a pretty slick function. If you've got a machine surface that you're getting some reflection on, a smooth mesh tool is going to be a really handy one for you guys. And then our thin mesh is a really great tool for reducing the number of points on our project. Now I'm going to first click our part, hit tab, and turn on the mesh structure so you guys can see all the details on our part. And these are all these vertices, these triangles are the points of data that we collected during the scanning process. So super high resolution part we've got here. And again, I'm going to go down to this select on surface function. I'm just going to grab a random patch here, and I'm going to just grab some of this, and then we can see that we're reducing the number of triangles on our surface. So we can change our surface tolerance if we need it to be tighter, or if we want more or less points on here. But you don't have to grab just patches of the part. If you want to grab your entire part, you can reduce the size of your entire part, which makes it easier to transfer, easier to back up on your networks. A lot of different benefits for having a thinned mesh. Now, the polygonization process, when you take your raw data and then polygonize it, it's going to thin and smooth your mesh already to a certain degree. And so that's how we get that kind of, I don't want to say choppy looking because it's all just raw data. It's all just pre-processed. But once we process it and we get this really nice, high-quality mesh, those are the functions the software is doing in the background here. So these are our three major functions in the software here: thin, smooth, and close holes. These other three are a little bit more involved, and I'm going to opt not to explore these ones right now. If this is something you think you're going to use in the future, by all means, send us an email, give us a phone call, ask us in the Q&A. I'll be more than happy to show you guys these different functions, but as it is, I'm actually behind schedule a little bit, so I'm going to switch back to our I'm going to switch back to our PowerPoint presentation and try and get caught back up here. So we looked at our 3D selection tools. We used some of those functions to select bits of data on our projects. We'll use those again for certain selections and certain inspections in our process. But we used a couple of those to get into the mesh editing workspace, where we were introduced to the fill holes function, and then we used the thin mesh function, and then we actually used the smooth mesh function also. But again, this is just walking you through. This PowerPoint will be a great resource for you guys to walk through and sort of guide you along how to use these different functions. Look at that, only a minute behind. So right now, this brings us to our first 10-minute break. All right, all systems go. Welcome back, everybody. May your coffee be hot and your attention be here on this training. Anyways, let's get back into the matter at hand. So we've got our CAD imports. So we imported our CAD earlier. We had our file in here. I believe we have an STP or some version of the part. But this is the different file types that you can import into the software. So if we have the free, if we're using the free version of the software, we can bring in non-native file types. So that means just a standard generic CAD or mesh file. So we've got the steps. IGES files, you can bring in your STLs for mesh files. Sort of limited to what files you can bring in, but I believe that any CAD software worth its salt can export files in a variety of different file formats. And so if you're going to be using the free version of the software, it's important to note that you can only use non-native file types. Now, if you step up to the professional version of the software, or you use that free trial version of the software, it's going to allow you to bring in all the different file types. So native or non-native, if you're using any of these different software, any of these different CAD softwares, CATIA, Autodesk, any of these things over here on the right side of the screen. So this is kind of a cool graphic to look at. This table allows you to see what versions and what file types are supported by the professional and the free versions of the software. So generally, when we get the question, well, can it bring in X software or X, file type? Our general answer is yes, it generally can. We've not run into too many file types short of them being corrupted, or like a text file or something that you can't actually bring into the software. So if it's a modeled part, or if you've got any type of a surface or a solid, you can bring them into our software. So just to reiterate again, in our software, everything that we're going to be doing related to the CAD is going to be blue, and anything relating to the mesh, the actual, is going to be green. And I'll reiterate this again when we get back into our software. But I just want to drive this point home when you're using your Explorer over there. I'm kind of weird about collapsing my Explorer and getting rid of all sorts of menus just to keep my screen clean. But if your Explorer, you got a bunch of expanded menus and stuff on the left side of your screen here, just keep in mind, blue is nominal, green is actual. They're very, very easy. You only see those two colors, unless something really bad happened. You'll just see those two colors. So we brought in our mesh, we brought in our CAD, and they're not lined up in space. Now, what's important to note about the differences between CAD and mesh, aside from the obvious differences of one being scanned data and one being an actual model of a part, is that both of them have an origin point, but the CAD's is the only one that's important. CAD origin point is almost always important. The mesh origin point is almost never important. Now, we saw these origin points when we first brought these in to our software here with F10, and we see this origin point here. Now, when we're lining these two parts up with an alignment, we're aligning our mesh to our CAD. We're not putting the CAD to where the mesh is. The CAD's staying right where it's at in space, because generally CAD models have an important origin point to the assembly of their overall machine or mechanism. So, for instance, automobiles have I think it's engine center or something. It's car center, and it's near the engine or by the firewall. It's near the front of the car, sort of by the engine. Terrible job of explaining that on my part, but the origin of a car is there, and so all of the CAD models for the assembly of an automobile, their origin point is up there. And then if you assemble all those CAD models together, you get the complete assembly. Same thing with like turbine blades. If you're in the gas turbine industry or aerospace industry, each of those turbine blades have an origin point, the center of the rotary of all those parts together. Long-winded explanation of saying when we're aligning these two parts, our mesh is going to our CAD. The mesh origin, in our case for our systems, is based off of the first shot we used to collect the data on it, and so it's just arbitrary. So this origin point we're seeing here is generally always going to be important to the assembly of your mechanism. Now I'm going to hit F9 to make my origin here invisible. And we're left with just our part again. Hop back over to my PowerPoint. And we're going to go over the basics of aligning. Now again, we've already done this in the software. I was jumping ahead a little bit. Gosh, excuse me, guys. But what we did is we brought in our two parts. We went up to the top of our screen, the top right of our screen. And we used this plus button here, and we dropped down this option that showed us the pre-alignment. We just click on our pre-alignment button up there, and it brings up this dialog box, allows us to select our CAD model and our mesh model, the search time, additional help points, all these different options in here. They should have snapped together pretty well automatically, and we get these two parts brought together. So now that we're all caught up, let's go ahead and move on to our next function of the software, the surface comparison. This is one of the most prominent features of the software. This function alone is a huge help for a lot of people because it's a really quick and easy way to show deviations, hotspots, bending, warping on any of your parts. And so this is a pretty cool function. Whether you're in metrology or not, it's kind of neat to see. So let's go back to our software here. And we've got our two parts overlapping each other. Now what I'm going to do is I'm going to make my CAD exclusive. So if you remember from earlier, I'm going to use either the hotkey E, or you can click and drag out from the left side of your screen, and it says, should say, come on now. Okay, I'm going to use my hotkey E to make it exclusive. I don't know why that wasn't working for me. Oh well. So now we've got our CAD, the only thing visible on our screen, which should be pretty easy because right now we don't have too much inspection over here on our left side of our screen. Making our CAD the only thing on our screen here. Let's go up to our inspection workspace. So again, referencing back to these workspace menus. Inspection on the left side of the screen here. Again, if you don't have this pin over to the left side, you can click this top left workspace selection, and it brings up this list. Just make sure you're in the inspection workspace because it's more light brown color as opposed to the mesh editing, which is darker. I think there'd be more creative colors to use than dark and light brown, but I think that's limited to the professional version of the software. So we've got our CAD exclusive here. We are in our inspection workspace. Let's go to one of these functions on our inspection toolbar at the top here. If you hover over this first tool, it's going to say surface comparison. Let's go ahead and click on this guy. We've got two options here. We've got our surface comparison on our CAD and our surface comparison on actual. The big difference between the two of these is really which model it's going to be using as a reference. It's going to give you largely similar outputs as far as your deviations from surface to surface. We're just going to want to make sure that you use a model with a high resolution. By resolution, I mean it's got a lot of points it's being created with. So the mesh structure of the CAD is high resolution with all of these, triangles, and same thing with the mesh. We're going to go with a surface comparison on CAD. Up here at the top of our surface comparison menu, go ahead and click on that guy. It's automatically, oh boy, why? Oh, I've never quite seen that before. That's kind of interesting. It's like an accordion. Hope this doesn't mess up my software, but I apologize in advance if this goofs up and I have to restart my software. But anyways, we've opened up our Create Surface Comparison menu. And, because I was messing with my mesh. Sorry, guys. Sorry, 1 second. I have to recreate my pre-alignment real fast. Here we go. Now we're back on track. Surface comparison on CAD. We've got a couple of these different options here in our surface comparison on CAD menu. The big one is going to be your tolerance source here. If you have tolerances for your surface, you can adjust those. I don't, so I'm not going to mess with those very much right now. Another big one to look for is the max distance. Now the max distance is the distance away from our CAD that this function is going to be searching to look for mesh data. So because these two are lined up, it's going to go 10 millimeters in either direction, positive and negative, off of this surface in either normal direction to look for mesh data to use for our surface comparison. Now, generally you want it to be way bigger than it needs, just so that it has plenty of room to search. But keep in mind, if you have this max distance set to something ridiculous like 50 millimeters or something, you have these surfaces that are close to each other that could interfere with each other. And so it may try and grab the deviation from the side of this M to the side of this O, and then your deviation can get a whole messed up. And so just make sure this is small enough that you're not going to be grabbing onto the sides of your parts here. So I'm just going to go with the max distance of 10 millimeters. Looks just fine for us. Let's go ahead and say OK. There's a lot of information here in the dialog box. And again, if this is a function that you're going to be using a lot and you really need to know what each of these do, by all means, reach out to us. I'm more than happy to help you guys through it. I'm just going to go with just these basic information here in our dialog box. I'm going to hit OK, and we have our surface comparison. Now, what it's showing us on the side of the screen here is the deviation in the positive and negative direction. So at 0, we are at level with the CAD, and then at about a millimeter down to about a millimeter, positive and negative direction, is showing us how that surface changes. It's all green, part's perfect, send it down the line. Just kidding, let's adjust the scale. So let's go to the side of our screen here. I'm hoping you can see this. Sometimes it gets cut off a little bit, but you should see a color scale on the right side of your screen here. Let's go to the very top number where mine says 1.16. And let's adjust this to about half a millimeter. I'm going to adjust this to half a millimeter. And what I'm also going to do is I'm going to toggle this icon next to it, which is going to change it from bilateral to unilateral. So it's going to change it from different negative and positive to the same negative and positive. So when I click on this icon, it's going to change that lower value to negative 0.5 millimeters. Okay, so click on that guy and then click off of it. And now our scale has changed from about a millimeter to half a millimeter. And you can see how this deviation changes on our part. You can see this deviation is a little more accentuated now because we've tightened up that band. Let's go ahead and do that one more time and just sort of see how far we can get down. I'll go at 0.35, and it looks good. Generally, you'll have some surface tolerance that you're going off of for this. If you're going to be adjusting this, it's generally not just arbitrary, but if you're just looking for a hot spot or some warpage on your part, you can adjust the scale just to see how the form of your part changes. And again, what we're seeing here is we've got these numbers, or not numbers, we've got these colors on our part correlating to the scale on the right side of the screen. So our red is high, it's positive, it's proud of CAD. It's got more material at these spots of warmer colors. And then we've got these blue colors, which means that we're missing data. It's lower than the CAD. So in general, this M has got a little bit of deviation to it. We've got a high spot and a low spot in each of these corners of this part. And we've got a little bit of potato chipping to our part here. We've got some high spots along the top and the bottom and some low spots near the ends. So gives us a really quick and easy way just to see what the overall part or the overall shape of the part looks like. And that allows us to get a good idea of just the form of the part. Obviously, you can't, this isn't an end-all be-all inspection of this part. This isn't going to tell us everything about this, but it's a really great first step just to see the overall health of your part. Now, what we can also do is we can visualize this part with a couple of different colors, color gradients. Let's see here. Yeah, color schemes here. So right now, we are in the GOM continuous legend. And so that's going to be a continuous color gradient from warm to cold. But if we want to see this in a little bit more defined way, we can right click the legend, the right side of the screen. And I'm going to go down to legend templates. And here we've got a couple of different ways to view these parts. In this case, I'm just going to show you guys these top three, the GOM 3 colors, GOM 8 colors, and the GOM continuous. So let's just go and click on our top function, our GOM 3 colors. And it changes our number scale over here. So let's go back over here. I'm going to click my toggle for this. I'm going to make this 0.35 millimeters again, just to mimic what we were seeing with the GOM continuous color scheme. Hit enter or click away. And now we've got this visualization that shows us each of these colors defined a little bit better. And I just thought of something that confuses a lot of people. Excuse my messy, jumping around everywhere, but I just thought of something that I really wanted to iterate early on that I won't forgive myself if I didn't mention it just now. If you guys built this this surface comparison and it looks like this, if you have gray on it, make sure that your mesh is invisible. I should have mentioned that earlier, and I apologize for interrupting myself to tell you this now, but it's something I see a lot and something just triggered my memory up. So just make sure that your mesh is invisible, and you'll see just your surface comparison here. Anyways, back to our color scale over on the right side of the screen. Again, we have our warm colors on the top. We've got our cool colors at the bottom. That's going to show us where we have high and low spots on our part. This is sort of like a pass, warn, fail, almost like a pass, warn, fail visualization. But again, this is just the deviation on your part. It's going to show you where the high and low spots are in a very easy to define manner. You can also adjust where these cutoffs are. So if you want this to be closer to 0.30 and this one to be closer to negative 0.30, a little bit tighter tolerances. This will, again, show you these parts that are in or out of tolerance. Now, let's go to a different legend template. Let's right-click on our screen one more time, or our scale on the right side of the screen one more time. Bump down to legend templates. And instead of GOM 3 colors, let's go down to GOM 8 colors. And once again, we have to reset our numbers here. It's just good practice, Practice makes perfect. Make this 0.35 one more time. Lock those tolerances, linear top and bottom, hit enter. And this should be no surprise to you. We've got deviation on our M here. Again, same thing, cool colors low, warm colors high. And so it gives us a little bit more defined way to see the deviation on this part. Instead of just being continuous gradient, not knowing where that deviation really changes, you can now see and define the lines here where that deviation is sharply cut off at a certain threshold. Now we can also do is we can click on our surface comparison. So just click anywhere on your colors, hit tab, and oh my CAD. Talk myself into a maybe not. I think that there's usually a way so you can see boundary lines on here, but instead of me struggling around to find it, I'm just going to skip over it, and I can go back to that in the Q&A once I've got a second to look back at that. I don't want to get behind schedule again. But anyways, this is our GOM 8 color, went over the GOM 3 color, 8 color, and the GOM continuous. It's all the same way with different ways to visualize the same data. So we're looking at the same surface here. We're going to be visualizing the deviation between our CAD and our mesh, and we're going to be doing that with a couple of different templates for this color. So let's go back and just switch it back to our GOM continuous. Again, right-click on our color scale, legend templates, GOM continuous, and I'm going to change my color or my scale back to 0.35 top and bottom. And so this is what we are looking at here, is our surface comparison on our CAD model. And this is, again, just showing us the deviation between the two of those. Now, if I want to know what those numbers, is it specific deviation in each of these points are, we can go up to the top of our screen here. And we were using surface comparison earlier. We're going to bump over past inspection section and go to point-wise inspection. And we're going to go down to deviation labels. Now our deviation labels is going to allow us to see at exact points what our deviation is. So again, following the directions on our gray instructions down here, couldn't think of a better word than instructions, saying it twice, but we've got these directions down here on how to use this function. So if you hold control and just hover over your part, you can see how the deviation changes. Alternatively, if you actually want to create a deviation label, hold control, left click anywhere on this guy. And you'll be able to see what that deviation is in each of those areas. So you've got an area of interest somewhere, you're seeing some warpage more in certain areas. It allows you to zone in really well on these on these areas, and you can see what this deviation is. I'm going to hit escape to get out of this function. And so now we have our surface comparison based off our CAD model. We're viewing it with our GOM continuous legend template. And we've thrown down a couple of deviation labels to visualize what the deviation is at specific points on our part. So that's the basics of the surface comparison. You can do a lot with it. You can create them in localized areas. You can create them based off the mesh or the CAD. A couple of different other functions that you can use to visualize it. So what I was meaning to show you guys earlier was ISO lines. But you only have to do that in the GOM 8 or 3 color. I was telling you to show boundary lines, so you don't have to follow me along, but just so I'm not talking to myself randomly, I'm going to show you what these ISO lines look like. So there's something you need. Look here, ISO lines on surface. Here we go. So that shows us these sharp boundaries where each of these colors cut off. GOM continuous. And, so that leaves us here. Surface comparison. Super useful function. Very popular. We like using it. Metrologists like using it. It's a great tool for these high resolution sensors that you get a lot of data, and it translates into this really cool visualization of your data. So let's jump back to our PowerPoint. So again, we're using that surface comparison on CAD function in our inspection workspace. We create that, and that dialog box comes up. We're not going to change much of that. Just make sure your max distance is arbitrary large enough that you can get far from your surface, and then small enough that you're not grabbing bits of data next to you. We can change the legend on the right side of the screen. And then we have more options for legend types and templates here. Now, we're going to segue into next going over another type of alignment, because this will allow us to see how the deviation changes from alignment to alignment. So let's jump back to our software here. Now, we're going to go from a pre-alignment to a local best fit. Now, our local best fit, much as it implies, is going to be an alignment based off a localized area of data that we're selecting. So in order to do that, we're going to go ahead and make our mesh exclusive. So this time, instead of using my E hotkey, I'm going to click and drag this guy out. Again, it's the exact same function. You can either click it over here, hit E, or click and drag it out to show it exclusively. However you like to do it, just make sure that your mesh is the only thing that we're seeing here. Mesh exclusive. Now, what we're going to do next is we're going to go up to our alignments menu at the top right here. We're going to create an alignment. And we're looking for a main alignment this time. Our last alignment was our initial alignment. We created that pre-alignment. You may notice that these are different from the time we were creating the pre-alignment, because these are now main alignments. They're a little bit different. So let's go down to our local best fit. And let's all take a sip of coffee in unison. Good job. Now our local best fit menu is a little bit smaller than our pre-alignment menu, but the function is a little bit more specific. What we're going to need to do is we want to select a bit of data on our mesh to align to the CAD. So as our pre-alignment, with our pre-alignment, you remember me saying is a global best fit, so it captures everything and aligns everything to everything. In this, we're going to be aligning just a specific area on our part. Now, we're going to be using those 3D selection tools that we were introduced to earlier, so either in Edit, Selection in 3D, and use one of these tools. And I encourage you guys to get creative here, try some things out, try some of these different functions, and just see how it changes, because this is all training. There are no wrong decisions here. In my case, I'm just going to use this select deselect on surface, and I'm going to select the G, because I think G is a cool letter. And I'm just going to select the box around our G here, like so. You can get creative on how you actually select it. If you want to be more specific on it, doesn't necessarily matter. Just select an arbitrary bit of data somewhere on your part. Now you want to make sure your background thinking needs to be that you need to lock in movement, translation and rotation in X, Y, and Z directions. So just grabbing just a surface, that alignment's going to be a little bit higher deviation, or like just one cylinder might not lock it in where it needs to be. So just grabbing enough data in here that it locks all those degrees of freedom will assure you a nice solid alignment here. So I used my select deselect on surface tool, and I grabbed the G. And just to reiterate from earlier, if there's something that you grabbed that you didn't necessarily need to, you can use this tool again. It's deselect, or it's select and deselect, right? So you're going to be able to do both of those things with this tool. So if I want to shave off a little bit of this area that I was selecting, go ahead and grab this corner, hold your right mouse button, and I used the plus earlier to grab this data. If you want to deselect this data, let go of your mouse button over the minus, and it's going to deselect that. So another good excuse to use some of those 3D selection tools. Once we've selected the data that we want to use for our local best fit, go ahead and hit OK in here. And now let's go ahead and make our surface comparison. Actually, before we do that, let's turn our CAD on. Let's do that. Let's turn our CAD on. And we can see how these two parts line up to each other with this new alignment. Now, if we go down, if we go up to our alignments in the top right, we created them with a little plus button to the left of it. If we go to our alignments menu, click on this guy, and move back to our pre-alignment, you can see how this data shifts from alignment to alignment. Same parts, but they're based off of different points of data, and they're lining off each other in a different way. So that alone is a big lesson in metrology in general. You want to make sure that your alignments are nice and solid, because if you use 3 different alignments in the same part, through a run of production, you're going to get 3 very different values. And to emphasize that, let's go ahead and make our surface comparison visible again, or exclusive, I should say. So click on it and either drag it out or hit E. This time I'm going to hit E. I apologize if jumping around is confusing you guys. I just want to get you guys used to using both ways, either clicking and dragging something out to make it exclusive, or using that hotkey E. So let's go ahead and hit E there, make our surface comparison exclusive. And then let's switch again between our local best fit and our pre-alignment. And you can see how that deviation changes on this part. And if you were to select that M, like the instructions tell you to do, then you would really see how it emphasizes, because this M is so far out of tolerance. So the important takeaway from this is you really need to make sure that the alignments you're using are what you've been using before. If you're replacing a CMM, or you're replacing hand gauges, or you're replacing a different system, you want to make sure that your alignment process is evolutionary and not revolutionary. You don't want to be reinventing the wheel when you get this new software. You're going to be taking what you know, what you've been doing, and you're just going to sort of add that into this new process. And so you want to make sure that when you're measuring, you're putting together measuring plans, you've got your datums hashed out, you've got those alignment areas hashed out. You want to make sure that you're aligning to this part the same way that you have been, because if you're just going to be using a pre-alignment, then your numbers may be way off. So we can also turn on our surface comparison deviation labels, which is a good introduction to the Sub Explorer down here. So let's circle back to a couple different functions that we mentioned earlier in the training. So now that we have this nice busy Explorer over here, we've got our CAD and our mesh, we've got some inspection, we've got some coordinate systems in here, we can now see that this list is starting to get pretty busy. We've got all these different functions in here. We haven't even started using any of the actual geometry creations. So it's important to keep tabs on what you're creating over here. If you're creating things that have a bunch of red flags in your status bar, or if you're creating things you're not using, sort of start to get cramped up over here. So again, I had mentioned that I like to keep all of my menus collapsed, just because I like to keep things clean on the right or the left side of my screen. If you guys have a bunch of menus that are really wide open and it looks different than mine, that's just why. That's just because I like to keep mine all collapsed. But if you select any of these parts or any of these tabs here in your part container, so my CAD or my mesh, I'm going to see down here, because I'm in my relates to Sub Explorer. Again, everything down here is just organizing what I have up here in my Explorer. So this is where everything's listed, the top half. And then down here, it's just organizational tools. So if this is confusing you or it's getting in your way, you can collapse this down. You have just this list of all your stuff. But this relates to is super handy. I know even after my years of using this, I refer to this almost every time I use a project. I use this relates to, because if you're building a lot of things on top of each other, you want to know where their core element is. You can just click on something over here and you can see that I'm clicking on my surface comparison. The related elements are the CAD and the mesh because they're referring to each other. And then I've got all these deviation labels, and I've got the alignments that they're built in also. So important to keep note of that relates to Sub Explorer down here, and then our Explorer up here is where everything is listed. Now I was also going to jump up to the status bar and show you guys if we had any errors in our project, but because you guys are all doing great, we don't have any errors so far, and so there's no real reason to show you that quite yet. I will refer back to that when we start getting some red or blue. I saw some blue in there earlier, but as we built things, it went away. So as long as you see a green bar and your status here, that means that there are no errors in the software. There's nothing that's not computing correctly, and everything in your project is going good. So good on you. Let's continue on here. I believe the next part of our presentation is jumping into inspection sections, which is slick. So let's go back to our project here. Our surface comparison is a 3D visualization. It's taking all the geometries of our part, creating a surface comparison based off of all of those. We don't have any data on the back of our mesh, and so nothing's computed on the backside. But the next function we're going to be using is our inspection section, and this is a 2D surface comparison tool. So I'm going to start this function much how I started the surface comparison by making my CAD exclusive. Click on it and hit E for exclusive. Now we have just our CAD model visible here. I'm going to square it up in space just to make my screen just look a little bit more presentable. I'm going to go to our function up here in the top left. We've got our inspection section. Looks like kind of a little bar graph up here. And the first thing you want to do is to take another sip of coffee. It's an important step, so please don't forget that one. We're going to click on inspection section on CAD again. Again, we can use it on actual or on CAD. In this case, again, it's going to be similar to surface comparison. It's not going to change very much. But we're going to do inspection section on CAD, and it brings up our dialog box here. And a goofy visualization of our part. Things just look a little bit cluttered, and we're going to sort this thing out. So our reference plane, the first thing in our dialog box here, our reference plane. There's my echolocation. Our reference plane is going to allow us to choose which direction we want to create our section cut on. So it's referring to a plane, and then this position is going to allow us to base off of that. So our reference plane is plane Z, and we're going to be 24 millimeters off of plane Z. Or you can choose plane X, plane Y. Really, at this point, it does not matter. I'm going to choose plane Z because I think it looks cooler. Now, when you start building geometries in your software, your project you may also have planes that you're building off of certain bits of your part, and you can base your reference plane off of some of these planes. But in this case, it's all just variations of X, Y, and Z plane. And so I'm just going to go with plane Z, and I'm going to position it about 26, better number, 26 millimeters off of that. Now, to change these numbers in these dialog boxes, I don't think I mentioned this earlier, and I apologize for that, but you can either highlight them, type in the numbers you want. You can use these arrows over here on the left and adjust them in increments. Or, which I do, which you can't necessarily see, is I use my scroll wheel. So as long as your cursor is inside this numerical box, we can use our scroll wheel to adjust those numbers up and down. Now, if you want to adjust them in bigger increments, you can hold Shift and we'll adjust in larger increments. Or if you want to adjust them in smaller increments, you can hold Control and we'll adjust them in small increments. And if you don't hold anything, just use your scroll wheel, it's going to adjust by that, middle. So I'm just using my scroll wheel here, and I'm going to adjust to 26 millimeters. My actual element is going to be selected automatically. Only got one, and so it's just grabbing that. Again, this max distance is how far away from the part we're actually going to be grabbing. So again, arbitrarily large, but you want to make sure that it's not going to be grabbing, the sides of the part here and giving us a whole bunch of wrong data. And then we've got our tolerance source if we wanted to do a pass, warn, fail, which I actually forgot to do on our surface comparison. Maybe I'll jump back to that at the end if I'm not terribly behind schedule. So now that we've got these main options up here, we've got these main options in the dialog box pretty well figured out using our reference plane. Position is 26 millimeters positive of plane Z, automatic actual element, and 10 millimeters for our maximum distance. Let's go ahead and say create and close. This is going to create this section for us and close out of the dialog box. Now, you can sort of see this highlighted. If you click off of it, it doesn't highlight. You can still see this colored band on our part here. If you go ahead and click on this guy, zoom in a little bit and click on it, you can see it highlighted again. Now we have it highlighted in our Explorer. Let's go ahead and hit E and see this guy exclusively. I don't know how well these colors are coming out on your screen, so I'm going to tighten up my tolerances a little bit just to see these a little bit better. That's it. 15 over here. So this is the deviation on our part on a section cut. So we're just choosing an area, cutting straight through that, and now we're seeing deviation in a 2D geometry. So we can also add deviation labels to this guy. We want to add deviation labels and see how it adjusts or how it changes off of just this section cut. So again, that shouldn't be anything new, adding these deviation labels. But what I do want to show you guys is a couple of different ways on how to visualize this section cut, because it's kind of cool. Let's go ahead and make our mesh and CAD visible. So click on the toggle over here on the left side of the screen, click your little eyeball. There's also another hotkey for that, which I'll use later on, but I and V, indivisible and visible, are the hotkeys for that. So we just click on something and say I or V or I or V, makes them visible, invisible. We want to see our CAD and our mesh and our section cut. So if somehow you made your section cut invisible, you'll find that under inspection and curves, inspection section on CAD. And now we have our plane. It's got a kind of a gibberish name, but it's a plane Z section cut, 26 millimeters positive in the X direction, or XYZ direction, excuse me. So we want those three: mesh, CAD, section cut. Now that we have those three things shown on our screen, let's go up to our PIP button. PIP stands for picture in picture. Not sure the origin of that. I think it sounds funny and I like it because of that. Once we're in our PIP menu, there's a lot of different things in here that we can get into later on, but the big thing we want to do is we want to go over to the far right, top right of this PIP menu where it says disable clipping. Click on that and let's go to clipping at element plane. Now you've got that function highlighted in here. Again, clipping at element plane. In your PIP box here, hover over your section cut and you'll see it sort of flash and highlight. Get right over that guy and click on it. And then once you see all this stuff disappear, so again, PIP menu, top right function, clipping an element plane. Once you've got that, click on the section cut here in your screen, in your PIP menu. And then once you've got that section cut, go ahead and click your PIP menu again. And let's zoom in on our part here. You might have to zoom in pretty good, but I would recommend you find an area with high deviation. And you'll be able to see how this part deviates on the mesh and the CAD. Now I've got this colored band here, which is my tolerance band. So real quick, I'm going to click on this guy. You'll see it highlight. I'm going to hit tab. I'm going to go over to tolerances. And I'm going to change my tolerance source to no tolerances. It just gets rid of that tolerance source, that tolerance band. So again, click on it, tab, tolerances. Yours might be no tolerances already, might be manually. I'm just saying no tolerances. You know, and get rid of that tolerance band. And so you can zoom in and you can see the deviation. A little bit hard to look at unless you look around, but this, again, this beige is our CAD. this gray is our mesh, and it's showing us in a 2D section cut the deviation between these two parts. So a really easy way to see where there's more or too much data or too little data or no data. If you've got a hole in the section cut somewhere, we can turn on our deviation labels on this part again. If you're clever, you'll remember if we click on it in our Explorer, so again, our inspection, curves, inspection section, click on it here. Down in our Relates to sub-Explorer, we'll see our deviation labels. Click on those guys and hit V, or you can turn them all on individually, however you like to do it. Again, anything down here in our sub-Explorer is in our Explorer. Everything we create in our project is going to be found in our Explorer up here. So if it's easier for you when you're just learning the software, just to dig through this Explorer up here, just to find what you're looking for, by all means, whatever's the easiest for you guys to get into the software. But good habits early, just keep in mind that this Relates to sub-Explorer. It's just going to be an easier way to organize what you're looking for on this part. So we've got our deviation labels. And if you want to create some more, you can go up to our point-wise inspection on our top of our toolbar here. Deviation labels, and then it'll allow you to create each of these guys here. Now, another cool function I'm going to show you real quick is, I'm going to turn off my deviation labels here. If you want to create all those deviation labels equally around your entire part here, you can go up to your point-wise inspection, go down to equidistant deviation labels, and then it's going to ask you to select this guy. So if you right-click your inspection section, it's going to create these points at random intervals. I mean, it's not random. It's, you choose it here. And then if you bump this up to like 25 millimeters, it comes a little bit more than 40. So it's going to put a deviation label every 40 millimeters, and then I think you've got, you can choose which start direction if you've got a very specific direction you want to choose these. So it gives you a lot of different deviation label options, so you can really hone in on where the deviation is and how bad it is on your part here. Okay? So let me jump back to my PowerPoint. We're getting down to the last couple minutes of our day one, so I just want to make sure that I'm not skipping out on anything here. Let's go back over what we did. We're creating an inspection section. So we clicked our CAD, made that guy exclusive. Click the inspection section button, inspection section on CAD. We get that dialog box. We're going to choose our reference plane, choosing how far off of that reference plane we're offsetting that section. And then we're creating that section. The only reason this looks differently in the project here is they're creating it off of the Y axis. We created it off the Z axis. Again, doesn't matter. It's just different ways to visualize that inspection section. It will matter if you're measuring your parts, I'm sure, but in this case, it's just which way we're cutting the part. And then we used our deviation labels on our part here to visualize that inspection. And then we're going to go over real quickly, let's see here, our material thickness. And this is a lot to unpack, and I apologize for being very brief on this, but I also don't want to talk myself into a corner and confuse myself and you guys. And so let's just go ahead and go to our project. Let's make our CAD exclusive. And now that our CAD is exclusive, we can see it's got this slice through it. Let's go ahead and deactivate our cut here just by clicking that. Click here to deactivate our cut. And we're going to go to Construct, Surface, Material Thickness. So Construct, Surface, Material Thickness. It's going to be asking for where we want to create our material thickness. And just to visualize this, we'll do the outside of the O in GOM here. I'm going to use my select cylinder-based selection here. And it's going to grab the whole outside of that guy. I'm not going to change any of these numbers in the dialog box because it can easily get confusing if you take time to study this. If you're going to be using material thickness functions, and I like to keep referring back to this, but reach out to us because we can definitely help you with this. Unless you've used it before, and then you don't reach out to us. But this diagram here is a great way to visualize how it's going to be using this function, but it gets a little bit confusing for early users, and it's a little bit busy here. And so I'm just going to leave these numbers as is. I've got 25 millimeters for maximum thickness, 0 millimeters for minimum thickness, and my maximum angle between normals is going to be 15 degrees. And I'm going to create and close this. And this is kind of cool. It's just showing us the thickness across our part here. I believe it's to the next part of the CAD. So I believe it's going from the outside of the data here to the inside of the O here. You can also do this on actual data and see how the thickness of your actual part is shown after it's been created. So material thickness, there's a lot of different ways to visualize this in the software. And if it's something you guys want to see, we'll be happy to go into it in the Q&A. Getting down to our last couple minutes, so let's go ahead and boogie on to our next function. That is material thickness. You can also add those deviation labels. I forgot to just show you guys a second ago, but we've used that a couple of different times. So you can visualize the deviation on your material thickness as well. So last, certainly not least, let's go ahead and create a report page out of the inspection section that we've created. There's going to be a whole lecture to you guys on reporting here in the future. We'll go over it, I think, day 3. And we've actually got a guest who's going to come on and show you guys a really nice report that he put together with using only the free version of the software. So we're just going to touch on some very basic reporting functions right now. Right now, we're just going to show you guys how to create and edit one of those pages. And so let's go ahead and bring out something a little more exciting than some material thickness. Let's go ahead and drag out our surface comparison. Snazzy surface comparison. Bonus points for those who want to turn their deviation labels on as well. And let's go up to this far right function on the top of our workspace toolbar. It's this fancy little camera. And if we hover over that, it says Create Report Page. So let's click on that. And it brings us up this white page with our part. And we've got our pencil icon in the center, Edit Content. Let's go ahead and click on that guy. And let's just square up our part however we want to see it on our report page. You can go back and edit these once you've created them, so it doesn't need to be perfect right now. You can actually just use them as placeholders if you want to just put your surface comparison on here, your deviation labels, and then adjust how it looks or adjust where the deviation labels go later on. But let's just adjust how big this guy is here. You can view it a little bit differently as orthogonally, however you want to see it. And then go ahead and hit OK. And now we've created our first report page. I'm going to name this guy Surface Comparison. You can name it whatever it is you like. If you guys have specific names for them at your facilities, by all means name it that. I'm just going with Surface Comparison. You can also change the size of the paper if you plan on printing these or using a plotter or something. You guys can adjust the size of paper this is on. It's not going to adjust, or it's not going to change how it's visualized in the project though until you print it out. So you got different styles of paper. I'm just going to leave mine as A4. I'm going to say OK. Oh, actually, you can change landscape or portrait mode, hot dog or hamburger if you're a grown child like me. We're going to hit OK there. And so now we have a new report page. You can also visualize this down here in the report pages of our surface comparison, or we can go to our report pages workspace in our project here. And we've got our very first report page. Now again, we're going to go over a lot more of the reporting workspace later on in the training, so I'm not going to get on too much right now, especially since I'm over time. Let's wrap up here in our software. It went over on they're using the inspection section on a report page. If that's something you want to do at this point, it's kind of arbitrary. And you can adjust where those deviation labels are, which I didn't turn mine on, so sorry guys. But you can adjust where those are, you can adjust the size of those, and then you can visualize those in our report workspace. And then, oh yeah, that's a good one to show. If you guys want to export this later on, which again we'll talk about, you have this export as PDF button at the very top of your screen here. So you can export it somewhere on your computer and export it to a PDF and either print it or keep it on your computer and send it out to all your friends and show them how cool you are at inspecting. And I believe that brings us to our next function, which I thought was exporting the mesh. Oh, this will take just a second. So exporting the mesh, we exported our PowerPoint. If you want to export just this mesh file that you used, File, Export, Mesh as a G3D, which is a GOM proprietary file type, which you can only open in GOM softwares, or our main export is an STL. And again, it asks you where you want to export, what your file types are, and that will allow you to export out that model. I'm not going to do that right now. I just want to show you guys where that's at. So you can save your report, you can save your project, and you can export your model and have all those different file types to do whatever it is that you need to do. So sorry guys, we're running over just a little bit of time, but I believe that concludes us up with day one. So we went over a lot of different information today, went over the company, introduction to the metrology from GOM and the GOM Inspect software, general operations of the software, including data import, selection tools, mesh editing, basic alignments. We went over our surface comparison, our inspection section, material thickness, which is a sort of another sort of comparison, and then we went over introduction to report pages, and then exporting and saving your projects and report pages. Tomorrow, we're going to dig into a little bit more of the actual geometry creation. It's going to be a little bit heavier on the complexity side of things. We're just going to be a little more clicking around. We're going to be creating some things that are sort of based on each other, and so that one will be a little bit more information heavy, but it's also a lot more useful information, in my opinion. I mean, a lot of these geometry creations are really important to the functions of the software. So we'll go over all those different functions tomorrow. So that concludes our day one training, which introduces us to our day one Q&A. So I'm going to mute my mic, and Sean is going to take over as our host, and he's going to sort of moderate this Q&A.
Thank you, Garrett. So we did get a few questions during the session. The first question is from, before I start, I'm sorry if I butcher your name. I'll do my best. Unfortunately, I do have a crazy last name, so I'm used to it also. So from King Hong, is the rotary table controlled automatically, and how, if not, how is it controlled in the software?
So the rotary table is plugged into the computer with the sensor. And so when you're using a rotary table with these systems, it's going to be based off of all in the software. It's not its own standalone thing. So there'll be a function in the software that allows you to measure with rotation table. And so the sensor and the rotation table work in conjunction with each other. It's going to index each time. So it's going to take a shot, index however many times you want it to. You'll have different degrees of rotation, and then however many shots you want to take. And so they work in conjunction.
Thank you, Garrett. Our next question is from Jose Zunza. Can we change the units within the software?
Yes, you can. That is another great question. You get full today. So within the software, you can change the function or change the units in a couple of different ways. For one, you can change the units in your whole project by going to Edit, Application Settings, down to Preferences. Once you're in this preference box, you have default units over to the left side of the screen here. And here you'll be able to change each of these individually. I don't think there's a way to change all of these at once. Kind of makes sense, but I think that they just want to try and give you a lot of control with this. So you can change each of these units individually. Alternatively, which we run into sometimes, is that if you create something and you want to see the number as either metric or imperial right here in your dialog box, you can right click in any numerical dialog box, and it'll allow you to change the numbers here. Now it's going to revert back to what your base unit is from those preferences as soon as you click on this OK box. But if you want to see what 1 millimeter is in microns or inches or feet, you can switch here, and it's going to tell you what that unit is. So a couple of different ways to visualize units.
Thank you, Garrett. Just before we keep going with this Q&A, a few people joined in for our as panelists for our Q&A. We have Josh Old, which is our engineering manager here at Capture 3D. Also, we do have another lead up in Michigan, Wade Smith. So they will be helping me and Garrett out if some of these questions get a little more in depth. But just to let you know, for some of the other voices that you hear, that's not me or Garrett. So we'll move on from there. From Lucas Sedino, how does the regularized mesh feature affect the mesh, and is it detrimental as a metrologist?
I'm going to be honest, I don't use the regularized mesh function too terribly much. I believe that is more for like a flow analysis, which we don't do too terribly much within our software. Josh Old may have some insight on this, but I don't have much experience with the regularized function enough to say one way or the other if it's good or bad for general metrology.
Yeah, general metrology, we haven't used it for that. It basically just regularizes all the triangles and makes them all basically the same. Can you show the mesh real quick?
Okay. Well, let's move on to the next question, and we can get back to that one if we have some time later on.
Okay.
So the next question we have is from Jason Gabbard. Is there a workflow to compare two STL files from scanning when a customer would like to compare two produced parts, not to a CAD model?
Yeah. Yep, you definitely can do that in the software. So like mesh to mesh comparison is very doable in the software here. We'll kind of touch on that later on in the software, so I don't want to get into it too terribly much right now. But the general workflow that you'd use is that you'd bring in both of your mesh files, and then you'd set one as a CAD, and then you'd kind of go about the same workflow as we've been doing. You'd align the mesh and the CAD, which is another mesh, and then you could do all the same comparisons. So it'll visualize as a CAD in the software, but it'll actually be a mesh-to-mesh comparison. It doesn't change the file type. It doesn't change the file structure. It just essentially changes the color of it and how it's represented where it's assigned in the software. So you can definitely do, and we'll actually also get into trend analysis as well later on, which you can unfortunately not do in the free version of the software. But trend analysis will allow you to compare multiple different scans, either back to an original CAD or your mesh to CAD, or you can compare all the meshes to each other. So trend analysis is a pretty cool function, but yeah, you can definitely compare mesh to mesh. It's not exclusive to just mesh to CAD.
Perfect. So we'll keep going with these questions. The next one is from Maximiliano Campos. Is there a tool for deviation labels that automatically places a max and a min deviation? And if there is, can you narrow it down to a specific selected geometry instead of the whole part?
Yeah, so there is definitely a function for the maximum and minimum deviation labels. I'm going to show you here on the surface comparison real quick, and then I will go in and create something a little bit smaller. So we have our general surface comparison here. If I want to see the maximum and minimum deviation here on this part, I can control right click, which brings up my eye inspect wheel, which we'll introduce more in tomorrow. But this is our eye inspect wheel, so control right click to bring this guy up. And we can go to our checks here, and we can click on our minimum and maximum deviation labels. I'm going to hold control and click on both of these guys. Now, what's kind of interesting to look at when you do it on the total surface comparison of your entire part is that there's a lot of these areas, there's little spikes of deviation because the CAD is a perfect 90-degree cutoff, and you can almost never get a perfect 90-degree cutoff on actual parts. And so we've got this radius here, and so it's saying we've got 9.8 millimeters worth of deviation there, and 9.8 millimeters of deviation here, which that's more of just a computation error. So if you want to see it a little more accurately, if you choose specific areas on your part here and create a surface comparison on that. So now we have a surface comparison on just our M here. We bring up that function again. You can do minimum and maximum deviation labels. And now it's showing us like that one's a little more of a computation error. But still, I hope you get the idea. It's definitely a function you can do in here. You just got to be sort of careful of what you're using for your creation of your surface comparison. It works really good on your inspection section.
Gary, you can actually select the very
So you
area inspection section.
minimum and maximum on this 2D section cut. So yep, it'll snap to wherever the highest or lowest deviation is. So
Hey, Garrett.
Exclusively for that. So I hope that answers your question.
Hey, Garrett, hear me? Can you guys hear me at all?
I can. I don't know if Garrett can.
I can.
He can select that. He can select a portion. So if he just like lassos the M within the larger color map, you can then say, give me the min max, and it'll only put the min max on the selected area. So if he right clicks and select on surface and selects a portion of the mesh, the color map, it should only put a min max in that area as well. There you go. So you see how it only put the max or min or whatever, which one it was in that area where you selected. And you can do multiples too. Okay.
Was he talking earlier when I said, let's skip over this? Oh, whoops.
All right. Perfect. Thank you all so much for those answers. The next question is from Holly Howard. Can you set up the CAD import to always come in as a certain color, or do you have to change it each time?
Question. I believe it's based off of what color it's exported as. I think. Because I believe when they're created, they're built as certain colors in the assembly to differentiate different assemblies or something. I'm not sure if you can set, because I don't even think you can set, I don't even think it asks you what color to import it as when you bring it into the software. That's a good question, and I don't know the answer to that. Josh, do you know if you can import it as a certain color?
No, you can't import it at certain colors.
Yeah, I didn't think it was a...
You change them after they're in.
Okay, perfect. So the next question that I have is from Lucas Sedeno saying, if the Explorer bar becomes undocked and is floating, how does one redock it?
This last time, waiting for Shonda. I did this last time for the first time and it confused me a little bit, but so you click and drag it out and it's its own little window. If you click this plus up here, you can bring up your Explorer. So that works for all of these things. So your status information or your relates to, and I believe what I did last time was I closed out of my relates to, and I figured you have to open it up here also. I'll bring it down here. So you can sort of change how to visualize all of these different menus here by clicking and dragging. But that's a functionality they introduced in 2018 or 2019 software version where you can drag these windows out and bump them and use them as windows in different monitors. So you can use different functions in different monitors. So that's sort of the purpose of this. By default, your Explorer is up here and your Sub Explorer with the relates to is down here, but you can add whichever menu you'd like in each of these. You can also bump out these menus on the top where our pip was. If you exit out of those guys, you can bring those back up as well.
Do you think he was talking about? No. I think he was talking about the whole bar. I think the whole docking area came floating. But I'm pretty sure Garrett answered that in there. But the next question, if he didn't answer that question fully the way you were trying to ask it, please just send me the question again and I'll try to answer it, or I'll try to ask him again for it. But we'll keep moving on real quick. The next one was from Nathan Martinez. Is there a way to do dual units?
Like metric and imperial? I do not think so. That was one of the questions we had last time with this training, and I think the consensus was no. And if you are using dual units, I'd be very curious what the application is. I've never seen a call out or drawing referring to two different units. Unless it's, I guess, like two different iterations, it's like a microns and millimeters or something. But I do not believe you can do dual units. And if you've got that sort of drawing and you need help with that, then go ahead and reach out to us. We can try and work through that with you.
Okay. So the next one is another one from Lucas saying, can you export the color map in a step?
I don't think so. I don't think you can do that either. Let's try. Let's try it. No. File, export.
You can't export step files at
Yeah,
all.
you can't export step files at all. That's right. I don't think you can export the STL as.
Go up to mesh. Those are the file formats you can use for your mesh model. But as far as the color map itself, the only thing you can export it as is a report page with a PDF. As far as I know. I mean, because a surface comparison is a visualization of deviation in color. But yeah, we can't export anything as a step file.
Okay, perfect. Thank you. So the next question that I have, I lost who it actually was from, but is there a way within the surface comparison to show, I guess, the density of where my points lie in that color map?
Histogram?
I'll give you the deviation of the overall part. Go ahead.
This isn't necessarily a point density. It's showing you where the it's like a standard deviation of all of the, where the areas are the most. Gosh. Histogram of where your data is on your part, but it's not necessarily showing you point density of the mesh file itself.
Can you turn on the mesh? Just the mesh by itself. Go to the properties menu. Go to general or information. Go up one. Information.
Say it again.
Information. No, it would actually be in the scans of the data. You can select an area and say copy selected point, so it's isolated just that area that you selected. But only when you're scanning does it give you all of that information about point density and residuals and everything. So for a mesh, though, I can't give you point density. It's not.
Here are the number of points. It can show you where all this data is, but I don't think there's a computation for the density. You can also, when you're building elements, it'll say how many points it uses to compute the element, but I don't think there's a surface comparison like visual to show you where the point density is.
It's a real good question, though, and we'll write it down and we'll send it back up.
That's a good question.
Thank y'all for that one. So the next one again is from Nathan Martinez. Is there a way to make the point cloud smaller before polygonization so that a very large scan won't take as long?
Yep, that's a good question. So when you're doing the scanning process, there's a lot of different parameters you can use to determine how many points you're going to get. So there's a lot of things that come in sort of in the background when you're scanning. The big one is we have two functions. There's one called fast scan and there's one called full resolution. Full resolution is going to use all the resolution available in the camera. So most of our current generation cameras are 12 megapixel. So up to 12 million points of data per shot. And so that gets heavy really fast. Fast scan essentially quarters the resolution, combines 4 pixels into 1, so you essentially get a quarter of that resolution. And so when you're scanning, you'll collect a lot less data. And then when you go to polygonize, it's advantageous for you to cut out data that's unnecessary to the polygonization process and thus the inspection down the road, like fixture data or table data or targets on the part. There'll be a lot of things you can cut out during the scanning process to help the processing time. And then obviously you've got things that come into play like the power of your computer versus using a laptop, and then how many programs are running in the background and whatnot. But essentially you can't use the thin mesh function on raw scan data that I'm aware of, but you can do a lot of parameters when you're scanning to reduce the number of points that you're collecting. Also, a lot of times when we get into scanning projects, we get into a lot of redundant shots where we're taking a lot of overlapping shots of the same part. Just by the nature of scanning the complex little geometries, you're picking up things around it. And so to be really particular, you can just pick up the data that you need and then leave behind what you don't need, and that will also reduce your scan time, or your processing time, rather.
Okay. All right. Next question. If we import a point cloud from a different scanner, can GOM polygonize that?
Oh man, remember
Yes.
this the last time? Yeah.
Yes. Operations. Mesh. Trying to think of exactly where it is. It's polygonized point cloud. Oh, point cloud scanner. There you go. Polygonized point cloud. So only third-party raw data sets from other scanners we can polygonize. Not ATOS systems, which sounds funny, but if you have an ATOS system, you're scanning within the software anyway. So this is strictly for third-party software. So laser data, third-party scan data, white light data, blue light data. So any raw data set you get from any other machine, we can process that data. And you can process it in the free viewer.
Okay, so let's see other questions. Kind of sift through my stuff. One says, Virginia Vega said, how precise are the measurements taken on a filled surface which was broken before the holes?
Basically, a hole that is filled is interpolated by the surrounding geometry of the hole. So how precise the surrounding geometry is for what the software needs to determine what it looks like is how precise the hole would be. So if you were to have a hole like on the edge, like maybe Garrett, you fill the flat spot and then fill a flat spot very close to an edge, so you can kind of see the difference. You'd have to cut a hole in it.
Flat spot between.
Like cut a hole in the, just cut a hole between the hole in the middle here, just so you can kind of get an idea of what we're talking about. Select on surface. Okay, so now I'll do an interactive hole fill, and then start with. So if you go up to filling result, or I'm sorry, where it says preview, and go original. I'm sorry, modification. Not that. Okay, so what you're seeing is the resulting hole fill is called normal on this one, and that's going to mimic whatever surface polygonization you use. Deleting the neighborhood means how many rows of triangle from the edge of the hole are you going to delete And then the solid yellow is what data is being used to interpolate what that hole would look like. Okay, so if you have a real jagged hole, you would want to delete a few rows of triangles to get rid of any crazy triangles that might be there. And then it's going to interpolate that hole by that yellow area, by that row of triangles. So you could imagine that if you had a 90-degree edge right in your yellow area, it would affect what that hole looks like. Okay, I can't give you an actual precision or an accuracy value of how accurate a hole fill is. But if you look to see when we fill radiuses and areas around it, it does a very good job and it's very fast at hole filling. But it is creating data. It's interpolating the data from existing data. So it's very important that you understand that if this hole was on a 90-degree edge, the hole fill wouldn't be as precise as it is on a flat surface. Does that make sense? So if you went back to preview, this view, you're going to see, now if you rotate that around, Garrett, you would actually see the light bounce off. You'll see how kind of precise and flat that surface is, or after you hit apply. And then if you did the same cutout and hole fill on a radius, say like on the edge of the part, yeah, like right there. So if he cuts out this radius, and now start to raise the delete neighborhood up. Now you can go back to preview. It shows it better. As he starts to raise that neighborhood, you can start to see how it changes. See how that radius right on the edge starts to, and if you turn it sideways, you'll start seeing it starts to change and dip. And because you're utilizing less of a radius and more of a flat area, it can affect what this looks like. So we try to keep small neighborhoods when we fill holes. Normally, we don't fill holes. If we have a hole, we try to rescan the area with the sensor and collect actual surface data there. But sometimes you don't have that option, and you have to have it. But it does a really good job. Okay.
Thanks, John. Also.
Okay. All right. So next question from Jose Martinez. Can you go into detail for the material thickness function?
I knew someone was going to ask me this. Oh boy. Okay, yep, we can definitely do this. I haven't done this in a little bit, so you'll have to bear with me here. I will show you the basics of material thickness. So, and I know one of the other guys will sort of step in if I'm doing something wrong, so you'll definitely get the right steps here. We earlier created our material thickness on CAD, which inherently is sort of a goofy way to visualize material thickness. It's just a very easy way to show you guys how you'd select the data and then how you would create this material thickness. Because on CAD, it's set, it's based off the CAD, which is the perfect surface. If you want to visualize material thickness on your part, we would do largely the same thing. So we would just select this cylinder here, and I'm going to just real quick increase the selected area by a row or two, just so we're getting all of this cylindrical area here. And then I'm going to not do that. What can I do from here? Yes, I can. We can do material thickness on here, and this will show us the material thickness of our actual mesh. And again, it's showing us the thickness from this outer surface to this next surface here. So these areas where there's more data, you can see this part of the O is a little bit thicker here, and so we're more within our tolerance band. Same thing over here, with these areas where it's a little bit thinner, we're lower on our tolerance band. Now, what's a good visualization from here is to construct, and forgive me if I go through this a little bit wrong. Where is this? There is the material thickness. The material thickness comparison on actual and oops, where'd that go? Actual material thickness. Let's exit out of this guy here. Oh no. Josh.
So basically, when he was making that material thickness on CAD, if you have a CAD model and you create a material thickness, what you can do is then you can compare actual material thickness to nominal material thickness. So instead of getting a thickness value, you get the difference between the two. Okay, so that's one way to look at it.
What step am I missing here?
What's that, Garrett?
What step am I missing? I've got an actual material thickness on the mesh. I've got a nominal material thickness on the CAD.
Just go to your nominal material thickness.
Yep, got it here.
And apply a measurement principle to it. And then check the nominal material thickness. And then inspect it. So now you can inspect the thickness comparison. So this is now the thickness comparison between a nominal thickness and an actual. So now you can see on the histogram scale and the values of the legend that you're actually seeing the difference of the thickness, not the actual thickness. So this is really, and then if you had a tolerance applied to this thickness map, this comparison, you could actually get a pass-fail or just change the legend. It looks like there's already a tolerance applied. So if you were just to change the legend now, it might all pass. To a tolerance legend. Yeah, so if he was to lower the top, there you go. So now you got, there you go. So now you can start to visualize this thickness as a pass-fail against a nominal value. So if you're looking at a mold, we can also do this as draft angle. So if you wanted to see the difference in draft angle from a nominal draft angle that you're trying to make versus what the draft angle is on your mold, the same thing, a pass-fail, exactly the same way as a thickness map is. And then from there, you can actually get the values of failing by using a deviation label. Or a statistical value by changing the value or the label. So if he was to change the label of that, you go in and visualize the label in your eyes. Here you go. And then choose ooh, that one doesn't have the statistic label. Maybe you have to do it somewhere else. But you can have a statistic of that.
Is it because we need more than one, like a trend?
No, it's not. It shows the percentage of pass-fail on that selected area.
Oh, let's try this.
But it might only be good for. It's okay.
I tried.
Do you have to select all points of element first?
You might have to right-click.
The material thickness itself or the labels?
No, the material thickness.
There it is. Statistic. So now you can get a statistical value of pass-fail for that surface. Hope that helps people.
Cool, you guys are pretty smart guys. Yeah, the material thickness workflow can be a little bit confusing, as evidenced by me stumbling through it a little bit here. And so if you don't do it pretty frequently, it's hard to kind of put it together. It's a nice function. It gives you a lot of good information. If it's something you think you'll be using on your own projects or on your own software or with your parts, then we'll be happy to walk you through the workflow of it. There's also a couple of different knowledge base articles. There's a lot of different information on how to get through this, but you can visualize the material thickness on the CAD. You can visualize it on the mesh itself, and you can do this really cool material thickness on actual where it shows you the deviation between the two of them. And then as Josh was walking us through here, you can see how this information, you can break it down statistically, and you can use your deviation labels and stuff.
Also, if you don't have CAD, you can also build the thickness map on the actual and then check it against the nominal value. But if you have an undulating change of thickness, then that's not going to work for you. That's it.
Sean, you're muted.
Thank Wade. I do that sometimes. But again, so I'll reiterate. So if that's all the questions that I have so far. If you have any more questions, please put them into, oh, sweet, another one. Again, if you want to put them into the chat, please do. We'll try to be glad to answer them. From Aaron Wants, is there a tool to measure clearance between two scans?
Yes.
Yes.
That was one of the questions we had earlier, correct? Measurements between two scans? Or
It's a little bit more advanced.
different question.
Yeah, it's a more advanced function for like digital assembly. Go ahead, Wade. Sorry.
Yeah, so basically it would require you scanning two parts separately, utilizing what we call our part container. So then under construct, there's a distance check and it says surface distance. And you could check the distance between two meshes, i.e. if there's a design gap. But that's definitely more on the advanced side. We could provide a little more detailed information if that's something that that he wants.
Okay, so if y'all don't have any more questions, we can end this. Or again, if y'all have any more questions, please direct them towards the chat and we'll be happy to answer them.
Anything else?
So if there's nobody else, we'll go ahead and conclude for today. We thank you guys for actually being here with us and taking time out of your day to learn from us. So we'll start tomorrow again about we'll start at 1 p.m. Eastern. What was that? 10 Pacific. And we'll hope you have a great rest of your day. Thank you all.
Thanks, everybody. Appreciate you attending.
Thank you, everyone. Take care.
All right, so welcome to day 2. As Sean had said, I appreciate all of you guys who were able to make it back for a second day. And if this is the first day of your training, welcome. We're all excited to see you here. We're going to go through a couple of introductory slides here just to get you guys back on track. And then we will be ready to roll. Also, just a note, it is not May 6th today. It is June 10th, so apologies for that. All right, this is just some information about keep your microphones muted and your cameras turned off. And then if you have questions, go ahead and shoot those over to the Q&A. Sean will be monitoring that throughout the duration of the training. He'll be answering those what we can during the training, and then we'll be saving some of the more important sounding questions or questions that are more beneficial towards the group towards the end. And then we'll be answering those as a group. And then if you guys have any other questions at that point, we'll be happy to take them then. Just to follow up, this is your two lovely presenters today. Sean Anyagas is our host. He's going to be on the airwaves answering questions. My name is Garrett Carpenter, and we're going to be teaching you some GOM Inspect today. So let's just go over a basic recap of what we did yesterday. So yesterday we went over an overview of the company, an introduction to the GOM products and the metrology, what is GOM Inspect and versus GOM Inspect Pro, and we'll get into a little more of those differences later on in the training. I believe on day 3 we'll go over some of those. We also are working with importing the data using some of those 3D selection tools, the mesh editing tools, very basic alignments, aligning the mesh to the CAD there. We did a lot with the surface comparisons and the inspection sections. Then we did some material thickness, and then I showed you guys how to create very basic report pages and then export your mesh files and saving your projects. So let's go over what we're going to do today. Today, we're going to get more into the inspection side of the software. So we're sort of going to pick up where we left off yesterday. We're going to introduce you guys to the iInspect wheel. We're going to do an introduction to measuring principles, which are a very large, important part of the GOM software. So we're going to take that nice and slow. Hopefully we can teach you guys a lot about this stuff and get you guys a good introduction to it. We'll go over the workflow of the software. There were the first couple steps yesterday, and so we're going to go over and continue that workflow. We're constructing nominal elements and their subsequent actual elements, show you guys some basic distance checking tools like our outer disk caliper and our 2-point distance creation. And then we'll go over creating 2-dimensional elements as well as surface points. And then we'll use some of those the elements to create an RPS alignment. And then we will finish up by touching on our inspection without CAD. So an important reverse engineering functionality within the software. So let's go ahead and jump into it. So we're going to first start by introducing you guys to the iInspect wheel. So let's jump over to our software here. And just as a reminder to those who are following along here, Sonia sent out an email again last night notifying you guys of the recording updates that have been uploaded into that folder. And this email looked something like this. So there was options to log into the training for the separate days, as well as this link highlighted here about where you can download the software as well as the class materials. So I hope that everybody was able to jump in there and grab those files. Again, we'll just be using the regular files that are in there. I'm not going to be using anything outside of that, just so there's some continuity for this training. So any of the files in the software that I'm using are going to be coming directly from that link. And again, if you have issues downloading those files, or if you need help grabbing those, we'll be more than happy to help you out during that 10-minute break about halfway through the training or later on in the Q&A. And also you can email training@capture3d.com, and we've got a team of folks behind the scenes that will help you to get things straightened away on your end. So hope that everybody is able to get all that data. Let's get back to our software here. Open up my GOM Inspect. This should be familiar from yesterday. This is just our basic home screen of the project. So I'm going to open up a new project, and we're met with our blank screen again. And I'm going to go back into my course content folder here. I'm going to go to exercise projects and files, and I'm going to bring in my GOM part actual by clicking and drag and drop it in here, new part. And then I'm going to do the same thing for our CAD model. Now, you don't have to bring in your models first. You can bring in just your CAD and do an analysis on that, set up your measuring plan, and then bring your mesh in afterwards. I just like to bring everything in first, just so we've got everything. So when we start the inspection process, we can just continue on that and not have to worry about bringing parts in later on. So I'm going to go back to my folder. I'm going to go up, and I'm going to go to my nominal folder. And in my nominal folder, I'm going to find my GOM part STP file. This is our CAD model. And again, click, drag, and drop. And I'm going to add to this part. And so now we've got a mesh and a CAD model here. I'm just going to hit OK with this define CAD parameters dialog box. I don't want to actually change any of these parameters for importing. And then I'm going to click on this tag for our local coordinate system here. And I'm just going to hit I for invisible, or hotkey for invisible, just to clean up our screen a little bit. And then I'm going to give these guys a very basic pre-alignment. Now, if you're opening up the project you're using yesterday, you should probably, or you likely have all of this done already. So I'm just doing some extra steps, but this is good practice and important stuff to note. A pre-alignment dialog box. Again, I'm going to leave most of this as it is. Say OK here. And now we've got our two models overlapping on top of each other. I'm going to square them up in space using our viewing cube down here. And we can see that we've got our CAD model, which is this sort of beige khaki color, and then we've got our mesh, our actual scanned in data, which is our gray color here. And we can just leave those two both visible. It's a pretty easy point to get to it. Hope none of you guys had too much trouble getting to this point. We've got everything here. So let's go ahead and open up our iInspect wheel, and you can access your iInspect wheel with one of two ways. The first way is to click this option up here. And again, we're in our inspection workspace. So it's this brown toolbar up here. You should recognize some of these functions along the top that we were using yesterday. We're going to open up our iInspect wheel, clicking on the magnifying glass. And again, if you hover over that, it'll tell you what it is. Open up our iInspect wheel, and we've got these 4 pie slices and a magnifying glass here in the middle. So let's go around each of these and see what it is that each of these do. So if you hover over them, they'll tell you what exactly is within these pie slices. So in our top right, we've got our measuring principles. We're going to go over these a little bit more in depth here in a little bit. Those are going to become very important soon. Bottom right, we've got our checks. And this is where you're going to find your XYZ distance checks and angle checks. And again, we'll explain that here in a little bit. But our iInspect checks, that guy is right there. We also have our GD&T menu here. So this is going to be dependent on whichever geometry you have selected. It will automatically populate this list of GD&T. We don't have anything selected, and I believe these are just the default ones that pop up here. But this list will change, and we'll go over GD&T, I believe, on day 3. We'll just briefly touch on it because it's kind of a big part of the software. But the professional and the free version has a full built-in suite of GD&T. It's an add-on to the software. It's already embedded in the software, so that makes it pretty nice and easy to use. Excuse me. And then our top left function up here, which will not be very important for us, but can be very powerful for folks in the aerospace industry. We have our airfoil package, and this is a really powerful package for inspecting and analyzing airfoils. If you're in that industry and you've never used the software or you're not familiar with this before, definitely reach out to us. We'd love to show you about it. It's pretty cool. It's very helpful. Developed for a lot of the big OEMs in aerospace. So definitely some good functionality within there. And then in the middle of our iInspect wheel here, we've got our edit, and this is just choosing visualizations for our geometries and our creation parameters, and then element visualization. And we'll go over using some of that here in a little bit. But this is our iInspect wheel. Now, I mentioned earlier that there's 2 ways to access this iInspect wheel. We had chosen to open it up here, so you can toggle it open and close with this guy. Alternatively, you can hit the X and open it back up here. The way that I will probably get in the habit of doing it for this training and forget to reiterate later on is to use the hotkeys to open it. And that is to hold Control and hit your right mouse button. Control, right mouse button is going to automatically bring your iInspect wheel to wherever your mouse is. So that's a nice little slick hotkey. So if you ever see me working around and it just appears out of thin air, I'm using that hotkey. I'll try and remember to reiterate that when I use it, that I'm accessing it with that hotkey. Control right mouse button. And again, you can just exit out of it here with our top right arrow. Okay, so that's just a brief introduction to our iInspect wheel. So let me jump back to our PowerPoint here. So iInspect, this is a good reference if you're using the software later on in the future and you need to access this guy again and just figure out what is in it, what it does. Good page with all the information here. The next thing that we're going to do is go over briefly our measuring principles. And I just want to go over what this page is covering right now and then show you guys a little bit later on when we start actually building things. So our measuring principles in the software are a little bit more of an intricate part of the software. And I mean that because it does a lot in the background that is not very apparent sometimes. So the general flow of our software here is that we're going to build our inspection on the CAD. We've got our theoretical perfect surface, our CAD model here, and we're going to build all of our inspection on our perfect surfaces. We're going to build all of our cylinders and circles and spheres and points and whatever it may be that you need to inspect. And it's all going to be very easy to build on the CAD here. And then instead of building those subsequent geometries on the mesh, we're going to add measuring principles to those geometries in the CAD, and the software is automatically going to build those geometries in the background. And I know this is a little bit confusing at first to understand, but bear with me. We're going to really dive into it and make sure that you guys get a good understanding of this. But measuring principles in the software, we're going to use them for the rest of the training. It'll be something that you'll need to use just about any time you use the software. So we'll get some good exposure to it. And then if you guys have questions about it, by all means, let Sean or myself know, follow up with training, and we can get you some help on this. But hopefully there's a light bulb moment with you guys and it sort of starts to make sense. But let's go ahead and continue on here. Our inspection without CAD will be something we cover near the end of the day, but it's important to note with our software that you do not have to have CAD within the software, within your project to do inspection. If you have just your mesh file, or say you're reverse engineering a part and you want to make a CAD model out of it, or you've got your part and you've got a wrong CAD model and you can't use it for whatever reason it is, you have just your inspection data, you can complete your inspection on just the mesh, and you can still pull dimensions off of that and inspect geometries. And so we're going to show you guys how to do that later on. But like I was saying, our general workflow in the software, if you have both CAD and mesh, is to build your inspection on the CAD, apply measuring principles, and it's going to build those measurements automatically onto those mesh files you guys have there. So you can do inspection without CAD or inspection with CAD, kind of two separate work paths there. So here's just a general workflow of our inspection with CAD. We went over our data import yesterday. We brought in our CAD and our mesh file. We aligned those two. You can do a variety of different alignments. In our case, we just did a basic pre-alignment, and I showed you guys how to do a local best fit. After you do your alignment, you're going to construct your measuring principles, or construct rather your geometries on your CAD file here. And then after you construct them on your CAD, you're going to add a measuring principle from our little iInspect wheel here. And that measuring principle is going to build that actual geometry on the mesh. And then you're going to go to the checks button on our iInspect wheel, and that's going to allow you to pull a dimension off of it. After you've pulled your dimension, you could throw it into a report page, and that sort of walks you through the basic process of importing your data all the way out to exporting a report with your results. So we've gone through just the basics of opening up our software and creating these, or we're going to go over the basics rather of opening up the software and creating and inspecting with geometries. So again, our iInspect wheel here, control right click. We've got these 4 different pie slices here. We're going to be going over our measuring principles here. And we're going to be building geometries on our CAD. Now, again, it's important to note within the software here over on the top left in our Explorer, you've got your CAD and you've got your mesh. When we start building geometries, it's a really important thing to remember that everything relating to the CAD is going to be blue. Everything relating to the mesh is going to be green. That's going to be green and blue listed over here in our Explorer, not necessarily our models here, because as you can see, we've got a gray mesh and a beige CAD. Again, if you want to change the color of those so that you can help remember what the color of these are, you can change the color of these, turn your mesh into green and your CAD into blue, just something to help you practice early on. I'm going to keep mine the same color just because our PowerPoint is the same color and I don't want to run you guys off and confuse you this early on, okay? So back to our PowerPoint here, we're going to go over a live demonstration of creating and inspecting geometries. So let's go ahead and get to it. I'm going to first start by making my CAD exclusive. I'm going to click on my CAD over here in the top left in our Explorer. I'm going to hit E for exclusive. That's our hotkey to make it exclusive. So I've got just my CAD model here. Just my plain old simple plain Jane CAD model here. And we're going to practice some geometry creation by constructing some very basic geometries. In this case, we're going to construct a couple of cylinders. So let's go up to our construct menu at the very top here. Again, this menu is going to remain static. This file, edit, view, construct, blah, 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 all the way down. So we're going to go to our construct dropdown, drop down to cylinder right about the middle of the page here. And we're going to jump over to our auto cylinder on nominal. This is going to automatically generate a cylinder based off our selected data on the nominal file. Okay, so let's go ahead and grab auto cylinder nominal. And we've got this dialog box here. And again, we've got our instructions at the bottom of the page. Control left click on our cylinder to create this geometry. It's also important to note is that this dialog box has all of these grayed out options here. Oh, effed it up. So I'm going to recreate that. But important to note, I clicked those and it changed from gray to white. When they're gray, that means that they are going to automatically generate your point, your line, your radius based off of what you select on your CAD. All right, so let's go ahead and start creating some geometries. Let's go ahead and create a cylinder here. Now keep in mind you have to select on the actual surface of the cylinder. So don't grab the plane, don't try and grab the boundary or something because you might miss. Just go ahead and grab right there on the meat of the cylinder. And again, you can zoom in on your part to get a good view of it with your scroll wheel in the center of the mouse there. So hold control, left click. There we go, built a cylinder, easy enough. If you want to build another one, you can hit create here, or you can use your green check here, hover over this, you can create. If this is the only cylinder you want to build, you can hit create and close. I'm just going to go ahead and create another cylinder over here just to get a little more practice in. I'm going to create one in the inner diameter of this geometry over here. So we've got our conical surface here. If you were to try and build a cone on, or a cylinder on this, it might look a little bit goofy because it's not a cylinder. So I'm going to grab the inside of our cylinder here. Go ahead and grab that guy. And now what's important to note is that I did not hit create. And so my cylinder jumped from over here to over here. So if we were to try that again, if you don't hit create before you build your geometries, it's not going to build them automatically. So you need to select it, hit create, and then jump over to your next geometry. Okay, so now I have two cylinders here, one on the outside, one on the inside. So we've built two separate cylinders. I'm going to close out of this now, and I'm just going to go over to my cylinder 1 here. I'm just going to zoom in on my cylinder 1. All right, cylinder 1. What we've noticed here is we've got a red cylinder and we've got a red flag next to it. Now we can tell what the issue with this is by using our status bar here in the top left of our software. This status bar is going to tell us the issues we're having or the errors that the software is seeing within our process. So let's go ahead and click on our red portion of our status bar and see what it's telling us. It's saying our nominal elements, our cylinders, are missing a measuring principle. The measuring principle is missing. This circles back to what we were mentioning earlier with the measuring principles. These are very important. We're going to use this almost every time we create geometries. So we can build a measuring principle on these cylinders in one of two ways. You can either use your possible action up here, which will allow you to apply a measuring principle directly from our status information bar. But the more common workflow is to just grab the tag here of the cylinder in the middle of your screen, bring up your Inspect wheel, either by clicking the icon in your taskbar at the top here, or control right click. And as long as your cylinder is selected, meaning it's grayed out, if it's white here, that means it's not selected. And if you were to try and grab this, you wouldn't have any options. So make sure that your cylinder 1 is selected. You'll see it highlight here in your cylindrical feature as well. Go up here to our measuring principles icon. And it comes up with this list of measuring principles. Now, the measuring principles, the reason we have a list of them here is that for a lot of these different geometries that we create, they're going to be created differently depending on which measuring principle we decide to use. So it's also important not just that you use a measuring principle, but you're using the correct one. With each different measuring tool in your measurement lab, whether it be calipers or a CMM or a laser scanner or whatever it is, you're going to have to build those geometries depending on the data that you've collected. In this case, we've got a ton of data, and so we need to be able to try and fit that geometry within the confines of that data. So we're going to select our fitting element measuring principle here. Just going to click on this guy here, and this brings up our measuring principle fitting element dialog box. Now, we've got a couple of different options here. Our actual element, again, is going to be automatic. Since we've only got one mesh in here, it's really not going to matter if we choose automatic or the part. I'm just going to leave it at automatic. Our fitment method is important depending on the parts you're measuring. And this part, or in this case, I'm just going to use the Gaussian best fit. But if you need to use maximum inscribed, minimum circumscribed, or Chebyshev, if you understand the differences between all of those, just make sure that you choose the correct fitment method because that'll give you different results on your inspection as well. So in this case, I'm just going to use the Gaussian best fitment method. We're using 3 sigma points. And then if you drop down here for our selection parameters, generally you shouldn't need to mess with these too terribly much. I'm not going to just because I don't want to start confusing you guys early on in this, but you have a bunch of different parameters here you can adjust if you need to. If you understand how they work, if you want to dive into the menu here and really figure out how you can adjust that fitment algorithm, I'm not going to mess with that. I'm just going to leave everything as it was. Our measuring principle fitting element, I'm going to hit OK. And so now we've noticed that our cylinder 1 has turned from red to blue, which means that its creation requests have been satisfied. And now we have a cylinder 1 nominal. And because we gave it a measuring principle, we now have a cylinder 1 actual. And we can see that if we go over to our Explorer over here, we go to our nominal elements, we jump down to our geometries, and we have our cylinders. So we have our cylinder 1 and we have our cylinder 2. Now our cylinder 2 is still red because we have not given it a measuring principle yet. Our cylinder 1 is blue because we've given it a measuring principle and its requirements are satisfied. Now, if you remember, we aren't building the actual elements manually. So if we jump down to our actual elements and open up our fitting elements tab down here, actual elements, fitting elements, cylinders, cylinder 1, we now have a cylinder 1 actual element that relates to our mesh. We didn't build that. We've been building exclusively on the CAD. So if we make this guy visible, we can now see that we have 2 cylinders in this area. We've got our actual cylinder 1, the green one. We've got our nominal cylinder 1, the blue one. So now we have 2 different size cylinders, the nominal, which is the CAD size. We've got the actual, which is the mesh size. And now we can compare those 2 dimensions to each other and see the deviation in the size of this geometry. So let's go ahead and click on our cylinder 1 nominal, your blue cylinder 1. Go down to your eye inspect wheel. So again, if you've closed that, control right click to bring that guy up. The bottom right pie slice here is our checks. Let's go ahead and open this up. And we've got a couple of different checks that we can complete on this cylinder here. In this case, I just want to check the diameter. So I'm just going to click on diameter. And it brings up our check diameter dialog box. Now, what's important to note about this check diameter dialog box is that you can either check against the nominal. So in this case, our nominal cylinder diameter is 20 millimeters, or if you've got, drawing-based definitions, where you're going off what the drawing says, and there's a discrepancy between the CAD and the drawing, and you need to use the CAD, or the drawing's dimensions, you can drop down this menu and change that nominal value to against a fixed value, and you can change the actual value of what that diameter should be. And that way, when it compares your actual back to this nominal, you're comparing to the drawing value and not the CAD's value. Kind of a confusing way to explain that, but I hope you can play with that and sort of understand what I'm saying there. We're just going to leave it at against nominal. We want to use that CAD diameter. We also have our tolerances down here. So you have tolerances for this geometry. Go ahead and throw those in there now. We don't necessarily have them on here, but we can just make some dummy ones here. So let's make it 0.25, a quarter of a millimeter. Nice and wide tolerances. Okay, because I've got this icon selected in the middle here. It's going to mirror that, my upper limit and my lower limit. I'm going to say OK. And now I've got a cylinder 1 tag that has my nominal diameter value, my actual diameter value, and the deviation between the 2 of these. We've also got our box and whisker plot here showing us which direction it is deviating. And so we're green. We've got a green check here. Our cylinder is within specification limits. So if you want to make this a little bit easier to see or want to pretty it up for your drawing, we can go ahead and bring it to a top view. So we're looking straight down at our part. Again, you can click on your Z axis here. Look down at your part. I'm going to make my actual cylinder 1 invisible just by clicking on that tag, hitting I on my keyboard, I for invisible. Click on my cylinder 1 here, and you can see that it's being outlined here within our inner diameter of the cylinder. I'm going to click on the actual check in our dialog box here, anywhere within this box. Doesn't need to be anywhere specific. Just make sure you're checking the actual, or you're clicking the actual check and not the cylinder. You can see that it's got sort of 2 separate entities within this tag here. We've got our cylinder 1, we've got our actual check. So make sure you grab that diameter check, and you can see this little itty bitty blue square up here in the middle. If you go ahead and grab that guy, you can drag out these leader lines, and that separates our actual diameter check from our created geometry. So now we can make our cylinder 1 invisible, and because I built it right there in the middle of that cylinder, it's kind of hard to see from our outside there, but if we select it, you can see it outlined. You can drag these leader lines out here and really make this a nice looking report page, and you can really see what geometries you're referencing. So let's go ahead and get some practice in. Let's just repeat that exact same workflow on this cylinder over here. Maybe a little bit less of my talking. We can just cruise through this real quick. So again, nominal cylinder, I inspect, measuring principle, fitting element measuring principle, Leaving everything the same here in our dialog box. Just going to say OK. We now have a cylinder 2 with a measuring principle. Drop down our checks. Give it a diameter check. It's going to automatically populate with the previous tolerances that we had before. 1/4 millimeter, totally fine with me. We can adjust those if we want to. So you want to make it 0.15. Leaving everything against nominal, tolerance source manual. You can say OK here. Also, if you want to rename your geometry, you can do that there. If you've got callouts on your drawing that you need to rename it to, go ahead and do that there. We're just going to say OK. We now have our cylinder 2, nominal, actual, deviation, and our check. Go ahead and grab the actual check here in your label and look down at Z. Little blue box appears. Click, drag that guy out. Make our cylinder 2 the actual geometry. You can make it invisible if you want to. I just, again, like to keep my stuff clean. If you don't want to, totally fine. And so now we have 2 cylinders that we've built on the CAD. We built our nominal elements on the CAD. We've given them a measuring principle, which builds an actual element. We've checked the diameter of them, and then we've brought them out so that we now have 2 cylinders being checked. And now what we can do, this is again just a very rudimentary way to build geometries, but once you've gotten your dimensional checks that you want to do, you can save your report page again. So go ahead and create a report page up at the top here. You can call this diameter check or whatever it is you want to. You can go ahead and edit the content in here and change the view, how far in the part you want to see, where these labels go. You can adjust how far out these leader lines are. You can square it up in space here. And so we built ourselves a nice, pretty dimensional check off of our part here. Okay, whoops, scrolled out a little too far. Once we've done that, we can go ahead and hit OK. And now we have our report page diameter check. And if you want to change this type of page you have, if you had some other dimensions you wanted to add into the second one, you can edit that content here. I'm just going to leave mine as a 3D style. Say OK. All right, and that is the basics of creating and inspecting geometry. Now, granted, this is the easiest it'll probably be for you, just creating some basic cylinders, fitting elements, and then doing some basic diameter checks off of those. But it's good to get you guys into the habit of it early on, on the CAD and building those measuring principles. Measuring principles are some of the most common things that we see people forgetting to do early on, is building those measuring principles. And your leader lines will be red, or your elements will be red, and people try and give it checks, and there's no actual data. And it's like, oh, what's going on? So, well, it's a very easy check. But alternatively, if you're having problems on your own, go ahead and jump up to that status bar. If you have any red in the status bar, click on the red, and it will automatically bring you to the issues that you're having, and then it will bring up some possible solutions for it. So very handy status bar up there. Let's jump back to our PowerPoint here and just get caught back up. So we've gone over creating and inspecting geometries. So again, we're going to that construct menu at the very top of our screen, jumping down to whatever geometry it is that we want to create. In our case, we're creating cylinders, using that auto cylinder on nominal. Generally, if you're building your geometries on CAD, you're almost always going to be using that auto insert geometry here. In our case, cylinder. If you're doing cones or spheres, it'll be auto cone, auto sphere. After we've built that nominal geometry, we're going to give it a, or I guess in this case, we had talked about why it had that red tag. It's measuring that measuring principle. And so after we build that geometry, we're going to give it our measuring principle there on our iInspect wheel. So definitely keep in mind where that guy is at up there in the top right. And if you ever have problems finding it or need help figuring out which measuring principles to use, definitely a good resource is to go to that direct help in the top here. So you can just, I believe, if if you just search measuring principle, it'll bring up a list of which measuring principles are available. Apply measuring principle. So these are good articles to help you figure out which measuring principle it is you need to use, and more importantly, how each of them work. Because again, those measuring principles determine what results you're going to get. So it's definitely important to make sure that you're using the right measuring principle. Thanks out of that guy. Jump back over to our PowerPoint here. So that wraps up that specific geometry that we're creating, adding a measuring principle, open eye inspect wheel, select fitting element, yada, yada, open our measuring principle dialog box, and then that builds our cylinders for us here. After that, we went down to our check on the eye inspect wheel, checked our diameter, added a couple of tolerances in there, and then we built those cylinders and then clicked on the actual check. Remember, click on the actual check, not the name of the cylinder, the bottom part of that guy. Grab that blue line, or that blue square for that line, and just drag it up, and that's going to give you some nice leader lines. Hope you guys appreciate that I don't have ice in my drink today, because I know it was blowing out some speakers there. I apologize for that. Anyways, we then created a report page based off of the cylinder checks that we had created. And this page, there are 3 of them. If you want to create a third cylinder check, by all means, nobody is going to stop you. But just going through the workflow, created that cylinder, measuring principle, created that check, and then created a report page based off of that check. So the next thing that we're going to go over is creating a disc caliper check for a 2-point distance. Now, the disc caliper check is a really awesome way to figure out the absolute limits of your part here, and it's a little more of a evolutionary measuring technique. It's not something that's, we're not recreating the wheel with this measuring technique. And so this should be familiar to you guys if you've used calipers before. I know there's some other softwares that offer functionality similar to this. So hopefully this doesn't confuse you too much, but these steps can be a little bit heavy. So try not to blink. Just kidding, I'll go slow. So let's jump back into our software here and let's make our CAD exclusive. I'm going to do that clicking CAD, E for exclusive. We now have just our CAD model here, nice shiny CAD model. And let's go ahead and build an outer disc caliper check on our part. So let's go back up to construct, our construct menu here. At the very bottom, we're going to find a distance check or a distance tag. We're going to bump that guy out here. And we've got this whole list of different ways to measure distance. In our case, we're going to jump down about 2/3 down the page. We've got our outer disc caliper check. If you wanted to check the inside diameter of some parts, you could use your inner disc caliper check. In our case, we're just going to use outer disc caliper. Go ahead and click on that option here, which brings us up to our dialog box. This dialog box has got a couple of different items that we need to satisfy to build our outer disc caliper. One thing to note when you're building these geometries is take note of where this little red triangle is. That's important to note because when you start clicking on things, wherever you click, when you're clicking and wherever this red triangle is going to determine which dialog box you're filling out. So we're going to need 2 points and we're going to need a computed direction. But if you try and go for your direction first and you click where you're clicking your first point, things can sort of start to get messy. So just take note of where this red triangle is. You'll sort of get in the habit of it to use the software a little more frequently. But when you're first learning, just keep that in mind. You've got your red triangle here. That's going to determine which dialog box you're adding data to. So to create our outer disc caliper check, we need to pick 2 points that we want to measure the distances of. So in this case, we're just going to measure the width of our part here. Just see what the absolute width of this part is. So point 1 can be anywhere on this side plane here. Just make sure that you're clicking this flat surface. We've got a little bit of a chamfered edge down here. So just make sure that you're clicking the flat surface here. And again, our instructions on the bottom of the screen, Control left click to select point 1. So I'm going to hold Control, click anywhere on this flat surface, and now I have point 1. Now we're looking for point 2. So let's go ahead and go to the other side of our part. And again, make sure you grab that nice flat surface on the edge. Don't grab the top surface. Try not to grab the boundary. If you need to zoom in, there's no shame in zooming in on your part. I have bad eyes, and so sometimes I have to enlarge my screen really big to see what I'm looking for. So grab anywhere on that flat surface on the side of your part. We now have 0.1 over here, 0.2 over here. In our dialog box, we now have 2 points fulfilled in our point selection. The next thing that we need to do is we need to add a direction, a computational direction. Now, I believe the first time you use the software, it's going to try and check this box, compute direction automatically. Now, what's dangerous about this compute direction automatically is it's going to automatically use the normal of wherever those 2 points are. So to help demonstrate that, I'm going to get rid of my 0.1 here real quick and build that down here. Oh, nice. This worked a lot better than I thought. Sometimes it'll grab both those points and give you a cockeyed outer disk caliper check, and it'll grab some of that part in the wrong direction. So it's always sort of important to double check your computed direction. If you need to, you can uncheck this guy and then clear that selection by clicking your drop down, go to your red exclamation point here, and then compute that direction by just clicking on the flat surface you want to measure. You see it squares up automatically. Alternatively, you can bump down this menu and choose a axis to measure against. Now, we have our point selected, we have our direction selected. Now we need to go ahead and adjust the size of the area that we're going to be measuring. And in that case, we're going to be adjusting our clearance and the radius. So let's go ahead and adjust our clearance first just to see what that's going to do for us. As we bump this clearance up or down, you can see how far away from the part it's going to be starting to measure. Now, if you've got a part that's just a little bit larger than your CAD, you know it's sticking off of the ends a couple of millimeters, you want to make sure you've got enough clearance here. But if you're measuring something like the inside of this M and you're trying to get a caliper check on the inside leg of this M, you want to make sure that your calipers aren't so far out that they're going to grab the other parts of the M. So just make sure that your clearance is wide enough, but close enough that you're not going to be grabbing false data. So you can go ahead and adjust those. In this case, we can leave it at, I think it was 5 or something, which is just fine for us. The next option we want to adjust is our radius here. And our radius is going to determine how big our outer disk caliper sampling area is to actually build or to actually measure on the part. As we select these individually, we can see this thing grow pretty small. If you want to do it a little bit faster, you can jump in here. So we're going to have a nice, gigantic outer disk caliper check. It's going to be large. So 300 is large, but that's okay. When we start to build things, it'll disappear a little bit more. So just make sure that your radius is large enough to encompass the entirety of the area you're intending to measure. If it's so small that you're cutting off some part of you're trying to get the absolute distance of the length of this, or the width of this part rather, and your radius is only 30 millimeters, you're only sampling this 30 millimeter area here and you're discrediting the entire rest of your part. So make sure that your radius is large enough that it samples the entirety of the side of that part. So I've got my clearance at about 5%. We've got our radius at about 300 millimeters. We've selected both of our points here, and then we've chosen our direction. In this case, I'm just choosing the x-axis to come in. It's going to travel right along that x-axis and then grab the closest bits of mesh that it can find. Okay, now our final step here, as you can see, I've got my information grayed out down here. If we hover over to our yellow triangle here, you can see what it is it's trying to tell us. Please select points in the 3D view. So what that wants to know is what part it is we're measuring on. Now, obviously we've built it on our CAD model here, but you can select individual patches on the CAD. But to make it easy, I'm just going to right click on our CAD model here, anywhere in our CAD model here. And I'm going to say select all points of element. Now, make sure when you're doing this that if you've got your mesh file up here, you're not grabbing your mesh. Make sure you're grabbing that beige CAD color. I would recommend just keeping your mesh invisible for this so you can turn the visibility of it on or off throughout this process. But I'd recommend that you have just your CAD exclusive and make sure you're right clicking somewhere on your CAD, select all points of element, and it's going to turn to this gray color with these red boundaries on it. That means that our CAD has been selected. And now we see that our creation buttons down here at the very bottom are available for us to click. So let's go ahead and say create and close. And so now we have this distance 1 created across the length of our part. What we need to do is give it a measuring principle. So go ahead and open up your measuring principles dialog box here, or your pie slice. And we've got 3 different options: no measuring principle, reference construction, and link to actual element. We do want to give it a measuring principle because we want it to build the same thing on the actual. And so we're going to say referenced construction. That referenced construction means that it's going to build this distance 1 on the mesh based off of referenced construction, which is going to be our disc calipers. So go ahead and click on your referenced construction distance 1. And we can see this turns from red to blue. So now let's go ahead down here and grab our checks pie slice. And we can see that we've got a few more options than we did when we had those cylinder checks here. So if you want to check just the arbitrary absolute distance in the X, Y, and Z axis, you can choose just your distance here. Alternatively, if you want to check it in just one axis, X, Y, or Z, you can choose those. Or if you want to choose in 2 different directions, you've got a lot of different functionality here. With a pretty basic part like this, we can choose distance, or our XYZ distance, or we can choose it in the X axis, and it'll likely be very similar, and I can demonstrate that. We can choose just distance check here. I'm going to leave my 0.15 millimeter tolerances down here. If we want to add another distance, we can choose distance in the X direction. So you can add multiple checks to the same geometry. Say okay there. And so now we have 2 different checks. We've got our generic length check, and then we've got our length check in just the X direction. And again, we've got the same distances here. So I'm actually going to grab one of these, and I'm going to delete one just because I just want to have one on my screen, not to clutter things up so much. And again, once we've got our distance up here, we can select the actual check, which again, make sure you grab those numbers and not the numbers, not the letters. Yep, that makes sense. So grab your actual check down here. You've got this highlighted throughout the part. We've got our blue square in the middle of our check. Click, drag that guy out. You can see because I was a little bit cockeyed on my part, mine's a little bit crooked. So it is determined by how you're viewing your part. But if we look at it squared up on the top here, makes total sense. And we're just going to drag that guy back into place, make it look nice. So now we have this distance 1 length check. Our nominal distance is 450 millimeters. Our actual distance is 450 millimeters and 0.35, 1 additional. So our deviation here, and then we've got our check telling us how far out. And unfortunately, our part is out of spec. Dang, scrap it. So that is our outer disc caliper check. Now, I know it's a little bit involved, and we can go over this again if you guys have questions later on, but this is how you would use a tool to check the absolute distance of your part. So let's go back to our PowerPoint, sort of recap what we're talking about here. So again, we're using our disc caliper checks. And that can be found in our construct menu. All the way near the bottom, we've got distance outer disc caliper check, which brings up this busy looking construct outer disc caliper dialog box. We filled out those dialog options by choosing our points on the side of the part. We can uncheck compute direction automatically and then choose which axis we want to measure that from. And then we adjusted our radius and clearance in order to make sure that we grabbed the entirety of this part. Now, if you can look kind of closely on our PowerPoint here, you can see that they didn't grab the entire bit of the CAD. They just wanted to grab these planes on the side, which is fine. You can use one of those 3D selection tools and just grab that planar surface. In our case, I just wanted to make it easier and a little bit quicker and just right click on our CAD and select all points of element. Once we built that outer disc caliper check on our CAD, we gave it a referenced construction measuring principle. I'm sure you guys will get tired of hearing me say that by the end of the training today, but I assure you it's very important to know what it is and how they work and where they're at. after we gave that the reference construction measuring principle, we checked that distance in the X and the XYZ direction. If you remember, I deleted my X distance, whichever one you chose, it should have the same numbers, unless you chose like Y or Z, in which case it probably doesn't have very good numbers. Once we created those distance checks, we were supposed to have put them in a report page, and we can do that right now. So there's our report pages down here on the far left. So let's go ahead and one more time build our report page. So at the very top of our inspection workspace, we have our create report page button, our little camera here. So let's go ahead and create the report page. Again, this should look relatively familiar. And let's just name this whatever it is we want to name it. Disc caliper check. Once you've named it, you can edit how it's visualized with our edit content button, the pencil here in the middle. You can shuffle this guy around. You can adjust your leader lines. You can adjust where your label goes. You can change the size of the label down here. So if you have really good eyes, which I don't, if there was an extra large size, I'd use that every time. So I'll go with the original size, which is nice and large. Zoom in a little bit on our part. And also, if you hold control while you zoom, it'll zoom in small increments. If you hold shift, it'll zoom in large increments. Or if you don't hold any of those, it's just a medium. Hold control, zoom it in just a little bit. So we've got our nice part here. We've got our distance check from our outer disc calipers telling us the absolute length of our part here. And then we can go ahead and hit OK and hit OK one more time. And now we can go to our report page, our reporting workspace rather. Again, on the far left of the page, alternatively, 3 horizontal bars, workspace selection, go to reporting. And we now have our diameter checks that we created earlier. We have our disc caliper checks, which we just created. And now we have these 2 pages. We can shuffle them around and change up the order of them. And again, we'll be addressing report editing and creation and custom report pages a little bit more in the future. We have a good guest speaker coming in tomorrow who's going to give you guys a really good in-depth view of a really nice looking report that he put together with this free version of the software. So that's where we're at right now. We've gone over very basic geometry creation. We've shown you guys how to build them on the CAD and apply a measuring principle. And I know we've only gone over very basic cylinder checks. And so we can go over some more of those a little bit later on if you guys have some questions or some concerns. But I'd urge you in the future to try and create some of these geometries on your own. The 3D geometries are a little bit easier to work with just because it's easy to select where the data is and then apply basic measuring principles. So you got your fitting element measuring principles here. All right, so easy to build those geometries there. Just make that guy invisible. So after we did some of those geometry creations, we went over our disc caliper check, our outer disc caliper, to give you guys an absolute distance. Gosh, excuse me. So that leaves us off here after we've created 2 report pages. And I believe we have next is our highly looked for 10-minute break. So let's go ahead and take 10 minutes, bathroom coffee break, and we will see you guys back here in just a few minutes, and we will kick off where we left off. So let's get back into our training here. So we took our 10-minute break, and there we go, live demonstration. We are going to jump into creating a 2-point distance. So we're going to start putting a couple of more geometry creations and inspections and measurements together here. So I'm going to click on my distance 1. I'm going to make this guy invisible. So I've got, in my case, just the CAD up here. So I've got just my CAD. But what I want to do is I want to go over here to my Explorer on the left side of my screen. And I want to find my 2 cylinders because we're going to be building some geometries based off of these cylinders. So go ahead and find your 2 cylinders over here and make your CAD and then 2 cylinders visible. If you did not build 2 cylinders before, or if you've got 2 cylinders in a different area, that's all right. It's not the end of the world, but we do want to make sure that we have 2 cylinders created first. If you need to take a second to create those real fast, quick refresher, construct, cylinder, auto cylinder on nominal, control click wherever you want to build it. Once you've built that guy, hit create or create and close in that dialog box. I inspect wheel, go to your measuring principles, give it a fitting element measuring principle, and then you should have this nice blue cylinder 2. If you did that 2, or if you did that 2 times, then so be it. We've got 2 cylinders here. And what we want to do is we want to check the distance between the 2 center points of those 2 elements. So we're going to do that by building some more geometries and deriving a center point off of these 2 cylinders. Now, inherently, you can't measure a point-to-point distance off of cylinders because you've got a center axis and not a center line. And in our software, it doesn't automatically grab any point on that line. It doesn't even let you build those 2 distances because you've got those axes, which change no matter where you're at on those axes. Over-explaining, but in this case, we need to derive a center point from these cylinders and then build a 2-point distance from those. So we've got our 2 cylinders. What we need to do is we need to build 2 planes. So we're going to go up to our construct menu at the very top here. Go to our 3rd option down here. We've got our construct plane, and we're going to construct an auto plane on nominal. So go ahead and click that guy there. Brings us up our dialog box. So go ahead and control left click. Again, our instructions down here. Control left click somewhere on a top plane. Now, in this case, I'm just going to grab this planar surface in the top of our cylindrical feature here. So anywhere on this top surface, again, don't grab the boundary lines and don't grab the cylinders on here. Make sure you use that zoom wheel and make sure you use that middle so you can kind of pan around and get a good view of this. Zoom in on your geometry here. Control left click on your planar surface. So we now have this plane. Now, previously when I was using this software, I was building them as datums. And I want to change the name of this feature. I'm just going to name this guy plane 2. And I'm going to name it plane 2 because I want plane 2 to correspond with cylinder 2 over here. So it just helps me keep track of the things that I'm building here. It makes it easier for creation down the line. So I've got plane 2 built on the top of this feature here. I'm going to say create. I'm going to shimmy on over here to my other cylinder. And on the top of our feature here, I'm going to build another plane, and this guy is going to be automatically named plane 1. Great. We're going to hit create and close. So now we have 2 planes. Bonus points for somebody who can tell me why they're both red and they have these red tags. If you guess it's because they're missing a measuring principle, you're right. Good job. What we need to do is to give these guys measuring principles. Now with the cylinders, we clicked them automatically and built them individually. But what we can do is we can select both of them because they're both getting the same measuring principle. I can click on one, hold control, click on the other. And now when I go to my measuring principles and my I inspect wheel, I now have the fitting element measuring principle here that I'm going to use. And now I can see that it's building these actual planes on both of these features at the same time. Now, keep in mind, if you need to build them with separate build parameters, you'll have to build them individually. But in this case, we're not going to be messing with any of these settings because these are going to work just fine for the planes that we're building. So we're just going to hit OK. And now we've got 2 blue planes, 2 blue cylinders. Your favorite color is blue, then you're in luck. We've got these guys both built here. And so now we have the proper prerequisites to derive a center point from these cylinders. So let's go back up to our construct menu here at the top of the screen. Construct, point, bump out to intersection point. We're going to grab this intersection point, and if we take a brief look at the options here in our construct intersection point dialog box, we've got a line, and we need something that it intersects with. So our line in this case is going to be our cylinder 2. So we can either control and left click our cylinder 2 to add that in there, or if you want to try and find it in your list here, you can scroll down and find the items that you've created. So in this case, we've got our plane 2 that we wanted to intersect with. So plane 2, and This is a very busy name because if Ethan's here, I've gone through his training class. This is all for airfoil inspection. So I'm going to name this something way less busy, 0.2, much better. So now we have 0.2 built from cylinder 2 and intersecting plane 2. So go ahead and hit create for this guy. So we've got our 0.2 there, and let's do the exact same thing here. Again, I'm going to left click, control left click cylinder 1, control left click plane 1, and now we have our 0.1. So go ahead and create and close that guy. So now we've derived 2 center points along the axes of these cylinders where it intersects with this plane. Now we've got our 2 points here. We need to give them both a measuring principle. So let's go up to our measuring principles. And we've been using fitting element before, but in this case, we're not going to be using fitting element. It's important to note here that don't get in the habit of just using fitting element when you're going through some of these. It's a very common measuring principle for 3D elements, such as spheres and cones and cylinders. But just because it gives you the option doesn't mean it's the right option, especially in this case. If we try and use fitting element for this, it's going to give us some really wacky results, and we don't want that. We've done everything clean and well so far, so let's continue that. Let's give it the correct measuring principle down here, referenced construction. And we're giving it that referenced construction measuring principle because we're building these points referenced from previous geometries, much like our disc caliper, which built that distance based off of those calipers that we built. In this case, we're building these points based off of a cylinder and a plane. So it makes sense if you sort of think about the build process. So let's go ahead and give both of those guys reference construction. Again, they're both highlighted. I've got both of these tags grayed out. So as long as they're both selected, you can give them both a measuring principle at the same time. Alternatively, just click on one, measuring principle, reference construction, click on the other, same thing. So now we have 2 cylinders, 2 points, 2 planes. So let's go ahead and build a 2-point distance check. Let's go back up to our trusty construct menu at the top of our screen here. Drop that guy down to the very bottom, our distances. And in this case, we're going to go up to the top for our 2-point distance check. Let's go ahead and select that 2-point distance check option here. And this is a pretty easy to understand dialog box. We're looking for a 0.1 and a 0.2. In this case, we've got a 0.1 named 0.1 and a 0.2 named 0.2. But because I'm an anarchist, I'm going to choose them opposite. Just kidding, I'm not actually an anarchist. I just like to make trouble. So we've got our 2 points here. So again, we're just building a point-to-point distance based off of these 2 points that we've derived from the cylinders. So I'm going to create and close this guy here. And now we've got our 2-point distance check that is red because you guessed it, missing a measuring principle. So let's go ahead and open up our iInspect wheel here, go up to measuring principle and give it a referenced construction measuring principle. So now it's gone from red to blue. We've got our 0.2 to 0.1 2-point distance. And then let's go ahead and give this guy a distance check. I also get in the habit of closing out of my iInspect wheel as soon as I use a function and then having to access it again and pull it up. So you get into better habits. Congratulations to you. I like to do excessive work. 0.2 to 0.1, our distance check. Much like our distance check for the calipers, you can check it in just the X direction because that's the direction that we've built it in, or you can choose just an arbitrary XYZ distance. In that case, that's what I'm going to choose. It's just an arbitrary XYZ distance. Again, we can choose against the nominal values derived from the CAD, or you can choose from a fixed value. In this case, we're going to choose our tolerance source manually, and we're just going to use 0.15 millimeters again. Say OK. And now we have our 2-point distance check that we've derived from our 2 cylinders, 2 planes, and thus 2 points. So I'm going to click all of this excess stuff and just make it invisible with my I hotkey, just to clean it up a little bit so we make our report page, it just looks a little bit nicer. And I'm going to give it a nice functional view here, bring my 2-point distance check here. If you want to pull out that leader line, again, grab those numbers at the bottom of your tag, and then grab that blue square right in the middle here. I'm going to leave mine right where it is just because I think it's descriptive enough. And then I'm going to go to our top create report page button, and we can adjust. My chair isn't in the view here. My guest presenter, my chair. We're going to adjust our content here in our screen. Again, you can use that Control or Shift to zoom in and out. Just make your report page look nice. You can use your viewing cube down here to square it up however it is you want to see it. So I'm going to square mine up nicely here. I'm going to say OK. And then I'm going to give it a name. We'll name this guy 2-point distance. Rock and roll. We're going to say OK here. Now we've gone ahead and created a nice, very basic, easy 2-point distance. Now, this isn't the end all be all of all 2-point creation distances, 2-point distance creation. But this is an important exercise in learning how to string along multiple geometry creations and use these points that you derive from other geometries. So a lot of times you're going to be building geometries on top of each other and then referencing them back and measuring them off each other. Sometimes you may have very basic, easy geometries like circles and cylinders and just general surface points. But a lot of times you'll sort of have to string some of these along together to get the results you're looking for. So it's a good exercise to get you in the mental habit of building things, giving them measuring principles, and then referencing that construction and building them subsequently. So it's this is a good exercise, and you get some pretty interesting results from it. Nice and easy, a nice introduction to it. So let's go ahead and recap that with our handy PowerPoint. So again, we're creating this generic 2-point distance on our 2 cylinders here. So in our case, we had already built those cylindrical features, and so we didn't go back and recreate them, but this brief tutorial is showing you how to create those cylinders and then create those planes on the flat surface above those cylinders, give them both a fitting element measuring principle. After that, we're deriving an intersection point based off of the center axis of that cylinder, intersecting with the flat plane on the top of that feature. We're applying a referenced construction measuring principle to that plane, again, because we're referencing the construction of the plane and the cylinder to build that point. In this case, they used the cone and a plane on top and derived a point from the center axis of that cone. If you go back and practice it again, the workflow is going to be nearly identical. They're just using the outside of that cone, whereas I used the inside of that cylinder. Again, center axis for the cone, plane, fitting element measuring principle for both of those guys, deriving a intersection point from those, applying a reference construction measuring principle to those, or to that point rather. And then we go up to our construct menu at the top here, bump down to distance, 2-point distance. And then we're just going to be referencing those 2 points that we created. And again, you can control click on those points to reference them, or you can select them from that drop-down list if you want to use those. After we created that distance, we're using a referenced construction and measuring principle and applying a distance check. And that was our live demonstration of that. Next, we're going to move on to a little bit of 2D geometry inspection, and we're going to construct a very basic angle check. So this will actually be a good exercise for recreating a section cut, which we did an inspection section yesterday, and then creating a 2D angle check. So I'm going to make my point-to-point distance here invisible again. Just click on it, hit I on my keyboard, hotkey I. So I've got just my CAD visible. Again, alternatively, you can click and drag this guy out here. If you've got these 2 on top of each other, just go ahead and make your mesh invisible. So you've got just your CAD here. Okay, I'm going to square up my view here. And what we're going to do is we are going to go ahead and create a section cut first, because the easiest way to create the 2D geometries in the software is on a 2D measuring surface. Let's say 3D part, so deriving 2D geometries on it gets a little bit tricky, and the software might resist you a little bit. So let's go ahead and create a section cut, and we can derive some inspection from that. So once again, referencing our construct menu at the very top here, construct down about 2/3 of the way, we've got a section dropout. Let's go to our very top option here, our single section. So we've got our single section, and I believe this is referencing exactly where we built our inspection section yesterday. So in our case, we're going to build it in the exact same place, but just as a quick refresher, if you want to change where that reference plane is, you can adjust it here. Once you have it in the rough direction, you can adjust the position by clicking on your part somewhere. So I'm just going to grab this guy right here in the middle. And we now have another yellow triangle telling us that something is amiss. Something is not right here. So the conditions which are required for creating the element have not been fulfilled completely. Please select points in the 3D view. So if you remember that from earlier, we are just going to right click on our CAD here, select all points of element, and now we've got this nice porcupine looking section cut around our part. So once we've selected the model that we want to use to create a section cut, we can go ahead and hit create and close. All right. Now that we've got our section cut here, we can deselect it by just clicking in off in space, and you can see that it's just a red line, and it's red because it needs a measuring principle. So go ahead and select that guy, and we're going to control right click, and we're going to go to our measuring principle option here. Now, we've got a couple different measuring principles. In our case, we're going to use referenced construction to this section. Now it changes from red to black, which means that it's accepted this creation, and now we have a actual section as well, which you can find by digging through your elements up here. We've got our nominal elements, we've got our section, we've got one. I should have renamed that, but I kind of like that name actually. And then we can go to our actual elements, and we've got our fitting elements, geometries. We've got our section, we've got one as well. So cool, we've got both an actual and a nominal section for this part. So now that we've got our section cut here, this is a 2D geometry that we can derive measurements from. So let's go ahead and make our section cut exclusive. Go ahead and select that over here in your Explorer. Alternatively, grab it right here in the middle of your screen. Hit E for exclusive, E on your keyboard. And we've got our sweet section cut, sweet section cut. Okay, I'm gonna square it up in space here, just by on the Z axis. And we've got our sweet GOM outline. So now what we can do is we can derive lines and measure an angle, which is a good idea. We should do that exactly. Let's go up to our construct menu at the very top. Let's go to line, and we're going to apply fitting. I believe it's a fitting line to these guys. There's a couple different ways to do this. So excuse me, I'm referring to my notes here so that what it says on the PowerPoint is the same way that we're going to be practicing here. So fitting line, and we're going to build it on our M over here. And I'm just going to build the line. So again, control click, and now it's a kind of a specific area to click right there on that line, but hold control, take a second to line up, build it right there on that section here. You can see that these have normal vectors. In this case, it's not necessarily a big deal for the inspection that we're going to do. I believe you can change that direction in here. X, there we go. So just to make it look prettier, I'm just going to commit constraints, and I'm just constraining the direction of the X. Okay, so now we have line 1, line 2. I'm going to create and close that guy. Now we have 2 lines on our section cut here. While they're both selected, as soon as I've created them, they both are selected. I'm going to give both of these guys a measuring principle. So again, opening up my Inspect wheel, going to my measuring principle pie slice in that top right corner, and I'm going to give both of them a fitting element measuring principle. Okay. Our actual elements, I'm going to say okay. So now we have two lines, line 1 and line 2, built on our actual section and then linked to our actual, or built on our nominal section rather, and then linked to our actual section. So we have two lines that are built here. And so what we can do with these two fancy lines is that we can derive an angle from them. So back up to our construct menu at the top left of the screen. Down near the very bottom here, right below distance, which we've used a couple of times, we have an angle check. So bump over to angle. Middle of our list here, we've got two directions angle. So we'll go ahead and grab that option. Now that we've got our two direction angle box open, it looks very much like our 2-point distance check. We've got two directions that we need to check. So again, you can control left click them on your screen here if they're visible. Alternatively, you can drop down this list and find them. So we've got line 1 and we've got line 2. So we've referenced both of these guys to do an angle check here. You can see that we've got a red angle. So we're going to hit create and close. We now have our angle 1. Let's go ahead and give that guy a measuring principle. Opening up our inspect wheel, going to our measuring principles and giving it a referenced construction measuring principle. Again, this should make sense because we're building this angle by referencing our two lines. So referenced construction measuring principle. We now have our angle 1 that's been satisfied and we can give this guy a check. We've got all these different angle checks. I'm just going to give this an arbitrary XYZ angle. Again, if you've got tolerances, let's say a tolerance of, say 1 degree. 1 degree in each direction, which is a lot, but you know what? We're being generous here. Let's say okay. And now on our section cut, we've derived two lines. And from those two lines, we have measured the angle on our M here. So we've got line 1, line 2, angle 1. 93.94 is our nominal. And then we're pretty darn close. Which is interesting that it says 93.94 is our nominal, 93.95 is our actual, but our deviation is 0. That's probably just because our decimal places, it's by less than 0.00. So we can check that here real quick by going to edit, application settings, preferences, default units. You don't have to go along with this, but I just want to sanity check myself. Oops, angle there. There we go. Yep, so we just have a very, very small deviation. So I'm going to bump back to 2 decimal places just because I think it looks a little bit nicer. So we've got our angle check here. I'm gonna make my line 1 and my line 2 invisible just by hitting I. I'm not deleting much here. I'm just making things invisible, just cleaning up my screen a little bit. And let's go ahead and make a report page out of this angle check. So create report page. We'll just call this angle check. Edit that content, zoom in, change where that angle goes, looking sweet. And hit OK. Hit OK again. And we've got that sweet, sweet angle check right there in the M. So that should about take care of our angle checks. Now, if you've heard of angularity before and you're checking your GD&T, your angle check and your angularity are two different things. Those are two totally separate terms. And we may touch on angularity very basically in GD&T. We're not going to teach you guys GD&T because it gets really heavy. But just keep that in mind. This is not checking angularity necessarily. This is just checking the angle of those two lines. So let's sum that up in our handy PowerPoint. In this case, we're going to do a 2D geometry inspection off of an angle. So we're giving it a section cut. We're doing a single section. We're giving that single section a reference construction measuring principle. We're building two lines off of that section cut, line 1, line 2, and we're applying the fitting element measuring principle to both of those lines. After that, we went to our construct menu, down to angle, 2 directions angle, and we're referencing each of those lines to make our angle check. Once again, using our referenced construction measuring principle. to get that angle to check out. And next, let's go ahead and use that section cut again to create a different 2D geometry. So back in our software here, now we've got our sweet 2D section cut here. Let's go ahead and try building some circles off of some of these geometries. Now, they're using the O here, and this should be a perfect circle. I know the inside is definitely not, kind of more egg-shaped. But let's go ahead and use the outside of this O and create a circle. So go up to our construct menu, down to circle, and let's go bump out to auto circle on nominal. Again, all of these are grayed out, meaning that they're gonna update this information automatically depending on what we select. Bottom here, control left mouse button for our selection. You gotta get kind of accurate on the outside of that O. Hold control, left click. We build a circle. Easy enough. Create and close. And we've got our circle here that's missing a measuring principle. So let's go ahead and open up our iInspect wheel. Go to our measuring principle. Let's go ahead and give this guy a fitting element measuring principle. So now we've got our circle that we've built on this section cut. Now it's a little bit hard to build 2D elements on 3D data just because you've got a normal direction that comes into play, and it's hard to force that freeform on geometries like that. So 2D geometries like lines and circles are always a lot easier to build on 2D data, in this case sections. So if you need to build circles and stuff, or check your diameter, try using a cylinder first in a lot of cases. But in this case, if you need to use a section right to the middle of your part to check the diameter through a cylinder somewhere, go ahead and create that single section and then fit a circle to that section. And then once you've got that circle, give that measuring principle, and then go to your checks, and you can check all these different options here. So this is a list of these, deviation XYZ, deviation in your normal direction. In this case, we're just going to grab a pretty standard diameter check on our part. Again, we can throw in our tolerance source, so 0.15 millimeters. That's okay with me. We'll just say okay. And now we've got this circle built. Circle 1. If you want to, you can create a report page out of it. If I can spell, that'll be just fine with me. We got our circle and our angle, a couple of different geometries and inspections that we've derived off of this section cut of our CAD. Again, we've got our nominal inspection, we've got our actual inspection, so we can see the deviation between our two models here. So, refer back to our handy PowerPoint. Again, building that 2D circle on that section cut, give that guy a, excuse me, give that guy a fitting element measuring principle. iInspect wheel, check that diameter. That was our live demonstration. Next, let's show you guys how to create a surface point, which will lead us into an additional alignment option, which is very popular in some industries. So jump back into our software here. So let's create a couple of surface points. The first thing I want to do is make my CAD exclusive. So I'm going to click on my CAD up here in the left part of my screen, upper left, E for exclusive, and now have just my CAD model exclusive. So let's go ahead and construct some points. Let's construct point, surface point. Let's go ahead and construct a few surface points. Now, much like this name implies, you're gonna have to build these surface points on the surface of your part. They're automatically gonna jump onto the surface. So even if you try and get really close to a line here, it's automatically gonna jump it to a surface. So let's go ahead and build a few different surface points here. These are pretty basic, pretty easy to create. Let's go ahead and create 3 on our top planar surface here, right below where it says GOM. So hold control, select a point there. I'm going to use my green check, control, left click, point, control, left click, point. Now, my naming convention started off at 0.3 because I have those other points created before. If you want to rename these to make it something, you want to name them point A, B, C, whatever it is, to help you figure out the naming later on, by all means, you can change them up here. Alternatively, close out of this, click on it, and you can rename it down here, or you can use F2. You can name it whatever it is you want to name it. So let me jump back into my box here. We've built 2 points. I'm going to build one more down here. And because we're going to be using an alignment, or we're going to be building an alignment off of these, make sure that they're pretty well spread out so you get a good sampling of data when we build this alignment. So we've got 0.345 on our flat surface, top planar surface here. I'm going to build 2 points on the end of our part here. Again, create one at this flat surface, making sure you don't grab that chamfer, making sure you're not too close to the edge. You actually build it on the top here. Just this nice flat planar surface on the edge of your part. Again, make sure you're using your CAD model so you're not building these on the mesh. Make sure your mesh visibility is off. In my case, it's kind of bumping out on the end here. And so just make sure that you're working on your CAD here. I got 3 on my planar surface up here. I'm going to build a second one on this plane over here, my little green check mark. And then I'm going to build one more along this bottom plane here. Just anywhere, but again, make sure you got it on that planar surface. Anywhere along this plane here. So we should have 6 surface points built onto our CAD model here. Once you've built all 6 of those, go ahead and hit create and close, or create that last one and then hit close. We've got our 6 points here. I'm going to give all of these guys a measuring principle. And I'm going to right click. I'm going to go back up to my measuring principle list here. And I'm going to do a intersection with mesh measuring principle, which is going to take the normal direction of that point and build it directly there on the mesh. So intersection with mesh. Once you've highlighted all of those guys, pretty easy little dialog box here, just asking what mesh you want to build it on. Automatic is fine. Say okay. Those all go from red to blue. So now we have satisfied the parameters for all of those points. And so now we've got our surface points here. And so now what we can do when we've got these surface points is we can tell exactly how far away the mesh surface is on this part. If you click on one of your points, go to check, and then check the deviation in the normal direction. We'll say okay here. So our deviation here is 0.06. So our mesh is below where our point is, which you can visualize by turning on your mesh. You know, if you see down here where you see your mesh above the CAD, it would make sense if we put a point here, we would have a positive value. But in this case, we've got a negative value. It means our surface is below our CAD here. Our deviation in the normal direction is below where that CAD is. So we've got 0.5 here. If you like, you can give all of these guys a DN check, deviation normal direction check, and you can see that on our flat surface up here, it's a little bit more stable, but on the left sides over here, it's a little bit more variation, which is actually a little more apparent if you look at it. It's kind of bumped out on the sides here, and then this bottom surface is about in between. I'm going to turn off those deviation checks though, just by highlighting all those guys, going to my checks, my inspect wheel here, and just unchecking this, just so it's a little bit easier for them to see. Okay, now that we've got all of our points there, let's go ahead and build an alignment off of these. Now the alignment that we're going to build next is called an RPS alignment. RPS stands for reference point system, and I'll actually bring up the PowerPoint slide while I'm talking about this. This is our RPS alignment. And the RPS, again, reference point system. We're going to be using those 6 points that we built on our surfaces to align the 2 parts together. Now, this is really popular in, I've seen a lot in automotive. There's a 6-point nest that some aerospace companies will use when they're doing airfoil inspection. It's a couple of different names for it, but I referenced like a point-based alignment is generally a pretty popular alignment type. In this case, we're sort of mimicking a 3-2-1 alignment, 3 points to make a plane, 2 points to make a line, and then 1 point down here. So we've locked all of our degrees of rotation, degrees of freedom rather. So when we throw this into an alignment, it's going to be nice and stable here. So let's go ahead and do that. I'm going to turn my mesh visibility off. So I've got just my CAD visible and just my 6 points visible here. And I believe I'm going to actually highlight all of these guys just because I don't know if it's going to cause hassles in the future. I'm going to highlight all of them and then go to the middle button on my eye inspect wheel, the edit. And I'm going to choose the visualization. I'm going to choose just the name, just so it's the points and not like the distance check that we had used, or the deviation and normal check we used earlier. I don't know if that would make issues, but I just want to keep it clean just in case. So we've got all 6 of our points. We've got our CAD. Let's go up to our operations. Let's go down to alignment. And we can go to main alignment. Alternatively, we can find it over here in our alignment button on the top right of the screen. But I'm going to go back to operations, alignment, main alignment, and RPS. So that's where we're going to find our complete list of alignments. And in this case, our initial alignment was our pre-alignment. We're going to create another alignment, which is our RPS alignment. So RPS, we have this blank dialog box here. Now what we want to do is we want to import all of those points that we've created into that dialog box so the system knows which points to use to align these 2 bits of data, the CAD and the mesh. So I'm going to hold Control. I'm going to highlight all of them so they're all grayed. Alternatively, you can grab them each individually, but grab them all. Use this little icon, the bottom left of your dialog box, add selected elements. So our add selected elements button right here, it won't become available to you unless you have selected points on your screen. So just make sure you remember to do that. Add selected elements here. It's going to automatically bring them into this list. And based off of the normal direction of those points, it's going to try and assume the direction you want to lock it into. So in this case, we have point 3, 4, and 5 in our Z direction, which is right, 3, 4, and 5. We've got 0.6 and 7 in X, which is correct as well. And then we've got 0.8 in Y, which once again is exactly what we want. So we're all good there. If you've got them on a chamfered or a rounded surface, or if you've got them on some place where they've got a normal that's sort of not as straight as what we're working with here, you can adjust that direction by dropping down this list here. So you can see that we've got a deviation of 0 at each of these points. We're locked into each of those points on our part here, which is great. That's what we want to see. Now that we've got all of our parts imported into our RPS dialog box here, we've made sure that our directions are all straight with our part. Let's go ahead and hit OK. And now we have an additional alignment option. So let's go to the top right of our page here. We can see that we had our original alignment where they're off in random space. We had our pre-alignment, which was just a global best fit of those 2 parts together. And then we've got our RPS alignment, which is locked into those 6 points. Now, you'll notice I have some issues going on in my project. Let's go ahead and check out what those are. This is saying the element is not included in the report, which is just, excuse me, just saying that if you're building these elements, you might as well report them. We'll get to that in a little bit here, no big deal. So let's go back to my Explorer. It's a good habit to be in is to just check what your status bar is telling you. It's a really good way to make sure that your project is being created completely and you're not forgetting things and letting things slip through the crack. So let's go ahead and check the deviation at each of these points by, again, Control, highlighting all of these. I'm going to open up my eye inspect wheel, Control right mouse button. Let's go to our checks, and I'm going to hold Control, and I'm going to say X, Y, and Z. And this probably will be easier to see if I make my decimal places larger, which I guess I probably just should have done in the first place, but I gotta learn things the hard way sometimes, right? So we've got 0 deviation in each of these directions. We've locked them into these axes here. Clean up my screen a little bit. Oops. We got our RPS alignment. We're checking the X, Y, and Z in each of these. And then if you notice, it might be hard to see on my screen, but one of the directions is actually more bold for each of these points, and that just means that it's being constrained in that direction. And so you should expect to see 0 deviation at that point. So to satisfy our status bar up here, let's go ahead and create a report page out of our data. Create report page. This will be RPS Align. Edit content. Adjust wherever you want to see those guys at. And then we can just say okay. That looks good to me. Say okay there. And now we've created our RPS alignment. Let's go ahead up here and see what this is saying. Oh, this is what it's saying. Our deviation to normal for each of those points is not included in the, that's all right. We can go ahead and select those guys and just say accept, just so it doesn't give us a hard time. So that is our RPS alignment based off of our created surface points. So let's recap in our PowerPoint here. So we did a create alignment dropdown off of those surface points. We had imported all of our points into our dialog box, and then we made sure that everything was constraining the correct direction based off our direction dropdown for each of those points. We applied the checks in the X, Y, and Z direction for each of those, and we can see the deviation goes to 0 when you are aligning into that specific axis direction. So let's bump into, I believe, our last topic of the day. Let's begin some inspection without CAD. We will start with our 3-2-1 alignment, and then we will jump into some inspection without CAD on just our mesh file here. So let's jump into our software. In this case, we're going to make our mesh exclusive. I'm just collapsing all of my menus over here on the left side of the screen. If you've got a whole bunch of them open, it's not a big deal, doesn't change anything. Again, I just like to keep my screen a little bit cleaner. It helps me stay organized within the software. So I'm going to make my mesh exclusive by clicking on this guy, E for exclusive. And so now I have got just my mesh file here. Now, what we can do, and which is going to give my status bar up here a whole fit, is that we can give just this mesh an alignment in space. So we can do that by going to Operations, Alignment, Initial Alignment, and we can give this guy a 3-2-1 alignment. And you know what? You know what I might do here, just so that, no, I'm going to continue on in the software here. Sorry, I'm trying not to be wishy-washy here. Let's go, yep, Operations, Alignment, Initial Alignment, 3-2-1, and then we can choose 6 points rather on just our mesh file to square up just our mesh file in space. So this sort of segues us into an inspection where you don't actually have any CAD within your project. So if you were doing reverse engineering or something and you're trying to derive points or inspections and measurements off of just a mesh file, you have no CAD in your project, you can do these following dimensional checks and inspections without any CAD. In our case, we have CAD in our project. We're going to sort of ignore them a little bit. So bear with me here. If you guys want to see a little bit, maybe a little more simple reverse engineering type inspection later on, we can definitely reach out to you guys and help you with this. But this is just an introduction to mesh only inspection. You do not need to have CAD in your software to do any of these inspections. So if you want to derive elements and geometries from just your mesh, it's very possible as well. Short segue there. So let's get back into our 3-2-1 alignment. So we're looking for 3 points in the Z direction, 2 points in the Y, and 1 in the X. So let's go ahead and build 3 points here. Again, I'm just going to hold Control, left click, for our points. Anywhere on our planar surface up here. 2 points for a line. And then 1 more point for our single point. Be very similar to our RPS alignment, but if you remember, our RPS alignment is sort of mimicking a plane line point alignment as well. And it's going to be aligning those CAD and the mesh together based off of those 6 points. In this case, we're just giving this mesh an alignment in space. We're sort of giving it its own origin here. So we say, okay. And now we have our 3-2-1 alignment, and we have this origin based off of this bottom left corner. Our plane and the top surface point over here, and our plane line over here rather, and then our point down here on this flat surface. So this is our 3-2-1 alignment here. So this is just how you would line up the mesh in space if you just need to have an origin point at the bottom there. Turn that guy. I'm toggling on and off my origin point here by F9 and F10. So F10 turns it on, F9 turns it invisible. So F9, F10, that'll be in your short keys list up here, edit, application settings, shortcuts if you want to see where that guy is. But again, F10, turn it on, F9 to turn it off. So now that our mesh is aligned in space, let's go ahead and do just some very basic dimensional checks on our mesh. We go back up to our construct menu, and let's go ahead and measure one of those cylinders. But instead of going to our auto cylinder on nominal, which we would build on the CAD, we're going to go to the very bottom, which is our fitting cylinder on the mesh. And this is just creating a cylinder and best fitting it onto that geometry that we're selecting. So fitting cylinder, it automatically brings up our construct fitting cylinder dialog box. We're going to control left click on any cylinder. So I'm just going to select this guy down here, control left click, and it's going to automatically grab the data that it thinks is best to create this cylinder. It's going to get rid of some outliers in there, so it's not going to select really bad data. We can create and close that guy. And now that we have this cylinder 3 with my normal going into the part, we can now just grab that tag, bring up our inspect wheel, bottom right pie slices our checks, and we can just check that diameter. We'll say okay. Now, what's important to note when you're doing just dimensional checks on mesh is that it still is looking for a nominal value. And so in our case, on our tag here, we've got a nominal value of 0 because we're not referencing any CAD. It's still looking for it. So it says, this is your nominal value. It's nothing because you don't have it. But we have an actual value and we have the deviation, which in case is huge because it's deviating to 0. And so any value that's an actual is a deviation. We can visualize this a little bit different if we go to our deviation, and it'll show us just the deviation across that part, which is huge. But this is how we're seeing our dimension on our mesh here. So let's go ahead and try something else. Oh, actually, before I do that, no, I'll show you on the CAD, or on the cone rather. Let's go ahead and choose this cone here. Construct cone, not nominal. We're not building on the CAD, we're building it on the mesh. So let's go to the very bottom option, fitting cone here. Control left click, grabs those points. The red is the selected data that it's using to build that cone. So the red is not bad, it's just what the data it's selecting looks like. Create and close this guy. I'm going to control and right click, go to my checks for this guy, and we can check the angle of our cone here. Now, what I should have mentioned before is that you can actually change this fixed value. We have no option to change it to versus nominal. So if you have a drawing for this part, but not CAD, and you know that this is supposed to be a specific angle, say it's supposed to be 27, we can change that fixed value to be whatever it is that you want to measure versus, and that way you have a nominal. It's not actually, it's a nominal value, but it's not based off a nominal element in your project. I hope that makes sense. So this is just the basics of creating geometries on just your mesh. You can measure any of these geometries that we measured before, but instead of using your auto elements that we were using just go to your fitting elements and best fit that element onto your mesh. So back to our PowerPoint here, and we'll recap that. So inspection without CAD is our cylinder. Again, our construct menu down to cylinder. Our fitting element, we created it on our part there, create and close that, and then just check the diameter of that guy. Same thing with our cone, construct menu, cone, fitting cone. And then we checked the angle of that guy. In our case, we changed this fixed value. Instead of it just being 0, we changed it to what our drawing said. And now we can see what the deviation between our nominal drawing and our actual is. So that sort of brings us to the end of our day 2. So our summary of today, we went over that eye inspect wheel. We went over the introduction to our measuring principles. We were constructing nominal elements. We did a couple of different checks, such as outer disc caliper checks, 2-point distance checks. We constructed some 2D elements on our section cuts there. We created some surface points and then used those surface points to create alignments and alignment. And then we did some basic inspection without CAD. So tomorrow, we're going to go into a little bit more in-depth with our GD&T. We're going to get into some basic GD&T creation, and then we'll show you guys the super slick GD&T Quick Creation menu, which is new, I think, in this version of software or the version before. Doesn't matter. It's really cool. You'll want to see it if you use GD&T at all. We're going to go into some custom report pages. We're going to have a guest presenter who's going to show you guys some really cool in-depth analysis you can do and some cool custom report pages. And then we'll get into the differences between the GOM Inspect Free, which we've been using this week, versus the GOM Inspect Professional. There's some very fundamental key differences there, but you remember you can get a free version of the GOM Inspect Professional with that Try Professional button on the top of your screen. You'll definitely want to see that if it's something you're interested in getting your hands on. And then we'll show you guys some of the big features of the GOM Inspect Professional software. So, without further ado, let's go ahead and jump into the Q&A. I'm curious to hear what you guys are interested in hearing about today.
Thank you, Garrett. So our first question that we have is, for this project, we're using millimeters. I usually do projects in inches. How can I change my units, and if it is possible?
Yep. I heard myself echo through Sean's mic there. That was kind of funny. Yes, good question. We had briefly mentioned this yesterday, but if you need to change your units in the software here, top left of the screen, go to Edit, down to Application Settings, and then you've got your Preferences. And then within here, again, unfortunately, you can't change all of them at once. You've got to just change one unit at a time. And so in this case, we can change our length from millimeters to inches. Apply that, and you can see that my cylinder 3 is changed from metric to imperial. So I'm going to leave my back at millimeters just for continuity, but pretty easy to get in there. So again, Edit, Application Settings, at the very bottom, Preferences, and then default units over here on the left side of the screen.
Next question. Can you create a different coordinate system than the one imported from the CAD model?
Yes, we had talked about that yesterday, so I don't want to hang on that one too much if there's other questions. But yeah, you can create local coordinate systems based off of geometries. You can create them to base your GD&T inspection off of. So construct local coordinate systems. You can create datum systems and create local coordinate systems based off of geometric elements. So you could create that element first and then build a local coordinate system, and then you can shift your dimensional checks to different local coordinate systems. So I know there's a lot of like airfoil analysis is based off of a bunch of different local coordinate systems. So it's definitely something you can do, and it's very easy in the software.
Here's another one.
Hey, Sean, wait.
Yeah, go ahead. Wade.
We just might want to make sure that after you create that local coordinate system, when you go to apply your check, there's a drop-down box, and maybe you could show them, Garrett, to make sure that they pick that local coordinate system. That way it'll dimension out with that being the new 0 point. Just real quick. Yeah, it's grayed out there right now because you don't have it.
Reference it.
So yeah, basically once you have a new coordinate system, that drop down box would become active. And then you could say local coordinate system 1 or whatever you name it. And then you would dimension according to that being your new 0. So, and it looks like it's because you edited.
Yeah.
Only the professional.
Okay, hopefully that answered your question. So next question is, if I want to measure a partial cylinder, will the cylinder construct or circle construct tool work for that? Or is there a way to construct an arc?
You can construct partial cylinders. So something like this, the inside of this G, it's not a complete cylinder. You can still construct a cylinder based off of this, and it will use the data that it has to derive the rest of the cylinder. Josh Old, I think he had mentioned yesterday, you need to have a certain amount of the software. Just naturally assume you can grab any small amount of a circle or a cylinder and it will automatically build the geometry from it. But you want to make sure you have enough of the geometry to accurately grab it. The less data you have to derive that geometry, the less confidence you'll have in that actual, and that's just a fundamental metrology principle, is you want to make sure you have as much data to derive an element from in order to build it. You can still, if you have, so you can build it off of these incomplete geometries here, but if you want to build them, you can construct curves or sections and then fit elements to those curves or sections as well. And that will still allow you to build your diameters or radius checks or whatever off of incomplete radial surfaces.
And to go just a little bit further, like you were on that little fillet radius on between the upper and lower part. So that there is a relatively small arc length of the entire circle, which will accurately compute size. What it starts to do is become inaccurate on the center point, the smaller that arc length is. So like the G, the bottom of the G, we have a good coverage around our 365 degrees, so we can accurately find the center point as well as the size. But on that fillet radius, we start to lose a little bit of the accuracy, and the smaller that arc length would be, the less accurate the center point would be. But we can still define the size of that radius with that size of a arc length. Hopefully that adds a little to that answer. And
thank you. The next question is, can we create point on cylinder axis 1 and 2 and ask for the X distance instead of creating a plane on top of the cylinder?
Like saying, make a point off of that center line of the cylinder instead of, we're building that point derived from the center line of that cylinder. We're just giving a point for that center line to intersect with, because when you're trying to build just a point-to-point distance off of 2 cylinders, doesn't know which point along that center line to grab. You can build a point on the line of that axis. Sean, can you read that question one more time? I think I'm understanding it correctly, but maybe.
Okay, it says, can we create a point on cylinder axis 1 and then cylinder axis 2 and ask for the X distance instead of creating the plane on top of the cylinder and intersecting them?
You can build a point on that the cylinder axis. You can physically build that point on there, but I don't think that the point-to-point distance will actually allow you to. I think what you're asking, you feel free to correct Sean if I build this incorrectly, but construct cylinder. Actually, we have our 2 cylinders here. Let me just grab those guys. We've got our 2 cylinders here. You're saying construct a point and a create point, and those are just at the bottom of these cylinders. So at the ends of those guys, and I believe.
Hey, Garrett.
Yeah.
construct point from line, and then you can pick which end of the cylinder you want. See how it's got first or second?
There we go. Great.
So yes, you can, but the problem with this becomes
Referenced.
depending on what type of radius or chamfer or whatever there is from the top plane to the cylinder is going to change the location of that point. Where if we build the plane and intersect it with the axis of the cylinder, you're getting a solid stationary point every time you build that. Does that make sense?
Yeah. It makes it look easy and clean on the GOM block here, but I could see it running into issues on a less.
So turn on your mesh while you have your CAD on and zoom in to the edge of that cylinder. So see how there's a radius from the top plane to the inside cylinder?
Mm-hmm.
So as that changes from part to part, the location of that endpoint is going to change. Where if you build it as an intersection off the top face, you've got a much more consistent location of your point-to-point distance.
Yep.
So that's why I would steer away from doing that, even though you can. I mean, it's your choice.
I could see that becoming more repeatable as well. If you were to do a trend analysis of the same part, I could see this becoming kind of your repeatability degrading a little bit, whereas deriving from that plane is a little more stable.
Correct. So yes, you can, but I don't know that it's the most repeatable and accurate from part to part way of doing it.
All right, cool. Well, I hope that answers the question.
Okay. Next question that I have is, if I have a bad scan and I fit a primitive geometry to it, but I want to exclude some obviously bad region, is there a tool to do that, or do I have to edit the mesh first, example, smooth it, or delete the bad regions?
Yep, you can edit that mesh first, but you definitely can. You can edit what your selections are. So let me grab one of our cylinders here. So when we built this cylinder originally, I'm gonna walk myself into a corner. You can, in the professional version, you can go in here and edit the data that it's selecting, but that is a tool, I believe it will say professional. Doesn't, wow, cool, okay. Nice, it does, okay. I'm not a liar. So when you go ahead and construct these points, so in this case, we've got a very nice, smooth, complete cylinder here. And so there's not a whole lot of data that we want to exclude out of this. But when we go in here to construct these cylinders, and go down to fitting cylinder here, and we build it on our mesh, we can edit the data that it's choosing. So in this case, we've got all this data that's red, but we can use our 3D selection tools to deselect certain bits of data here. So in this case, we can deselect this strip, or say we had some burrs or bumps or something along the top we want to exclude. And you can just grab out this data and deselect some of it. And again, you've got the whole option list for deselecting.
Maybe hit the button decrease selection and show them how it moves away from the radiuses.
Yeah, this is a good best practice. Excuse me, good best practices in general is just using this decrease selected area tool, which is nice, and it allows you to decrease the distance or polygon rows away from the edges here. So it allows you to pull them up from those chamfer or radius surfaces, and you get a little more confidence in building a high quality cylinder here. So I find myself using this function a lot, but you can also use any of these other 3D selection tools. And then once you've edited your data, you can create and close that guy. And now this cylinder is based off of the data that you've adjusted to select. We're still building off of 71 100 selected points.
Cool. So the next question that I have is, can I import an inspection point locations into the free software?
I believe you can do this in the free software. I guess I haven't really tried it so much in the free software. In the professional version, yes, it's really easy. You can import CSV files, which is point coordinates, and you can bring in all of those points into your inspection, or you can bring in a CAD model with PMI, which will have built-in coordinates in them. So you can import that data very easily, as long as you can export it into a file format that the software is able to recognize.
So the next question here is, anything creased in construction is true geometries? That, I guess he was just asking, is of having a crease in construction that considered true geometries?
I am not exactly sure what that question means. Maybe if you could specify with Sean or clarify a little bit, or follow up with us afterwards.
Yeah, maybe this would be better with a phone call or a team viewer, so we can better understand. We make sure we understand the question properly.
Okay. I also had a request for Garrett to kind of try to show them the angle, how to create the angle again.
Can absolutely do that. I can definitely do that for you guys. So we started off with just our basic mesh here, and we constructed a section cut because our angle is based off of 2D geometries. We want to create a 2D measuring surface. And so we're going to go to construct section, single section. In this case, it's automatically jumping to our previous selection from yesterday. But we can adjust this to whatever position and whatever reference plane you prefer. In this case, we can just make it 25 millimeters. So 25 millimeters off of the plane, or off of the Z plane, cuts it right through where it says GOM here. And again, we're looking to our yellow triangle to tell us what we need to do next. So please select points in the 3D view, which is just wanting us to select the data to cut through. So even though it knows it's cutting through this CAD, it wants to know specifically. So we can actually just choose part of it. I'm just grab this patch of the O, and we can see we make our section cut through the O here. But in our case, before, we just right-clicked and selected all points of the element. And it cuts through everything. So we create and close that guy. And while it's still highlighted here, you can click on it and highlight it in red here, hitting E to make it exclusive. And it's red, so we need to give this guy a measuring principle. I'm going to just say referenced construction. So it changes our section cut from just exclusive to CAD to now we have a CAD and a mesh version of that section cut. So next we need to go and build our lines off of our section cut. So construct line, line, and we're going to go down to fitting line here. We want to fit it to this section. So I'm going to hold Control, click, create, hold Control, click, and create. I flipped the normal direction of this plane as line 3 before, but I'm going to leave it this way this time. We're going to say create and close after we've built both of those lines. And again, we need to add a measuring principle to those guys. So let's go to measuring principle. I believe this was fitting element. We're fitting it to that section cut. Say OK. So now we have 2 lines. And now that we've got our 2 lines, it's a very basic 2-direction angle check. Go up to construct, down to angle, 2 directions angle. Go ahead and click on that guy there. Just looking for 2 directions. So again, you can drop them down in your list here. I'm just going to Control left click each of the lines. Once we've got both of those guys here, we can adjust which direction it's measuring off of. Based off of my angle here, it's choosing this outside angle, but you can adjust those, invert those directions. So we're measuring inside our M here, create and close. Now we've got angle 2. One more measuring principle, referenced construction, because this angle is referencing both of those lines. And then once we've got this angle 2 built, we can go to our checks on the iInspect wheel and just check. In this case, it'll be, we could check an XY or just arbitrary angle check. So there we go. I hope that was slow enough for you. I get a habit of talking fast. So if there's anything specific about that process you'd like me to show you again, I can definitely do that. But that is the basics of a 2-direction angle check.
Thank you, Garrett. One question is, can we check angle using both surfaces, not using a section?
Yeah. Gosh. It's like a tough one to answer, because what you'd be doing is you'd be building, you would need to like derive a line, 2 lines from that. So if you had like geometries, you could derive them from. I mean, you could build like a 2-point line here and a 2-point line here, create and close, and then we have both of, you know, those lines there. We're not building it off a section cut. Yeah, I may be talking myself into a circle here. You could probably build points. Let's try that. This is like a, you know, one way to skin a cat. No cats were harmed in the making of this training. So we've got our points here, intersection with mesh. I apologize for going fast. I'm kind of trying to make sure I can do this before I say, yeah, definitely yes, or no, definitely not. So create line based off points. And then we've got those points are based off, or those lines are based off of points. And then we can do construct and angle. And I have to forgive my crazy naming scheme with these lines. It's just based off of a previous naming scheme I was using. Oops, construct, angle, 2 directions, angle, 86. Convert that inside again, 3.82. And then referenced construction, and then angle. So in this case, if we were to do just an arbitrary angle check, I'll do both. It might be, yeah, a little bit different here, because the difference in the difference in our build here is that we're basing those lines off of arbitrary points on the side of that, whereas when we build it on a section cut, it's constraining it in that X direction. But as long as if you choose the right angle check, it will give you the correct angle here. So yes, you can. You just have to be more specific about how you build that angle and then what you're actually measuring, because you can easily get a wrong answer if you don't build it on a 2D geometry. Just a little bit easier to derive that element, those required elements, and then subsequent angle if you've built it on a 2D geometry.
Thank you, Garrett. So next question is how do I check angularity of a line in a section? What is the angle between actual as compared to the nominal in this section?
If you're actually looking for angularity, I'm going to have a cop out of an answer, and I'm going to say wait till tomorrow to bring up GD&T, because we'll go into that in a little bit of basic. If you're just looking to check angles on a section, that was what we covered here. So I think we've got probably some other questions to go over, so I don't want to have to redo this process again. If you have questions about it or you want to get some more help on it, we'll definitely love to help you afterwards. We can team you in and help you do some of that stuff. But again, angularity and an angle are 2 separate things. If you're looking for actual angularity, we can discuss that tomorrow with the GD&T topic. This will be your angle on a section cut, just deriving lines from that section cut and then checking a 2-direction angle on them.
Next one is there a way to edit the definition of a feature and have any measurements based on the feature update as well?
Yes, but not in the free version. Again, kind of a cop out of an answer is that is one of the blatant limitations of the free version of the software, is that once you build things, you're kind of stuck with them. If you want to have them, the term parametric is a big one that they use in reference to the ATOS professional version. And that is, you build things on top of each other. You build your cylinder, then your plane, then your point, then your two direction distance, and 2-point distance rather. And then, if you want to go back and you want to edit that cylinder that it's built on of, you can edit that cylinder, and then everything else after that will recalculate and recompute. It's not something that happens necessarily in the free version of the software. At that point, if you've built everything up to this point, you need to change something from down here, you have to delete all of it and then recreate all of it. So the free version is good at practicing, making you practice, because if you do something wrong later on down in your process, you're going to have to redo all of it. So it's just sort of a limitation they build into the free version of the software. It's more of just an introduction and a viewer, and it gets you confident and comfortable with the software. But that functionality is only available in the professional version of the software.
Okay, trying to go through these questions real quick. I know we kind of didn't go over this one, but they had a question about tolerance tables. Do you guys know how to make tolerance tables or import tolerance tables in to the software?
That was one that we actually started to get into last time in the training. And this is a little bit more of an advanced topic, just because it's so subjective to what your tolerances look like and the tables look like and importing it into your projects. I personally am not a huge expert at that. We don't run into it a lot. And so it's hard for me to say definitely yes or no, or this and that. If you need help importing tolerance tables into your project, that's probably something we'll need to work on you with one-on-one. It's not as easy as just showing you something real quick in the software. Unfortunately, it's just a little bit more involved. It's definitely something the software can handle, but it's just a little bit more involved.
Okay. The next question that I have is there a difference in how it is fitting to the mesh between the construct versus the edit geometry-based method?
Can you read that again, Sean?
Let's see if I can word it different. Is there a difference in how it is fitting to the mesh with the measuring principle fitting element versus the edit geometry-based method?
What edit geometry-based method? Like going back in and editing the data that you had. Wade, you understand this one at all?
Not really. Bill, do a cylinder or something, and so we can see the fitting algorithms. So just hit your method. I mean, there's those different choices, which you kind of already covered, right?
Yeah, kind of just talked about. Kind of going off what he was saying is we've just been using the regular Gaussian best fit method to fit our elements onto our data. It's the default method, I think, for most of these functions. If you need to change that fitment method when you go into build these elements, you can change that in here. That geometry will change depending on how or what data you're selecting here. So if you decide to edit some of your data in here and you reduce your point selection, you can see that our selected points reduced, our deviation changed a little bit. And so depending on what data you select will determine the size and form of that geometry, and then also what fitment method you're using up here.
Right. The direct help should give you information on what the different fitting algorithms are.
Yep.
Plus, you have a little diagram in the dialog box that gives you kind of an overview of what data it's selecting to fit that particular type of feature.
These are sort of fundamentals of metrology as well, these fitment methods. So if you've worked with CMMs or other measuring systems before, chances are you've heard of or you've seen these other fitment methods. So this isn't something that's exclusive to GOM, but it's we have the whole list of them in here, which I don't know if it's exclusive to our software. I would doubt it, but this is definitely a more common measurement fundamentals.
Hopefully that answers the question. I'm not 100% sure what they were referring to with the geometry.
I think we nailed it, Wade.
All right, good.
Let us know if we didn't, and we'll happily help you out some more.
So this next question's more with, I guess, the option with the caliper check. Can you explain what the lock point one does?
Yes, I can. Yes, I would love to. Lock point one. Actually, let us let the software so I don't botch it. Okay, so I think what it's doing is, gosh, I wish I could use a whiteboard here and draw. I think what locking point one does is generally with that outer disc caliper, what it does is it moves in on two sides and then touches the first bit of data it can get right there on those two sides. I believe what the locking point one does is that wherever that point one is, wherever it is on that mesh or that CAD, it's locking it right there, and then only your second caliper is moving in to touch that opposite side of the part. So it kind of, regardless of the surface on the point one, wherever your point two is, that's going to be the only one that moves in. I believe, I haven't used that one in a long time, but I think that that's what this article is saying, is that it's lock point. The software uses the point one as a touch point. The caliper does not touch the point one of the element anymore. Unless I'm totally misunderstanding it, I believe that's what it's saying.
Give me 1 second. I'm trying to look through these real quick. So one question I saw earlier was, Garrett, you mentioned that there are, if you use a different measuring principle, will give you different results. Do you have an example, like a good example to show that difference?
Yes. So as I'd mentioned earlier, measuring principles are very important because it determines the fitment on your actual measurement or your actual mesh file. So one of the best ways to show this, and this is probably a hard part to show this, so I'm actually just going to show the, gosh, I don't really have a good chamfer on this part to show you guys. But one good one to think about is with points, surface points. So the two big measuring principles that come into play with surface points, because it has a normal direction here, is we have intersection with mesh. We've got project point onto actual. And those are our two big common measuring principles for points. Now, the way that they do that is, or the way that these work is that intersection with mesh projects that point's normal directly up that normal, positive and negative, and it finds the closest bit of mesh wherever along that normal it can find one. And so if there's no data below that CAD at that specific point, it will fail that point. You will not be able to build that actual point. You can give it a measuring principle and it'll still have a red flag and it'll say, can't compute, can't do this. Whoops, this other one we have in here is we have this project point onto actual. And what it does is it's regardless of that point's nominal, it looks for the closest bit of data in a radius around that point. And so even if you don't have data around that surface point, it could build you a point somewhere else. And so you got a hole of data around that nominal point. And if it right on that nominal, or that normal direction of that point, you've got zero data. If you select that project point onto actual, it's going to sample around and it's going to grab the closest bit of data that it can find. That's a little bit more important on like rounded surfaces or like hemmed edges or something. In automotive, if you're measuring class A surfaces like doors or hoods or something like that, and if you've got a point on a hemmed edge, generally that that normal direction is important and you want to choose intersection with mesh. Now, if you're building on a flat surface like this, you can give them either one of those measuring principles. And because you've got plenty of data on that flat surface, they're both going to give you a point almost exactly in the same spot. But again, if you're on a rounded surface or a chamfer or an edge somewhere and you choose one of these two measuring principles, you're going to get vastly different results. And there's a couple of different, like fitting element. If you choose a fitting element on a point, it tries to fit it closest to like an edge or something. And then you just look at it and it could just be wrong. So there's a lot of different small nuances with that. That's my favorite, is those surface points, because it's usually really easy to see, but it's also a lot easier to see if you have the right part to visualize it. There's some good intersection with mesh here. Go ahead.
Yeah. That's what I was gonna say. I'm pretty sure we have the visual example in the help.
Yep, so intersection with mesh takes that point right along its normal direction. But if we've got project point onto actual, yep, so here it is on our rounded surface here. It's not taking that normal into account, and it's just building it and the closest bit of data that it can find. And you can see right here, this is incorrect. It's building this point on the CAD here, you want on this flat surface, but it's building on this point here. So that, in my opinion, is the easiest way to visualize the difference in measuring principles, and it's kind of the most blatant. And if you work with a lot of surface points, if you've worked with CMM inspection before, you'll kind of recognize the discrepancies between the two of these. But for a lot of 3D geometries, you'll just use fitting element, but also reference construction comes into play, yada, yada, yada. Anyways, I hope that helps answer your question. Reference or measuring principles can be a little bit confusing. We've got some good resources on the differences between the measuring principles. So if that's something you want a little more literature on, we can definitely help you out with that.
Thank you, Garrett and Wade. The next question, is there a way that I can check whether my alignments are good, like pre-alignment versus the RPS alignment?
Good alignments are subjective to the part. What's good for one department could be bad for a different. What's more important is that they're consistent. So if you're checking one part with your RPS and you check the second part with a pre-alignment, you're going to have totally different results, even if it's a virtually identical part. So if you had an alignment that you're measuring with your CMMs or something, you've got functional gauging, or if you've got, you're using calipers or something, you're measuring off of, bad example with calipers, but your CMM and stuff, usually they have like a 0-0 point, or like tooling balls that they measure off of. If you're measuring that same part, that same fixture, you just want to make sure that you're using those same alignment points. There's 101 different ways you can align your parts together, but there's not 101 right ways. There's 101 wrong ways though. So it's just making sure that you are consistent with how you've done it before, so that you're getting consistent measurement results. And if you decide to go to a different alignment, making sure you continue to use that alignment for your subsequent parts. Your pre-alignment is almost never the alignment you'll use for your final inspection. It's good to get the two parts close together. And then when you go do an alignment afterwards, it gives you a good basis to align those two parts together. But generally, you're not going to be using your pre-alignment for in-depth inspection. We've just been using it here for the training, just because we don't really need anything more robust than just a basic pre-alignment. That's going to come from like your quality and your engineering department to figure out how do you align those parts. Again, consistency is key, not so much one over the other.
And also, Garrett, what you showed earlier with the RPS alignment of reporting out your XYZ values, that's proving that your alignment is correct. As long as the nominal features that you chose off of your print or your CAD or your PMI data are correct, once you put the outputs to those XYZ values, that proves that your alignment is correct because there's no deviation there. The only time you'll have any deviation is outside of not being wrong, but if the print calls out for more than 6 degrees of freedom, which means it's over constrained. If you have 3 points that you're using as your primary datum, you'll have 0 deviation. If you add a 4th point, now all of a sudden you'll see some sort of deviation. But that's just because of over constraint. But that would be also you following what's on the engineering drawing or direction from your engineering department or whatever the case may be. But reporting out your actual features is a really good way to prove that you have a good alignment.
Thank you. I think that's all the questions I have.
Thank you, everybody.
Yep. Thanks for joining us for day 2. We will see you guys tomorrow for day 3.
Welcome to day 3 of our GOM Inspect virtual training. If you're returning, welcome back. If you're new, thank you for joining us today. We'll be getting started right now. Without further ado, I'll hand it off to Garrett.
Hi, everybody. Welcome back. Day 3, as Sean has mentioned. Hope you guys can hear me okay. We're going to continue off where we left off yesterday after a little bit of some brief introductory slides here. My name is Garrett Carpenter. Sean Nanyagis is our host. He's kind of behind the scenes. He'll be the one answering the questions in the Q&A. So if you have any questions throughout the duration of the training today, please go ahead and shoot those over to Sean, and he will either answer those as he can, or he will add those to the Q&A roster, which we will answer at the end. We also have some special guests joining us today. Josh Old, the engineering manager for Capture 3D, will be jumping in likely for the Q&A at the end. Darren Marsh will be giving us a brief introduction on some advanced reporting features in the GOM Inspect free version of the software. And then Wade Smith will be joining us for the Q&A as well. And they will also be helping with some of the questions throughout the training. So these are some faces to go with the names that you see in the list of attendees over here. So let's go ahead and carry on. Just a reminder that there will be certificates of completion sent out to those of you who did join us for the training this week. If you did not join us for day 1, if you didn't register for day 1, go ahead and contact us at training@capture3d.com, and we'll add you to that certification list, and those will be sent out in the email. In case any of you are wondering, your names will not all be Garrett Carpenter. That's just me. So let's go over a quick recap of what we did yesterday. We went over a lot yesterday. It's kind of a heavy day of things. So I hope you guys got some time to digest all that information, came back with a fresh mindset on this software. Today will be a little bit less heavy, but yesterday we went over the iInspect wheel and the functions that are included in that. Did a brief introduction to measuring principles, when to use them, how to use them, what they are, where they are. The overview of the workflow in our GOM software and what you do from the beginning of the project, you're importing data all the way out to exporting projects and report pages, constructing nominal elements and then their coinciding actual elements, using an outer disk caliper check to check distances, a 2-point distance creation. You're constructing some 2D elements off of 2D geometries, creating some surface points, and then creating an RPS alignment out of those. And we had a brief introduction to inspection without CAD. So again, I know it's a lot yesterday. If you guys have any follow-up questions, if you were playing with it yesterday or anything that just sort of came up in your mind between then and now, go ahead and throw those into the Q&A. We'll try and answer those as we go. And then if you need help with those after the training, we can answer more questions there. And then, lots of ways to reach out to us, and we can get you some technical support there as well. So let's jump into our day 3 overview. Today, we're going to touch briefly on GD&T. I'm going to not get too far into this because GD&T is a lot to unpack, and I don't want to confuse myself or you guys or portray any false information. So we're just going to go over some basic GD&T creation, more so show you guys where it's at in the software and some of the limitations that you can expect. We also have a really slick function in the software called our GD&T Quick Creation menu, which will allow you to pull out GD&T creation elements and build those really quickly and easily. So it's a pretty neat function in the software. I find that super useful on our end. We're going to go over some custom report pages. So we sort of mentioned report page creation throughout the first couple of days of training. I showed you guys the basics of how to create report pages. We're going to dive into that a little bit further today and just get you guys a little more familiar with the report pages workspace and some of the functions that you can expect to find in that. We're also going to jump into the GOM Inspect versus GOM Inspect professional differences. We're going to show you some of the functions that are available in the professional version of the software that are not involved or not included in the free version of the software. So we'll go over some things like trend analysis and templates, and we'll show you guys some of the things that are beneficial to the professional version of the software. So let's go ahead and jump into a live demonstration, and let's go over some basic GD&T checks. So I'm going to jump back into my software here, and I'm actually just using the project that we ended off using yesterday. If you've been saving these projects and you're moving along with us from the past couple of days, that's great. If you're starting fresh, that's fine also. None of this stuff is dependent on what we've used before. And if there are certain things that I find that we've needed from the previous days, I'll show you guys how to recreate those really fast. So let's go ahead and make our CAD exclusive here. We've got just our CAD model. So I've just clicked and dragged mine out to show element exclusively. Again, you can also use that hotkey. Click on your CAD up here in your Explorer, hit your E for exclusive hotkey. Now that we've got our CAD model exclusive, let me show you a couple of different ways we can create some GD&T callouts on our part. Because I'm a big fan of recycling, let's go ahead and make visible one of these planes that we created on the top side of these features on the top of our part here. So I'm just going to zoom in on this leftmost cylindrical feature. I'm going to go over to my Explorer on the left side of the screen here. And I'm going to hunt through here and try and find our plane that we made on the very top here. So under our nominal elements list, go down to your geometries. This is going to bring out a list of all the geometries that you've created on the nominal element. Let's go down to our planes. We should have 2 planes here. If you've got more, if you've got fewer, that's okay. If you want to create a new plane up here, feel free under your construct menu, auto plane. We're just going to make one of our planes visible. So we've got 2 planes here. I'm going to use my plane 2, make my plane 1 back invisible again. So we have our plane 2 visible on our CAD. So these are the only 2 elements that we have visible in our project here right now. Again, I'm a big fan of keeping my screen clean and well organized. Just it makes the whole inspection process a little bit easier and faster for me. And so I've got my CAD, I've got my plane 2 here. Let's go ahead and click on this guy and then open up our eye inspect wheel. And if you remember from yesterday, we've got 2 different ways to open up the eye inspect wheel. Either we can go to our magnifying glass here in our workspaces bar, or we can control and right click. That's what I'm going to continue to do, is control and right click, just because I'm in the habit of it. I find it to be a little bit faster. So if you've got your eye inspect wheel open, again, make sure your plane is selected. You'll know it's selected because your label for it will be gray. If it's not selected, it'll be white. You can also see that it turns a lighter color. So we've got this guy selected here. Our bottom left pie slice in our eye inspect wheel is where we'll find our GD&T. Now our GD&T callouts that we'll find in our eye inspect wheel down here are going to be the callouts that are available for the feature that we've selected. In our case, we've got just a basic plane and we can do a couple of different callouts on it. In this case, again, I want to rate it. I'm just going to do some very basic GD&T callouts. I don't claim to be a GD&T expert. So if you use GD&T every day and you're really well versed in it, you likely know a bit more than I do. And so I don't want to try and pretend like I'm a master at this and try and teach you guys how to use GD&T. But I'm going to show you guys where this stuff is at and how the basics of it function. So eye inspect wheel, GD&T, flatness. Go ahead and select that guy right here. We've got our flatness callout dialog box here. Flatness in GD&T is a very basic callout. It's just how flat your plane is relative to 2 planes. It's just making sure that it fits within that space between 2 planes. So we can actually visualize that by looking really closely at our part. Our tolerance is 0.1 millimeters. So if we zoom in here, we can see these 2 planes, and that is 0.1 millimeter apart. As we crank this guy up, we can visualize how far apart those are separating. Oops. So again, this is our flatness callout. It's just checking how flat this plane is. So let's go with a flatness of 0.25. Just 1/4 of a millimeter, nice wide flatness callout here. Just going to say okay. And so now we have our plane 2 with a flatness callout on it. So again, we've got our nominal value, which is 0.25. Our actual is 0.17. And our deviation, there's no numerical deviation for this. We can see that it fits within our specification range. If you want a good visualization of how flat this surface is, we can click on the actual check here in our dialog box, or our label rather, hit tab, and under your properties, find your display tab near the bottom here. And let's show our color representation. And then I believe, yep, we can uncheck let me go back and show you how to do that here. So we've got our GD&T check, we've got our plane 2, and we've got all this stuff on top of it here. So let's go ahead and uncheck, make our plane 2 invisible, and then click on our GD&T check, our purple square here, and then show tolerance zone, the virtual condition, uncheck that guy. And now what we're seeing here is the actual flatness of our part. So this is the deviation to a perfectly flat plane on our part here. And so this is what our surface is looking like on the top of our part. So if we want to add some deviation labels on this guy, go ahead and bring out that eye inspect wheel one more time. Go to your bottom right pie slice, go to your checks, and you can check the deviation on this surface here. This will give you an idea of how much this plane deviates to a perfectly flat surface. Okay, so that is our basic GD&T flatness check. Let's go ahead and make a report page of this, just so we can get in the habit of reporting our inspections. So again, go up to our workspace bar. We've got our Create Report Page button. Just click on that guy there, and then we can name this whatever it is you'd like to name it. In my case, I'm just going to call it Flatness Check. Nice and easy. And if you want to change how this is visualized, you can click on your pencil here in the middle of your screen, edit content, zoom in, zoom out, rotate this part a little bit, make it look pretty. You can adjust those labels. We can change the size of those labels if you need to. They're a little bit too big and cluttering your screen. Or if you can't see them very well, you can adjust that size a little bit. We've got our scale on the other side of the screen here on the far right side. If you're satisfied with how that looks, go ahead and hit OK. And now we've got our very basic flatness check. We've got our deviation labels on this guy, checking our deviation, and then we've also put it into a report page so that we can report our findings later on. Go ahead and hit OK here. Let's jump back into our PowerPoint here, and whoops, not our PowerPoint, this PowerPoint, and just kind of briefly recap what we've done here. So again, we're just checking a basic GD&T, a flatness check. So we went down to, yesterday, we went down to construct, did a plane, an auto plane on nominal. And we just built that plane and we gave that a fitting element measuring principle. So if you're following along on this and you want to rebuild this guy, again, construct plane, auto plane on the top of that, just select that top. You're gonna have that red flag. Put your ID inspect wheel, get a fitting element, and then you will have built that on the actual as well. And then we're going to go back into our iInspect wheel, our bottom left pie slice, our GD&T call out. We're going to just select flatness. Once you click on that option here, we've got our check flatness dialog box that comes up here. We can change our tolerance source here. In this case, we're using 0.1. I think we used 0.25. These are just kind of arbitrary tolerances at this point, but that's how you would change those if you need to. And then we also went in here. We showed our local color plot for the plane by turning on the show color deviation representation. And that again is in our properties menu on the right side of the screen. You can find that by hitting tab, and then we opened up display and we clicked the button show color deviation representation. And that's going to show us our color plot on the side of the screen. And we finished things up by creating a report page of this function. Now, the next thing I want to show you guys, which is a really slick function of the software, is our GD&T Quick Creation menu. This is something I was introduced a couple of versions of software ago, and it seems to just keep getting better with each version of the software. I'm personally a big fan of this. It makes GD&T really simple and straightforward, especially with these projects that have a lot of different callouts and just get really heavy with the GD&T. Now, if you've never used GD&T before, it can be a little bit confusing. Datum systems come into play, and that's just geometries and features that you're referencing callouts for with GD&T. And so I'm not going to really get into too many of those functions that require datum systems, because a couple of these are a little bit more easy to understand. But let's go up to our toolbar at the very top of the screen here. And directly to the left of our camera, we have our GD&T Quick Creation menu. Go ahead and drop that down, and you'll see we've got our list of GD&T callouts here. Now, what's cool about this is that we can really easily create a datum system where we can quickly and easily create each of these callouts. And what we had done before when we checked that flatness is that we had manually built that plane, we'd give it a fitting element, and then we'd applied a GD&T flatness check on it. What this GD&T Quick Creation menu does is it takes all of those steps and does it all for us. So you can visualize what it's going to try and build off of by holding control, and it's going to snap onto each of these features. And as I'm circling around each of these features, you can see that it's asking me if I want to build it on each of these surfaces. So let's go ahead and find another flat surface here. just go ahead and build it on our planar surface right below the GOM letters. So again, holding control, our directions in the bottom of the screen there, hold control, left button. It's going to create that element. It's going to build that nominal element. It's going to apply a measuring principle, and then it's going to build your flatness check. And so we're automatically left here with our flatness check, and it automatically gives us an option for our tolerances. So it's built all of those things in the background. It's the exact same steps as we've done before, but it creates all these for us. So really puts the quick in the quick creation menu. We'll say okay with this guy, and there we go. Easy as that. So we've done the flatness check, the same flatness check that we had done up here. We built it much faster and much easier in the software with our GD&T Quick Creation menu. Now, you've got, again, all of these different options that you can choose to do this with. And so if you grab any of these other functions and just hover over these features, it'll tell you what you can build it on. Again, you just grab that, hold control, hover over those options that you want to build it on, and then left click, and it's going to automatically build that nominal element on the CAD, apply a relevant measuring principle, and then it's going to apply this GD&T flatness or GD&T check on that element. Now, you have to be careful though, because as we mentioned yesterday, your measuring principles are important depending on how you want to build this element. And so this just chooses, is for lack of better words, the most common measuring principle there would be. In this case, fitting element was the most relevant measuring principle for each of these elements. And so it automatically applied a measuring principle of fitting element. But if you're very specific on how you build these, where you need to use a different fitment method in those dialog boxes, you'll need to either go back and adjust those if you're in the professional version, or it might be more advantageous for you to build all of these GD&T callouts on these features manually so that you can control the fitment method along the way. We're just going to say okay here, and let's try giving this a color representation. So show color deviation. Again, I'm just hitting tab, opening up my properties menu, going down to display. We can show color deviation representation, and then I'll turn off my tolerance zone virtual condition. And I'm just going to click on my plane 3 here and make that guy invisible. And fortunately, some of my color is underneath my CAD just because it's bowed so much that we're only seeing a little bit, but we can see on these higher areas, these areas where it's more pronounced, it's more proud of the CAD. So you got excess material on these edges here. But again, it just gives you a nice opportunity to see where it is on your part that you've got areas of deviation. And again, if you want to throw up some deviation labels on there, we go to our workspace, the top here, point-wise inspection, and throw some deviation labels on here, hold control. And you can see what the deviation on this part is. Another slick function is if you want to see your maximum and minimum deviation, you can go to your eye inspect wheel and control right click, make sure that your color is selected here, and then minimum and maximum. So our maximum is positive 0.21, our minimum is negative 0.21. There, that's what I should have done a second ago. So you can see over here on this edge, we've got really low amounts of material, and then down here we've got a lot of material. So this is just the color representation of the parts. This is just being projected from, projected from that plane. And so you can just see the form of that top planar surface there. I'm going to turn my CAD back on. I'm going to bring this guy back out. Well, actually, before I do that, I'm going to make my CAD invisible one more time, and I'm actually going to make a report page out of just this. And I'm going to turn my cylinder 5 invisible here just because that was another GD&T that I was building, and I just want to make a report page of just this planar surface here. Organize these up a little bit, which I can do in my report page as well. And then click on my Create Report Page button at the top of my workspace. Again, brings us to this Create Report Page button. Click on the center of that screen, gives the option to adjust these things, just making it look a little pretty. Say okay. And we can call this, actually let's name this Flatness. Check. Planar surface. So that's what I'm referring to. My planar surface is that surface right below those GOM letters. So flatness check, planar surface. Okay, there. And so once again, we've created a very basic GD&T check. Pretty easy, pretty quick, lots of different visualization options for this. And again, if you're really working on GD&T a lot, you'll know a lot of how to use a lot of these callouts. If it's something that you need to create datum systems for, I'm going to make my CAD exclusive here. You can create datum systems just as easily as your callouts by using this create datum system. And then you've got the same options down here. We've got datum 1. That guy there. Plane 4, that's fine. Plane 5. And plane 6. You can name those as you go. I'm just naming them the planes, but if they have specific datums they're associated with, you can name them datum 1, datum A, B, C, and then you can name your datum system in here. And then much like traditional GD&T, the order of these datum systems is important. So just keep that in mind if you're practicing this or if you're getting into GD&T. So this datum system creation sequence is significant. You can also tell here the remaining degrees of freedom. You want to make sure that you've got all 6 of those degrees of freedom locked up. We can go ahead and create and close that guy there. And now this is our basic datum system. Again, just kind of arbitrary, but a good exercise in showing you guys how to use that GD&T Quick Creation menu. So I think it's a slick function. I'm glad it exists in the software. We use it all the time for projects that we work on. And so I think that if you end up using GD&T in the software, give this a chance, give it a try, and I think you'll find it to be a really useful way to build GD&T really quickly. So now that we've gone over some basic GD&T stuff, let's flip on back to our PowerPoint here. Let's see what's in store for us. So again, we went over that GD&T Quick Creation menu, which is just at the top of our screen. In our inspection workspace, we've got our list of different GD&T callouts in here. We built a couple basic GD&T callouts, and then we also created report pages of those callouts. So I've been creating report pages as I've gone through this training. If you have or have not, that's okay, but we are going to jump into, we are going to jump into a live demonstration of report page editing. So we've gone through a couple of our different workspaces, and our last workspace in our software here is going to be our report workspace. So we started in our start screen. This should all be pretty familiar to you. We've been doing most of our inspection in the inspection workspace here. We jumped over to our mesh editing to clean up our mesh a little bit. Make my CAD exclusive just so my screen's a little bit less busy. The last one that we're going to touch on here is our reporting workspace. So our reporting workspace is, if you remember from day one, the third step of the ATOS measurement process. So you've got the data acquisition part of it, we've got the data inspection part of it, and this our third part is the reporting. And this is where you're putting together all of the data that you've collected. So if you're trying to show off the scan data that you've collected, or you're trying to show off the inspections, or you need to send out your measurement results, all that is going to be put together here in our reporting workspace. So similar layout to what we've used before, or what we've seen before in the software. So we've got our sort of Explorer-esque function over here. We've got our sort of sub-Explorer down here, and we have our main screen. Again, we've got a different colored work bar along the top. So if you're flipping through the software and I've lost you, just go ahead and look at that colored work bar. We're here in the report workspace. If you flip through them, they all change colors here. Our report workspace, we've got a nice purple color at the top here. So let's go ahead and take a very basic tour of what we can find in our reporting workspace. Over here, we've got our report styles, and so we've got different sized sheets. if you need to plot this on larger paper or different size or styles of paper, you can use those report style templates over here. I think I've just been using A3, but when it's all digital like this, it doesn't necessarily change much. So we won't worry about that too much. In each of these styles, we've got different blank report page templates. And so we've been doing a lot with our 3D page, and this is just a very generic page to show off what you have in your 3D view. And so that's, we've been doing a lot of our dimensional checks in, and I think we may have done a surface comparison and thrown it in a 3D view, but there's also variations of that 3D view. So if you want to show that 3D view and that pip view, we'd use that very basically when we did those cutting planes earlier. And if you still have a report page of that cutting plane, I'll show you how to show a pip view of that. The pip is just a picture-in-picture, and it's just a small representation of the whole part, which sounds a little bit confusing, but we'll look back at it in the software and hopefully it'll clear things up for you guys. We also have the 3D and table report page, and this is kind of slick because it shows you your 3D picture up here and then automatically populates a table of data for any of the results that you have in your 3D view there. So we'll make a report page of one of those here in a second. Our 3D and diagram is a little bit more based off of trending analysis. It shows you the 3D view of the picture and then how that data changes over time. Our 3D allows you to have two different 3D views here. So if you've got two halves of the part and you want to show two sides of the part or your mesh data or something, you can throw one side into one 3D view and then another in the other. And then we've got our section views. So we got our regular section and then a section and section, much like our 3D. And then we have a little bit more of our generic reporting types of pages. We've got a title page, which we'll definitely throw in here because they always seem appropriate when we're sending out reports. And then our table of contents is cool because it automatically updates all the contents and our page numbers depending on how you shuffle around this report. So below our list of report pages is our actual list of report pages that we've created in the software. So we can flip through each of these and you can see what we've added. So each time we hit that create report page button in the top of our screen, we have created a report page in our reporting workspace. And so some of these have been through the last couple of days. So as we flip through these, we can see what we have in them. And again, if you hover over this, you've got that pencil to edit the content on them. If you need to rearrange where these are, you can shuffle these around so you can change the order of these guys. And then just cruising across the bottom of our screen here, we've got a bunch of different options on how to arrange the different items on our report page. So it's pretty fully customizable. I'm not going to get too much into how to resize things and link things together, just because I don't want to end up screwing up my report page, and there's a lot to unpack there. And I just think that it's probably a little bit better to explore that on your own if it's something you think you need to change. And again, we can always help you guys with that as well. I personally, I shouldn't speak for everybody. I personally just use the default templates for these and then adjust what my content is on each one of these, adjust the titles. And then a lot of this information around here is going to be automatically updated with what version of the software you're using and the alignment. So down here, we've got pre-alignment. This is the alignment we've been using for inspection. We've got our units, page number, what version of the software we've been using. So it's kind of good information to have right there on your report pages. So again, those are your tools down here in the bottom. If you want to add like your company logo or something, you can create an image and throw that up here. That's what this GOM logo is here for. So a lot of different cool options for customizing these report pages. Definitely a lot of tools you can use there. Along the top here, we've got our alignment options. I believe if we change these and we add more report pages, it's going to be based off of this alignment. It's not going to change what we have in our page here. So I'm in our 3-2-1 alignment, but this is still created in a pre-alignment. So that's something you can do to adjust your report pages if you're building them in the future. And then I think that's probably pretty well the basics of what we have in our screen here. Also, if you hit tab, you have we have our properties menu again, and you can adjust you can adjust some of the basic options in here. I mean, the default title and some of these other options. It's a little more limited when you're in the report workspace. Let's go ahead and try creating a couple more report pages and polish up our report a little bit. So again, I said I wanted to add a title page in here. I'm going to click and drag that guy right in here. I'm going to add it right to the top. And as soon as you add a new report page to your existing report, it's going to want you to edit the content on it. So in this case, we have our title page. And right now I just have this in my 3D view. So let's go ahead and edit our content here. And on let's make ours, I'm going to bump out my Explorer on the left side of the screen here. So again, if you hover over to the left side, we have these double arrows showing up. We're going to click on this guy. And instead of having our CAD, I'm going to expand my part. I'm going to make my mesh exclusive. So just clicking and dragging this guy out here. I'm going to size it up, the middle scroll wheel button. I'm going to size this guy up here, just make it look all snazzy. You're welcome, Stephen. We've got our mesh here on the middle of our screen. And this, you can choose anything for your title page. Doesn't necessarily matter what it is you want to make in your title screen. I always just choose either the mesh or the CAD. I think it's a good description. It lets people know really easily looking at the report page what the content of the report is going to be. You can make it your surface comparison. You can make it a dimensional call-up. There's no rules for this. Again, I just personally like to use either my mesh or my CAD just because I think it's a good description of the report. And then I like to make it fill the page, little bitty space between those. Hit OK. And then this is our report page here. And then we can title this. So we can call this GOM Inspect Training. And then if we want to change this from portrait to landscape, or hot dog to hamburger, if you're raised like me, you can change the orientation of your page like that. Hope I'm not freaking anybody out by switching that around so much. But I'm going to leave that on my portrait view here. So again, you can change the outline of that. And then if you're printing that out or if you export that as a PDF, it will be oriented in your viewer or on your pages in that way. And you can change the style of this in here if you want to. I'm just going to leave this as a title page. And then we will go ahead and adjust these, but we have to adjust these features outside of this dialog box here. So we're going to hit OK. And I'm going to go up here in my workspaces menu or my workspaces bar, and I'm going to define project keywords. So let's go ahead and adjust that. And we have this list of terms and dialogues that we can fill in if we need to. If you want to edit those, you can edit those. It can get a little bit busy if you're not careful. So just make sure that you're experimenting and saving your progress as you go. And then you can just fill in this information. My name is Gear Carpenter. And your, whatever your part number is and your location, company, yada, yada, you can fill out this stuff as completely or as incompletely as you want. It's all going to be up to however you guys, whoever you're reporting to is going to determine how much you need to fill out here. GOM block, we've got today's date, which is the 11th, and then all this other various information. Version GOM Inspect 2019. Okay, and so that is our project keywords. Again, that's up here. It's our key icon in our workspaces bar along the top of our screen. And as we filled out that information, say OK, and it fills in the information here. Now, as I hover over this, you can see that these are different boxes that we can adjust and move around if you want to sort of adjust your screen a little bit. So that is our title page. Let's go ahead and move down to a table of contents. Go ahead and click and drag this guy back in here. You can also, before I do that, you can also change the orientation here and drag that down. But again, oops, messing all my stuff up. I'm just going to leave mine in portrait mode. I think it looks nicer for the table of contents, but again, there is no right or wrong answer here. So however you guys want to format your report pages, definitely go ahead and adjust those as necessary. Drag my table of contents right below my title page. And I always just name mine doc, table of contents. And again, we didn't fill out anything in our table of contents here. This has all automatically been updated with what pages we have in here. So as we adjust where things go, our table of contents is automatically updated with wherever that information is, and then its associated page number. So we've got our page numbers over here on the right side of these options, or on the right side of these page buttons here. And then again, in the bottom right of your screen. Now, if you do get to a page that says outdated data here, outdated data, I don't know which one's more right, data or data. But if you do get to a page that says outdated data, then you can recalculate it up here. Oh, I messed with myself. Okay. Well, generally you'll be able to update this page. It just means that something related to this has changed, not necessarily the actual element itself. And so when you report this, it's not going to have this outdated data screen here. It's just going to be this, what the screen looks like. To get rid of that, if you haven't changed anything or if you're confident with what this page looks like, you can go in there and edit the content, adjust this guy a little bit, make it look nicer. And okay, can't do that either, dang. Running myself into corners here, sorry guys. But what you can do is right click this and lock your report page, and it locks the visibility of it and then gets rid of that. In this case, you can't change what's on it. You can still move it around, but you can't adjust anything on it. And that will lock the view of it. Alternatively, if you want to go through and make that page again, let's see, hopefully I don't get myself in trouble again. Restore 3D view from report page. There we go. So what I did was I took my page here, and I'm going to restore 3D view from report page, which means that whatever report page I have, except for the table of contents, I would imagine. Yeah, it's grayed out here. Whatever page you have here, it's going to automatically bring to your 3D view in the inspection workspace. I think that's a kind of a slick tool because you've got a whole report page and you just want to adjust something in 3D view, you can go ahead and do that. You can go ahead and make another report page from this guy. Say okay. Angle check. Oh, that was a title page, which I didn't mean to do, which is a good segue on how to adjust what those pages look like. So again, I just made that that report page back into my 3D view, and then recreated a report page of this. I'm going to go back to my report page workspace. Sorry for jumping around so much. And I'm going to shimmy this guy back up here under my other angle check. And I'm just going to delete this guy because I want to get rid of this outdated data. If you want to just leave it in there and you're okay with the visualization of it, you can right click this guy and say lock report page. In my case, I'm just going to delete it. And if I want to change the visualization of this because it's a title style, we can just click and drag this guy over it, and it'll override what type it looks like, which is kind of cool. Allows you to update this report pretty easily. So you can make this guy a 3D in table, and it's going to have your 3D view of the part and then your table of geometry or inspection results down here. So if you find something with a little bit more, say this flatness check, we can make this a 3D table, and it will tell us each of these deviation labels and what their results are, and it will still show us a representation of what this flatness check looks like. So kind of a cool way to update your report pages really easily. And if you want just table results, you can grab your table page here, throw that down there at the bottom, and then you can go in here to edit. And you have this 3D view, but really what you're looking for is these table results here. And right now it's just showing us the angle one from our 3D view. But if you go to your, what looks like a little basketball up here, list all excuse me. List all inspection values. You can click on this guy, and it shows you all of your different inspection values from your project. So if you want to report out all of your different inspection values, you can do that. And then we can say, okay. And now we have this table value. We can call this inspection values complete. Now, sometimes what you'll see is this table is a little bit longer than what can fit on one report page. And so you've got these two double arrows down here on your actual report page. Sorry, I'm losing my words, a little report page style down here. If you click on this, you can see all the report pages that are included in this table. So you've got all of our different inspection values from our whole project listed out in this table. And you can adjust those values again. Oh, I lied. Dang. Sorry, guys. I'm sorry to keep telling you that you can when you can't. But if you were to build it originally the first time, you can adjust how you visualize this information by dropping down this list here. There's nothing in with the trend right now because we haven't gone over that. We'll go over that later though. But we also have just our statistics information, details, overview. We just had our overview, and you can organize your different results in here depending on, again, we have all of our inspection values, but if you were to make just certain things visible, it would only make the inspection values for what you have visible here in your table page. So I'm just going to say cancel. So we have our basic report here. So let's jump back to our PowerPoint real quick and just recap some of the things we've gone over and make sure that we're not skipping out on anything. So again, we went to a report page to edit our actual report. That it has its own workspace, top left of the screen. We went down to our report workspace. We took a basic tour of the options within our reporting workspace. So we've got our template explorer up here, much like our regular explorer in the inspection view. We've got the report page explorer, which is down here, shows you all the report pages that you created. You can filter your report pages by tags. So if you have separate tags that you're creating report pages out of, that will be, I believe you can also tag report pages. I don't use that very often, so don't hold me to that. We can, if it's something you think you'll use, we can go over that. Area for the large review of report pages and templates. That was just that workspace that you have here in the center that when you select your report pages, it's just going to show you what the report page says. It also allows you to edit that content. Our toolbar at the very bottom for adding certain connectors, certain images, and different functions within your report page. And then we have our properties of the report pages and templates, which again, you can access that by bumping over to the far right of your screen. And those little two arrows come up, or you can hit tab. The hotkey for that is tab. So we've gone through the process of adding a couple of different report pages into our project here. So we drag and drop a title page into the report. That was one that we put right there at the beginning, and we edited what our part looks like in the 3D view. Again, you can change the orientation from portrait to landscape. I believe portrait is default. And then you can also change the style of your page down there at the bottom. And then once you create that for the first time, you can edit the 3D view to orient your part in a certain way. And then we adjusted those project keywords by going to our key icon at the top of our screen there. Again, if you hover over those functions, they'll tell you what they do. In this case, this is define project keywords. This brings up our list of different keywords that we can adjust within our title page here. Excuse me. You have that edit button down there if you want to edit the arrangement of those dialogues, or if you want to delete some or add some of your own. I would recommend that you, if you think you need some more or need some adjustment on these pages, go ahead and explore what the limitations of the report pages are. We also added our table of contents page into our report page here. And so we just, again, click and drag that guy down, kind of a cool different little feature that allows you to automatically see updates that you're doing to your report page. Once you add that table of contents in there, it sort of does its own thing. We always like to have those table of contents. It makes those reports just a whole lot easier to go through. And so that kind of brings us to the creation of our report page. So let me just shimmy on back here and just recap over some of the basic things we've gone over just because we got a little bit of time. We're a little bit ahead of schedule. Talking too fast today. Gotta slow down. So we're in our inspection workspace here. We were just dragging some of these report pages onto our screen from our Explorer over here. And again, we've been using this create report page button at the very top of our screen. You've got a couple different ways to create report pages. You either have that button, which we've been using frequently, or if you want to report something that you've been building, you can click on your report. Sorry, I got distracted. The second way to create report pages is if you want to just click and drag one of these blank tables or these blank pages into your screen down here. You can just go click and drag this guy down into it, and then it's automatically going to grab what you have in your live view in your inspection workspace, and we can adjust this. So we have just our section cut here, but if we want to show something else, we can add our different elements that we have in our project. So anything that you have created so far, you can't create anything new at this point, but anything that you've created so far, you can drag out into your project here. So we can do our RPS alignment. Maybe that'll allow us to, and that just changes the alignment though. Maybe not the points that we have. We can do this. Oh, messing things up here. Let's try this one more time. Nominal elements, points, surface points. So we've got each of our points for our alignment in here. And then we can make our deviation for these guys visible. A lot of clicking, a lot of clicking. There you go. You have multiple things selected on your screen, it'll move all at once. Okay, so enough murmuring to myself. That's just the basics of how you can create report pages one of two ways. Again, that create report page button at the top of the screen, or if you go into your report workspace, click and drag down into here, drag it down into your actual report page list down here, and then you can adjust what is on your screen. And then once you've got those pages, adjust where you want those, delete them out if you need to, change the names of some of these guys. Reconfigure report page. I'm not going to mess with that right now. So, and again, I know we're a little bit ahead of schedule, but I don't want to sit here and just try and talk myself into circles. We can just go ahead and bump into our halfway break here. And then when we get back, we're going to have our guest speaker, Darren Marsh. He's going to jump in and show us his created report page that he's made all the different inspections that he has in the free version of the software. So we're going to jump into introducing our guest speaker, Darren Marsh. Darren Marsh is another lead application engineer with the company. He concentrates in injection molding, but is fluent in a lot of metrology. He's been with Capture for about 6 years. And so we're going to pass control over to him, and he's going to present a report that he's put together with, excuse me, the free version of the software. And so I'm going to have Sean switch over to Darren.
Hello, everyone. I am going to just go through a layout that I did on the GOM block in the free version of the software. And okay, can you see my screen?
Yeah, we got it.
Okay, so I'm going to put this in presentation mode here. And this inspection report I created just using the free version of the software. So just to go through page by page, there's 29 pages. We actually have a blueprint that goes along with the GOM block. Table of contents, just like Garrett was showing earlier. This is a slide with just the scan data, the actual mesh of the part, 700,000 points of data. Another slide showing the close-up of the mesh structure. This slide and the next slide are showing a comparison between the global best fit alignment and the datum alignment. So since we are able to scan the entire part, we can create, we have the entire scan of the full field of the part. We can actually inspect datums, which can be a very powerful thing. So if you see on this page here is an alignment to the ABC datums, or the ZYX we have here. So what this allows us to do is inspect the best fit of the form versus being locked into your datums. And instead of maybe saying, let's rework this entire mold to make our form better, we could just maybe shift our datums by these numbers here, these deviations from the datum alignment. And just a basic surface comparison. Probably one of the best things you can look at in this technology, is showing you what the part is doing. There's a lot of options that we have where we can edit our surface comparisons to look differently. This one is the standard continuous colors where they just kind of blend into each other. Again, all of these, this scale can be changed to match your tolerances. So this one is 3 colors, showing areas that are low, which would be blue, or areas that are proud, which would be red. And then this is an actual pass-fail with the tolerance set to 0.25 millimeters. So this is showing areas that are green are within our tolerance. Areas that are yellow are kind of warning us that we're getting close, and then red is out of spec. This next one is an inspection section, just a slice in the Z plane at 26 millimeters with equidistant deviation labels created 35 millimeters apart from each other. And then this is the same exact inspection, but with a clipping on the CAD right at the that 26 millimeter section element. And then this is another inspection section at 130 millimeters in X, which is, you can see where that is on the part now with the clipping plane. Okay, so getting into the actual layout, this, and I'm going to show you some tips and tricks after we go through this, but this is an import of a JPEG of the blueprint that I actually ballooned this in the free Adobe Reader with using the draw circle and text comment. So you can actually balloon your prints in Adobe Reader. Took a screenshot of it and then imported the JPEG into a blank report page, and I'll show you how to do that when we get into the tips and tricks. So there's 2 pages to this blueprint, and I laid out the entire every dimension on the print in the free version of the software. So I'll just go through those quickly. There is a GD&T datum system, and I think it's on this page here, DE. And using the GD&T Quick Creation, I created the datum system and then just showing a report page showing that datum system, and that's another thing that I'll go over when we're done looking at this report. Okay, so balloons 1, 2, 4, and 5 from the blueprint. So, true position and size of those cylinders. Balloon number 3 was cylindricity call out. This is cylindricity showing a color deviation to the geometry of that perfect cylinder with a min and max deviation label showing where the high and low points are. And balloon 6 and 7, some diameter checks. In this case, I changed the CAD to have a transparency on there, and I'll show you how to do that. Balloons 8 and 9, parallelism and an angle check. Balloon number 10 is a profile. It's a form-only profile, so it's a profile of 100 microns to itself. And I did if you look on the bottom left corner, I just did a local best fit of that surface to itself. And I also put the color representation on there with min and max labels, and you can see kind of a histogram on the color bar on the right. This one is a diameter check of a hole using the measuring principle projected offset section. So it's going to sample that top surface, go down inside, cut a section in the hole, and then project it back up to that top plane, kind of similar to how you could measure a hole on a CMM using sample hits on the surface. This is a really nice thing that we can do in our software. If we have two opposing planes and you want to measure the distance between those planes, a lot of times it's hard to tell. You know, if you take your point here, you take your point there, you might get different readings depending on where you take your point. So with this GD&T Quick Creation, we can just control click the two planes, outer planes, and it's going to give us that minimum and maximum distance between those two planes and show you where those are with the arrows. And yeah, that's another tip and trick that I'll show once we go to the part. Here's some linear distance checks and a flatness check and a diameter check. So these, I think I just kind of tried to make it mimic that section AA view on the blueprint. Again, some more linear distance checks. I made the CAD model completely transparent, so you're just seeing the wireframe on there now. And those same exact checks, but adding the table report, which kind of looks, you know, like a CMM report. And this next one is it's a flatness check with min and max labels. Some GD&T parallelism checks and a true position. This label, I believe it's 27 and 28 are composite GD&T label on the blueprint. Balloon 30 is another linear distance check. I think that's it. So if we go to the inspection workspace, here's all the elements in this report. And nice thing about our software is you can just drag your report page and it'll put you right back into that view. So a couple of the things I wanted to show are how to make your CAD model transparent. So if we go and drag the CAD model into the graphic view, it'll show it exclusively, or you can hit the hotkey E for exclusive and hit tab or click these double arrows on the right side of the screen, and that'll bring up our properties. And this is going to show us our properties of any element that we have selected. Right now I have the CAD model selected. So if I go to display, I can change the transparency. I can turn off the wireframe. And this is nice for stuff like when you have leader lines that are going through the part. So if I turn the transparency back up on this view here, you'll see like the leader lines are they get blocked by the CAD model in some cases. So it's kind of nice sometimes to maybe change the transparency. If you have deviation points all around, say the outside of this O, you'd be able to see the ones on the opposite side in that case. You can do one shot instead of doing multiple report pages to get the backside. So the next thing I want to show is how to add an image to a report page, like your blueprint. So what you do in this case is you can right click here and say create an empty page. Just pick the format that you want. I'm gonna make this a landscape letter size. So I have a blank page. And then I can go and grab my JPEG and just drag it in and hit report image. And now I have my blueprint, my ballooned blueprint added into my report. Okay. Next thing I want to show is this GD&T Quick Creation. So I'm going to go exclusive on the CAD model. And in the inspection workspace, we have this this drop down here, GD&T Quick Creation. I'll start with showing, I'll just create a datum system. So with this dialog open, I have my datum 1, 2, 3, or primary, secondary, tertiary. I can pick features in here, or I can click this little blue button that will automatically, I can control click, or not control click, just, control click. So let's say at this top plane, we'll call this datum A. And I'm going to click this create fitting element button again and control click this front plane, and we'll call this B. And then I will do the same thing for our third datum and control click the plane on the side and call this C. C1, since it's already has an, I don't know if you noticed, the software always tells you when there's something wrong, which is really nice. In this case, it's telling me that something is already named datum C. So I'll just call that C1 and hit create and close. And now I have a datum system that I can use to reference for GD&T callouts. So maybe there's a true position to ABC. So it makes it really easy to create datum systems just by clicking those features on the CAD model. That'll also automatically create the actuals that are linked to the nominals that you click on. And not to get too heavy into GD&T, but we're also using the fitting algorithms that are required by the standards, like a Chebyshev type of fit. So the calculations that are involved in that are something that you need a lot of points to actually create those Chebyshev type of fits. And it's really difficult to do that on a CMM where we have so many points. We can actually follow the standard of those fitting algorithms. Okay, so the next thing I want to show is, I want to show you that linear distance between two planes. So I could create, say, an outer disk caliper check and check this overall width of this part here. And my selection area, I can make those disks big enough to hit the whole outer edge. And that'll give me a distance that way, but that's just going to give me the high point. But if I go up to my GD&T Quick Creation, I can go to linear size, and I'll control click these two outer planes, and really quickly it gives me the highest, the largest 2-point distance and the smallest 2-point distance. And it shows me where those are, which is pretty nice to see that. Okay, and then I think Garrett did some flatness stuff, but I'll just really quickly do a flatness check here. Hit OK. I'm gonna click on the flatness icon on the label here and hit my properties window by hitting tab or clicking this double arrow and show the color deviation representation. And I'm also going to bump this scale down so we just see a little bit of color in there. To go below 60 microns. Okay. Now we see some color deviation, and then to get the min and max labels, you actually have to select all points of element. So when I right click on the flatness here, you'll see that the flatness color map is kind of, it gets gray, which means it's selected. And then I can open up my eye inspect, or control right mouse button is the shortcut to get to that really quickly. And then I can control click minimum and maximum deviation. So it's going to show me my highest and lowest points on that flatness check. So just remember, if you want to put these deviation labels on there, you have to select all points of the element. Kind of like this point-wise inspection for equidistant deviation labels. So if I wanted to, I could select an area right here. It's going to turn gray and say, give me some equidistant deviation labels every 1 millimeter. I have a grid of deviation labels here. Okay, Just a couple other little tricks. How to drag those leader lines. I'll just create a quick distance between, say, these two circles here. Construct a distance, 2-point distance between these two circles. And I'll apply a measuring principle to get the actual distance. And distance check square to X. So now I have my my distance created, and then I dimensioned it to X. And so how do we get that that leader line to pull out? We click where it says LX there, and you'll notice this little tiny blue box pops up, and now we can click and drag that little blue box. And then hit make the that invisible, and now we have a nice clean dimension there. I'll do one more. Just a cylinder here, fitting element, which will create the corresponding actual and link them. And then a diameter check. Click this little diameter symbol here, and then the blue box comes up, and now I can drag my dimension leader out and make this one invisible. And you notice that those leader lines are getting blocked by the CAD model, so we can select the CAD model just by clicking it and then make this transparent. Now you can see your leader lines. Kind of these things are, they act kind of weird. If you drag them when you're square, so we're square to the Z plus view, they'll just move straight up and down. But if I rotate this now, this leader will move like up and around. Okay. In our software, we can create a material thickness color map. Not really going to get into that. It's a little complex, but we can create color deviations for how thick your wall thickness is, maybe on like a casting, or we can compare it to the CAD, or we can do the actual thickness, and it'll show you if it's kind of a blue color, it'll show you the wall thickness is a little bit thinner or thicker. But I will show you a really quick way to do a material thickness check as an inspection point. And it's kind of just like throwing a point micrometer on there and measuring material thickness. So if you go to Inspection, Analyze Surfaces, Material Thickness Inspection Point. If I can control click anywhere that has thickness to it. So say the wall of this O, and it's going to use that vector from where I clicked and go straight through and give me that the material thickness at that point. And you can create as many of those as you want. So basically, just like throwing a virtual point micrometer on there and giving you your material thickness. You can see the other options in here for color comparisons too, which is nice to see, because that'll give you the whole color map on the model. And then we can also do draft angle color maps. So if you have a plastic part that's that's got draft in there. You can actually put a color comparison of all the draft and tell it what's the demolding direction. And I think that's it. I think I have one more kind of trick here. If you do find yourself using, say, some functions a lot instead of keep going to these drop downs, you can just drag this function up to this toolbar right here, and now I can construct surface points instead of having to go through these drop downs. So you can put as many things on that top bar as you want that you're using a lot. So this free software is very powerful. You can do datum systems, GD&T, alignments, color maps, all in the free version, and make a pretty elaborate inspection report. So yeah, thank you for your attention, and back to you guys.
Excellent. Well, thanks, Darren. I do appreciate you helping us out with that. So let's go ahead and continue on with the last couple of topics that we've got for our training here. The next thing that I want to show you guys is a live demonstration of some of the different features between the GOM Inspect and the GOM Inspect Pro. Now, again, we've been using the free version of the software all week, and you've been able to sort of see what you can do. Hopefully you guys have got a good idea of what you can or cannot do within the software here. You can do a lot of those different inspection functions. It has the GD&T built into it. It has an airfoil inspection built into it, flush and gap inspection with that curve ability, importing and exporting different model types. But the professional version of the software does come with a lot more functionality in terms of parametric inspection and then creating some templates and stuff. And so this is just a brief list of the options, or the the functions that are available in the professional version of the software. So again, that parametric inspection, which allows you to go back and edit your geometries you've created and have everything else be updated off of that. We've got our importing native CAD formats, importing the PMI files, our digitally assembling, and we've got scripting options within the professional version. And then we've got our VMR, which is what we can use to run our automated solutions, which we have not touched on at all during this training. But if it's something you're interested in learning about, we'll be happy to tell you about that. If you are interested in trying the ATOS Professional, GOM does offer a 30-day trial. At the top of our screen, you may have noticed there is the Try Professional button. You can go ahead and hit that button, and it'll open up this dialog box for you. Just looking for some information about who you're working with, what kind of projects you're working on, and then they will send you a license for 30-day free trial of the software. So that's kind of slick. It'll give you the full, complete software for 30 days, and it'll unlock all of its potential there for you. So next, we want to get into some basic demonstrations of the bigger functions that are available within GOM Inspect Professional that are not available within the GOM Inspect Free. The biggest, well, I guess not the biggest, but first and foremost, we're going to go over some trend analysis demonstration. Now, trend analysis is a super cool tool within the software. Excuse me, tripping up my words here. It allows you to put together a bunch of different mesh files and compare them against a common CAD. And so you can see how these parts compare back to each other or back to the CAD, and you can see how they trend over time. We work with a lot of automotive companies, and this is good for validating dies and molds and checking tool wear over time. And so you can create these really cool trend analysis type projects. And I actually have one here in my ATOS Professional software. We'll go to inspection. Now, one thing you might notice is that there are a lot of very similar tools here in our professional software compared to our free version of the software. And it's saving the copy. It's automatically saving my software here for me real quick. But very similar looking screen. As you'll notice, we've got all of these same drop-down bars along the top. We have this same toolbar along the top here for our inspection workspace. We've got our Explorer on the left side of the screen. We've got our label on the right side of the screen showing off the trend values. And then What's new about this one is that along the bottom, we have these different stages in our projects, and these stages correspond with a new mesh file that we've imported into our project. And so each stage we jump through, you can see that it jumps to a different stage on our labels here as well and shows us those corresponding values. So we've got a bunch of GD&T callouts on each of these guys, roundness, position, and this is just our drill housing sample data. But we can pull out some of these report pages, and apologies, it's all in German. If you speak German, you'll understand this. I unfortunately do not, and so it's all kind of foreign to me. But this is also kind of a heavy project. I'll just run through here real quick the differences in our report page. So we've got this whole canned project available to us, going from the actual scanning of our part to aligning it with our CAD, and then showing us a range map across our whole part, showing us how the range changes across these 11 different mesh files. I was thinking, my computer sounds like a F-35 here, so forgive me, it's taken a second to think. There's a lot of data in this project. This is data heavy parts, and then we've got a whole trend project in here. So forgive me while it works through this here. But anyways, this trend analysis, again, pretty cool functionality within the software. It allows you to look at all these different mesh files together. And so you can bring in one part and you can do your whole analysis on this mesh compared to your CAD, do all this inspection, and then bring in your subsequent meshes after that, and then do an analysis and copy essentially all of that analysis from that one part onto the rest of these parts here. And so you can see how these parts change over time. And this is our range. So across these 11 parts, we can see how the range changes on average across this whole part here. We can throw in some deviation labels on this guy, just see our range here. I'm just going to jump to a reporting so I don't get hung up on trying to process a bunch of this data here. But very similar layout to the rest of the software here. This is just a trend information here. We're seeing how each of these callouts on our part changes over time. But our reporting workspace is identical to the free version of the software. We've got all of our different report pages up here. Again, we've got a couple of different excess workspaces in here. Actually, I can do this. But we used our start and setup, and we are digitized as what we would use to actually scan in the software. You cannot actually collect data or scan within the free version of the software. We've got our live tracking, photogrammetry, and VMR, which are modules within the software that allow different functionality with different hardware. Our VMR, again, is what you would use to run the robots, the scan boxes. And we've been using inspection, reporting, and mesh editing. So some of these should look relatively familiar to you. So this is just our trend analysis project. This is just a canned project. If you guys are interested in finding out more about the trend analysis, or you'd like a copy of some of these projects, or you want to see some work done with the trend analysis, we'd be happy to help you out with that kind of stuff. It's, again, a really powerful functionality within the full version of the software, but unfortunately not available within the free version of the software. What you can do is you can open trend projects in the free version of the software, but you cannot create them in the free version of the software. So jumping back to our PowerPoint here, again, this is just a screenshot of that project that we were just shuffling through. We have our bottom of our screen here, our 11 different projects that we were cycling through to see what those parts looked like. So it's 11 of the same mesh loaded into one project. It allows us to do an analysis on all of those compared to the CAD. Just another follow-up with that trend analysis functionality. View and further evaluate trend projects with Atos Professional. So again, you can open up those trend projects in the free version. So if it's something you guys are interested in just looking at a project, we can happily send over a project for you to take a look at, but you won't be able to do much with it as far as editing or changing the data. You can't add any more scans into that project. So another function of the professional software that we've gotten a couple of different questions on, so I'm kind of anxious to show you guys this portion of the presentation, is our project templates. Now, the project templates are a really powerful part of the professional version of the software. Our project templates allow us to save a shell of a project. So I'm going to go back to my professional version of my software here, and I'm going to go to my start menu. And this should look very similar to what you guys see in the free version of the software. We've got these same 6 tiles in the software here. So again, the free version and the professional version, they're not worlds apart. There's just some added functionality in the professional version of the software that's not available in the free. And so I'm going to go to project templates, which if you remember said in parentheses, professional only or something of the sort when we were going through the tour on day 1. I'm going to open up my project templates. And in here, I have got a project from the GOM block that we've been working on. So I'm going to go ahead and open up this project. It's going to ask me if I want to delete my project that we're working on with the trend. I don't really necessarily need that, so we'll get rid of that guy. And I'm going to open up this GOM block project here. I'm going to show you what the difference is with our templates versus just a regular saved project. So we have this GOM block, which is incredibly busy. I'm going to click on the CAD, make this guy exclusive. So we have this blank project, and I say blank because what templates do is it saves a shell of your inspection and your geometry, but it does not save a copy of the mesh in the project. And the mesh is a little bit more of the data heavy part of that file because you've got so many of those data points in there. So we have our GOM block in here. We've got all these different nominal elements. We've got a bunch of geometries and dimensions in here. We also have all of these tags that I've created before. So we have all of these tags for this part, distance checks and angle checks and GD&T. And we're seeing as we've got all of these nominal values, we have no actual value and thus no deviation correlated with those. So that is in essence what the template does is it saves this project in the software, but doesn't save your mesh. The benefit of that is that if you're scanning the same part that you've created a template for, all you'll need to do is bring in a mesh file. So I'm just going to bring in an actual, the mesh we were using earlier in the training, click and drag this guy into the software. I'm going to drop it in here and it's going to think about everything. And because I have my auto recalculate function on, it recalculated my entire project here, or everything that I'm seeing here. I'm going to let it recalculate while I talk. And so now we can see on my screen is I have these point-to-point distances, and now I have a nominal and an actual. So before, when I opened up this template project, we had just these blank inspections with just our nominal values, so we're measuring our CAD. And I had done this, I created this project when I had mesh in here. So we built this whole inspection on this part, and we had saved this as a template. And the idea behind a template is if you're going to measure more than, if you're going to measure and inspect even just more than one part, so 2 or 200 or however many, it's advantageous to build a template because it's smaller than a saved project. You can just open up this template and import in your new mesh, and you can recalculate that project, and it updates all of your inspections with all of that new information from your mesh file. So pretty useful. It's something we definitely use a lot of the time, and we definitely help customers build these because, again, if you're building any more than one of a part, doing an inspection any more than one of a part, you'll definitely want to use the templates functionality. Now, the obvious workaround to that is you can just save a copy of your project and then just open up that project, delete out the old mesh and bring in a new mesh, or there's a function if you bring in a mesh file here, you can replace the elements within the software and it will just take out that old mesh and bring in your new one. And that works as well to build your templates, or to build a sort of mock template. But the templates generally save smaller because you do not have that data heavy mesh file in there, and it's saved within the project files of the software. And so it's really easy to go to your templates folder here and just grab your templates. Usually you'll have a couple of, depending on how many parts you're working on. In our case, I've just got my GOM block in here. But it's really a nice way to get in here and save a version of your project that's really light, very easy to find, and you can just open this up, throw your new mesh files in there if you want to do an analysis project, a trend analysis project, and it's going to update all that information for you. And then you can make reports out of those. I don't have any report pages in here, but if you had report pages, it will update your report pages as well automatically so that you can have an automatically updated report So when you bring in your new mesh and you recalculate it, you can immediately export all of your new results for your new measurements. So templates are cool. We use templates really frequently. It's a very important and powerful part of the professional version of the software. And again, unavailable on the free version of the software, but it's important to show you guys where it's at so you guys understand the limitations of it. So the next thing I want to touch on in our presentation here is our skins. The skins function on the software functions sort of like a template for the software itself. I'm going to jump back to my software here. And at the very top of the screen, we'd mentioned this on day one when we were taking a tour of the software, is we have our skins menu here. And this drop down shows my list of skins. And again, this skins, I'm going to say it 100 times. I apologize for that. It's just a template for the software. It's going to determine what kind of options are available in your Inspect wheel, and it allows you to sort of configure the software to a way that's tailored to how you work or the functions that you use more. And so deformation and inspection are, I believe, available in the free version. Yep, deformation and inspection. And those are default in the software. Those are going to change some of the functions in the Inspect wheel. And then let's see, trying to think what it actually changes here. So Inspect wheel functions, I believe you can change default units, default decimal places, some of the default properties. And it's just, again, the template of how your software is going to be laid out. It also allows you to put in some report page templates, which is what we have our internal versions of the skins for. And if you go down to your manage skins function here, you can change which folders they're in. You can import your own, you can export them and save them. And so if there's a skin that your company uses or that you've created that you want to use on other versions of the software, you can export those skins so that you've got a little bit of continuity between your versions of the software. So that is the skins function. Also, there should be articles about them up here in the direct help. So you can read through this manage skins direct help article, and it tells you what will be saved in them. So label templates, legend templates, tables, report pages, keywords, all of these different options within your skins. So again, just a template more so of the software. We've gone over our project templates, which saves a copy of a project for you without the mesh. The skins is going to be just a copy of your software, essentially. So aside from those three big functions, we have the trend analysis, which is a professional function. We have the skins demonstration, and we have the project templates. So those are the three big functions, the big three differences that you'll notice immediately within the software. And then after that is our parametric inspection. And again, I've talked about that. I've sort of touched on that back and forth. And what that really means is that we've got these inspections that are built on points that are built on, we did a 2-point distance on these two cylinders up here. So we had these points built on the planes and the cylinders and all of these different geometries. And in this professional version of the software, we can go back and edit any of those geometries. We can edit how they're created or how they're fitted or what geometries are actually built off of. And then all the subsequent geometries built on that afterwards are automatically updated. We saw that limitation in the free version of the software, which we were to try and go back and edit some of our, functions here. So we've got this distance check. If we were to try and go back here and edit this, we're seeing down here at the bottom of our screen that professional function only. So we sort of lose that parametric functionality when we're confined to the free version of the software. The free version of the software is a really great introduction. It shows you how to find things in the menus. It helps you get used to the interface of the software. It's really a great tool. It's powerful enough for a free version of the software. And so it's really great to get your feet wet with this inspection software. If you get into practicing with this, you get proficient, you're feeling comfortable with it, by all means, go ahead and try that professional version of the software. And you can try out some of those more robust functionality that you'll find in the professional version. And then if you'd like to schedule a demonstration either of the software or of the hardware itself, we're happy to show you guys how all this stuff works. We've got web demonstrations available. I know with all the quarantine, things are a little bit crazy right now. And so we've got really great resources on how to demonstrate some of this technology online in the comfort of your home or your office. We also have facilities around the country, California, Washington, Michigan, Connecticut, and here in North Carolina. So if you guys would like to come to one of our facilities and see some of the technology, get a little more information on the software, meet face-to-face with some of the engineers or some of the sales guys here, we'd love to have you in. We'd love to talk with you. You guys can definitely reach out to us. But that sort of finishes up our demonstrations on day 3 here. So let's just do a quick summary of what we've gone over today. We've gone over our basic GD&T creation, showed you guys that GD&T creation drop-down menu at the very top, as well as that GD&T Quick Creation menu that's available in that inspection workspace. So super cool functionality there, makes it really easy to inspect all those different geometries. We showed you guys how to customize those report pages, and we showed you that really in-depth report page or report itself that Darren had put together. And we went over some of the basics of the GOM Inspect and GOM Inspect professional differences. So what you can expect to find different in the professional version versus the free version. And we went over some of those features in the professional version of the software. Got you guys a good introduction to what those features look like and what the professional version looks like. Just want to finish up by reminding you guys that all of this classroom material is available in that link that Sonia has sent out. We've got all those different folders with all this different information. She's going to be updating these again tonight with the recordings from today. I believe we'll be updating or uploading the that report that Darren put together, and then we'll also be sending out those certificates of completion to those of you who joined us for this week. I want to thank you guys again for joining us. And then finally, if you guys have any other interest in learning some more about the software, just wanted to remind you again about our YouTube channel. We're putting together a lot of good introductory functionality in those videos. And so a lot of different videos, they're nice and short, easy to get through with all of our stunning engineers. And so that's a good introduction to a lot of the topics in the software. Or if you're an advanced user and you're just looking to brush up on some of those individual functions in the software, head on over to that YouTube channel and check out some of those videos. It's sort of in its infancy, and so we'll be adding a lot more videos over time. You may recognize some of the engineers you've worked with in the company before, including myself. And then also there is the GOM Training Center, and that is where a lot of information from the manufacturer is going to be. So a little bit more in-depth knowledge. There's a lot of free classes in there, as well as some more advanced classes that will be available at certain times. And I believe they're going to do some live classes. There's also some in-person classes that might be available, but regardless, there's a lot of good videos and tutorials available on both of those platforms. So definitely recommend that you guys give a look at both of those. And again, if you want to reach out to either myself or Sean or any of the folks in our organization, you guys can reach out to that training at Capture 3D web address, and they can connect you with the relevant people. So I know we're ahead of schedule a little bit here, about 5 or 7 minutes, but that leads us into our day 3 Q&A. So that gives us a little bit more time to answer some of the questions that you guys have. So since it's day 3, this doesn't limit us to just day 3 content. You guys want to see things from the first 2 days. You guys have questions from some of the things we've gone over. If you have specific questions for maybe Darren himself, I'm sure he'll be happy to answer some of those questions for you. So let's go ahead and dive in. I know Sean has been collecting some of those questions throughout the day today, and so I'm going to let him take over facilitating some of those questions. But again, you can shoot those questions over to him in that Q&A chat down there. So thank you guys, and let's get to it.
Thank you, Garrett. So the first thing that I had actually was a question yesterday. Can you show the angularity callout and how that works within the software?
Yeah, I will show you angularity. Again, I don't claim to be a GD&T expert, so I don't want to try and make any assumptions about the really in-depth workings of this. We've got a couple of guys on our team here, Wade and Darren, who are a lot more concentrated in GD&T and their work history. And so I will show you just the basics of how to put together an angularity callout, and then just the basics of what it would do. But anything more in depth than that, I might defer to them if you have further questions. So I'm going to bring my CAD exclusive on screen here. I'm going to find Actually, let me find my angle check. Cool thing about these report pages here is that you can actually click and drag these out to your screen as well, and it'll make whatever was in your report page exclusive as well. So I've got my angle here, and my Sub Explorer is showing me everything that relates to what I have selected. And so I can easily find my lines 1 and 2 that I had made this angle out of. And so I'm going to make my angle 1 invisible. This is just built on my section cut that we made earlier in the day. So I've got my angle, or my line 1 and my line 2. And we will just give this guy a angularity callout with our GD&T Quick Creation menu. Angularity, I'm going to hold control, select my line 2. And angularity is looking for a datum system relative to, so I'm just going to make this relative to line 1. And I've got my red triangle next to this here. So I'm just going to control click line 1. Got our tolerance sources down here. We've got our standard up here. I'm not going to mess with standards because those can get a little bit tricky. We have a tolerance zone type, so you can make it planar. So you've got this angle here, and it has this tolerance band to fit within. You can make this planar or circular, depending on how you're calling it out. I believe it's called out on the drawing. And so that is sort of the basics on angularity. And you can create that there. And then we now have this angularity check right where we had our angle check earlier. So again, basics of GD&T, just using that quick creation menu. I'm just referencing that line 2, and our datum system is going to be line 1. If you have actual datum systems that you're referencing off of, you would want to go through construct, create your local coordinate system and create a datum system, or create a datum system through your GD&T Quick Creation menu. And then when you go to create that angularity, just reference that datum system.
Thank you, Git. The next question that I have is, can you export a 3D PDF of the model so it can be viewed with tolerance issues as a PDF model?
I'm assuming like a 3D PDF viewer, like an interactive PDF that you can share. I do not believe you can do that. I think that's come up before, and I say I believe because I know we had talked about that before, but I do not believe that is any functionality that software has. You can send out these projects, and you can use the GOM Inspect free version of the software as a sort of viewer, and so you can share these projects easily and for free, and you can view the report pages and the projects that way. But I'm almost certain that there's no way to export 3D interactive PDF files.
Okay. So next question I have is there any way to update a report page or overwrite a report page without having to go into the report workspace itself?
Like updating a report page. I know you can overwrite the report page. So yeah, I guess you can. I guess that makes sense. So if you have your report page drop down here, you can adjust what you're seeing here. If you adjust your page here and then just change what you want to see, and then you can change which report page was this caliper check. We can right click this and overwrite the report page, and it will automatically update that report page. And then we can go back into our report workspace. And where's my test caliper check? Yeah. So there it is. So now it's updated again. It's as long as you're confident that's what it's going to look like. You can't go back and update it in here. You'll have to just delete it and recreate it. So you sort of have that functionality to update it in here. But again, you lose it because the aspect ratio of that report page is a little bit different than your screen in here. It may adjust those labels or those leader lines a little bit and scrunch things together. And so you just got to be aware. You can do it. You just got to be aware of the limitations for it.
Okay. So another question I had, in the GOM Inspect software, can we do MMC and LMC conditions?
Yes, Yes, but it gets a little bit tricky. It's not nearly as easy as, well, LMC and MMC callouts in general aren't exactly very straightforward, and it depends on the standards that you're using. Yes, the functionality exists. It's built in. It's part of the full suite of GD&T. I would recommend that you know how it works and what you're doing before you go and start playing with it, though, because it can get a little bit tricky. Again, Wade and Darren are two good GD&T experts. They may have something to weigh in on and offer some more advice, but you definitely can do it. It is available in the software, but you'll just want to make sure that you're doing it correctly. Can you do it with, oops. There we go. Dang, I can't find my elements. Yeah, it's available. It's available in those creation menus when you go to create those parts.
Hey, Garrett.
Yep.
Yeah, right there. Show them under the quick GD&T. So you got, yeah, you're in a mode, hit escape. So the independency and envelope principles is what you're going to use to apply to whatever features, so that when you want to, let's say positionally, if you would use the envelope principle like on a diameter. And then when you're in the positional, click the position, see if it brings up, oh, you got to have it, select a circle or something. So then once you have a envelope principle, you then would be able to, the material requirement field would become active. And your dimension element would be that envelope principle. So just kind of a basic of how you would, what you have to do to be able to use max material, least material. And if they, you know, if they want further discussion, we can maybe get an email going and get a little deeper in that, put them in touch with support or whatever.
Thank you, Wade. The next question I have is, can I use pre-created templates in the free version of the software?
Unfortunately not. When you go to when you go to the start menu, you can't even open the project templates. It brings you to this article about the differences between Inspect and Inspect Professional. So templates are kind of a hard stop in the free version of the software. Again, you can sort of work around that by saving a copy of the project and then just opening the project, but you'll still deal with the same limitations in the free version of the software.
The reason being is that your project template is empty of data, actual data. And the limitation is you can't bring in actual data into a project and hit recalculate. So if you have a project that already has data in it and it's saved as a template, then yes, you could drag and drop it in. But it's because generally speaking, your project templates are intended to be empty, so that when you have new actual data set in the professional version, you would introduce that actual data and recalculate. And in the free, you cannot. So
Actually, I don't have any more questions that I got throughout the training.
Thank you guys for joining us for day 3. Concludes our second GOM Inspect online virtual training. It's great talking at you guys, and good luck with everything. Stay safe out there.
You have a great day.